Mhm. Okay.
Right, welcome everybody to the second edition of the AI for Creative Video Editing workshop. So we're just gonna give a few minutes for people to join. Yeah, just hang out with us for a few seconds. All right, let's get started. And welcome everybody who actually joined us today on a Sunday morning or night, wherever you are in the world. And thank you also if you're watching this as a replay. So we know that many people won't be able to attend on a Sunday. In some places it's a holiday. But thank you everybody for joining today, or if you're watching this later, also enjoy the workshop today. So first thing, like, just give me a sec, having issues here. I'm just making sure, like, I think I'm having issues to play the slides, but I'm not sure like if other presenters will have the same issue. I'm gonna go through the slides here, but yeah, let's make sure like presenters are able to go through slides later. Yeah, so first of all, like I wanted to give you a warm welcome from the organizers. So this is like a team of 10 different people from different time zones. So it has been a quite interesting journey organizing this workshop, like coordinating among us. Like it has been months of preparation. So we hope you really enjoyed this workshop today. I'm gonna give a special thanks to Anyi, Lenin, Alejo, and you, who has been leading this effort and have done the hard work of actually running the workshop, but also to all the organizers that are here with us today. And also thank you a lot for the people who wanted that is actually with us as speakers or panelists or people that submit papers today to the workshop. So I think this is like really like it's only possible because the community actually was interested in making it happen. All right, so a little bit of motivation about like this workshop today. So we know video editing has a long-standing story. So people start editing video using scissors, and it was a manual process. Then technology came up, and like there were multiple new devices that actually facilitate the editing process, right? Like in the 20s, like we were not cutting with scissors anymore, but now we were using the moviola, which is actually a way to make this faster. Then there were the flatbeds, and today we have nonlinear video editing. But the goal of this workshop, or like one question we ask in this workshop, is what is going to be the next wave of video editing? So how the next iteration of video editing, how will it look like? And especially, we're wondering what is the relationship of AI, intuitive video editing tools, and as well creative. How these three components interact to actually make the new generation of video editing faster, smarter, and also more creative. And again, to emphasize a little bit more, so one of the key goals of this workshop is actually bringing together people from multiple disciplines. So not only computer vision. So we know we are in a computer vision workshop, but we're also bringing people from the psychology and perception, human-computer interaction, and today actually we're bringing creative artists to different panel discussions we will be hosting today. So with that, like the workshop has three main components. So one of them will be the keynotes. We will have an amazing lineup of speakers today. We also have two different panel discussions. So last year we hosted one and people love it. So we say, let's do more of that. And now we have two different panel discussions today. And we also have a poster session, which actually will showcase work submitted to the workshop, basically papers and new technologies that has been submitted to our call for papers. And this is a snapshot of today's agenda. So all times are on PDT, but if you go to the website, our CVEU website, you will find the times in your time zone, so you can really schedule your day based on that. And yeah, as I said, we have an amazing lineup of speakers, two different panel discussions, a poster session, and there will be a closing remarks and prize announcement at the end. So please stay with us. And with that, I will pass it to Lenin, who will be introducing our first speaker, Tali Dekel.
Okay, so welcome everyone, and I'm Lenin. So thanks again, Fabian, for your introduction. And now let's begin our today's journey with keynote session. Note that each keynote will last for about 25 minutes and followed by a 5-minute Q&A. And we'll give a reminder when the time is running out. So everyone here is welcome to leave out questions for our speakers in the chat room and the live stream during the talk. So it's my great pleasure here to introduce our first keynote speaker, Professor Tali Dekel. representing the academic side among our speakers from diverse backgrounds. And Tali is an assistant professor from the Mathematics and Computer Science Department at the Weizmann Institute in Israel. And she is also a research scientist at Google. Her research interest includes image and video analysis, multi-view systems, 3D structures and motion estimation, and image synthesis and rendering, to just name a few. And personally, I'm a big fan of her serious work such as diverse image and video generation, video layer decomposition, texture light, and etc., which have great impact in our community and also inspired my own research works many times. So with no more delays, let me hand over to Tali for her speech.
Hi, thank you for the kind introduction. I think I cannot share my screen though. I need the host to enable. Oh, okay. Thank you. Okay, hi everyone. It's a pleasure to be here. And today I'm very excited to talk about how can we re-render our dynamic world through novel layered neural video representations. And I guess my motivation is that videos are all around us. We all capture our dynamic world through everyday videos. Most of my videos are of my children, so as you can see here. But compared to image content creation, video editing tools and content creation tools have been dramatically lagging behind. And recently, I've been focusing on tackling this challenge, aiming to make everyday videos much more creative, artistic, engaging, and generally aiming to enhance the way we can perceive our dynamic world through modified re-rendered video content. So just to give a few examples, I'm going to show a video of my son riding his bikes for the first time. And I took this video and stylized the background. And you can see that the background is stylized in a consistent manner. We preserve the structure and geometry of the scene. And by doing this, we can create like a much more memorial video. In other cases, when we have an extremely cluttered scene, we might want to focus on our attention on a specific moving object by removing all the other dynamic elements in the scene. And you can see that we can do that. We not only remove the people in the scene, but also on all the scene effects, like the trampoline deformation they caused in the scene. Or a different application where we might want to use text to semantically edit a video, like in this example where I'm going to talk about in more details today. But you can see that no matter what type of an effect we want to apply on our video, there is this fundamental challenge where each the edits that we apply to a video must be physically, geometrically, and temporally consistent. And in the past couple of years, I've been developing different methods for tackling this fundamental challenge. At the heart of all these methods, there are novel decompositions of the videos into layers. And today I'm going to talk about in more details about two recent of these works. The first is named Layer Neural Atlases for Consistent Video Editing, and it's a joint work with Yoni Kasten, Dolevo Free, and Oliver Wang. And here in this work, we tackle the task of video editing from a representation point of view. Basically, a video is just a huge volume of pixels, which is unintuitive for a user to interact with, and it's very difficult to process. And this raised the question of if and how we can represent video content in order to facilitate more intuitive and consistent video editing. So you can think that if we had a full 4D model of a dynamic scene, like we knew for each point in the video, its 3D location across time, we could achieve that, but that's like an extremely challenging task by itself. So instead, we took a different route and we took an entirely 2D approach. We took inspiration from some classical works that represents videos through 2D mosaics. And we proposed a method that takes an ordinary video and decomposes it into a set of 2D neural atlases. So as you can see here, each of these atlas serves as a unified canonical image that represents either the background or the foreground through the entire video. So each of the pixels in the videos are mapped onto this onto these 2D atlases, allowing us to basically reconstruct the video content from this representation. So this essentially gives us a unified representation or parameterization of the video in the 2D domain. Now, a key feature of this representation is that it allows us to hugely simplify video editing by performing the edits directly in the atlas domain. Okay, so given a video, our goal is to learn both the atlases and the mapping onto the atlases in a completely self-supervised manner. And I'm going to tell you a bit in more details about how we do that. So we use coordinate-based MLPs to represent both the mapping and the atlases. Each pixel position, X, Y, T in the video is first fed into two mapping MLPs networks that predicts that the output is just 2D UV coordinates in each of the atlas space. So these UV coordinates are just value between -1 and 1. The predicted UV values are then fed into an atlas network that predicts the corresponding RGB color at that UV location. So what you can see here is just a discretized rendering of these continuous atlases. Each video position is also fed into an alpha MLP network that produces a foreground opacity value. And with these values in hand, we can simply just reconstruct the RGB color at that location using simple alpha blending. And this essentially allows us to reconstruct the original video and to train the system end-to-end using simple L2 reconstruction losses, along with some regularizations. So recall that in the end, our goal is to get interpretable atlases that we can edit. So a reconstruction loss alone is not sufficient to achieve that. And we have additional loss terms that will encourage an interpretable and edited representation. So again, our main loss is a reconstruction loss. It's just a simple L2 loss between the reconstructed frames given to us by the atlas and the original video frames. Our goal is again to get interpretable atlas. So we want to preserve the original structures in the frames in the atlas. And to achieve that, we encourage that the mapping between the video pixels and the atlas will be locally rigid. Okay, so if we look at the pixel P and its neighbors, and we look at the corresponding mapping points in the atlas, we want this mapping to be a rigid transformation. Without this loss, you can see that the atlases are distorted and they collapse into some small regions within the continuous atlas space. So again, ideally, we would like that each point in the atlas would represent a physical point in the 3D world, but we don't have 3D information in this representation. So in order to encourage that without having 3D information, we apply an optical flow loss. So we pre-compute optical flow between consecutive frames, and then we encourage corresponding points to be mapped to the same atlas point. You can see that without this loss, we are still able to get reasonable decomposition, but we can see that we have some distortions in the atlases. Lastly, we have some sparsity loss that prevents duplications in the atlas because optical flow loss is not perfect. And if we don't have that, we sometimes might end up with duplications, and having duplication would make the representation more difficult to edit because we need to apply the edit in a consistent manner over all the duplications of the object. So you can see that with all our losses, we get like this nice decomposition of the foreground and background without duplications and without redundancies in this representation. We also have some initialization loss where we encourage the predicted alpha to match some rough object segmentation masks. We turned off this loss after several epochs, and these masks are continued to be refined and automatically updated through the network. Okay, so let's see some results. Here again, we can see the cartoon video, and you can see the car in this video takes like a 90-degree turn, and our method successfully unwraps it into this atlas representation. You can see the reconstructed video and some texture that we can map onto this car, which move consistently with a moving object. Here you can see even a more challenging example where we have severe parallax and lots of occlusions and non-rigid motion. There are some artifacts here, but you can see that the network successfully decomposes it into layers and track the dots successfully. And now for the fun part, editing. So now once we have these pre-trained atlases, what we can do, we can just discretize the atlas and just plug it into any off-the-shelf image style transfer method and map the edit back to the video, as you can see here. We can even replace the background atlas with a completely different image, which is roughly aligned to the atlas, which allows us to replace, to create this Arctic background in this case. So clearly there are limitations for these methods because we applied and we have some strong regularization to apply to get this decomposition. For example, the rigidity loss, it is very difficult for us to handle a highly articulated object like in this example. But even here, you can see that the composition is still meaningful and that the alpha channels still capture these complex scene effects like the shadows and so on. And this allows us to still apply edits on the background. So this representation is still useful. We can add this graffiti onto the ground and still get nice edited results, even though the foreground object was not successfully represented. Okay, so next I want to tell you about a new work in which our goal is to perform text-driven edits to real-world image and videos. And the reason that I'm emphasizing it here is because I think dealing with real-world data and especially videos is still an open challenge when it comes to text-driven editing. And this is a joint work with my student, Omer Bartal, Dolevo Free, Rafael Friedman, and Yoni Kesten. Okay, so I guess we are all aware of the ongoing generative AI revolution when we really can generate these mind-blowing images from text and very recently even short video clips. Various methods have demonstrated really cool semantic editing by using pre-trained generators with clip. But none of these methods is really designed to work with real-world data. And they all have this inherent trade-off between keeping a high fidelity to the original image and fulfilling the target edit. So in text-to-live, we took a different route and we avoided using any pre-trained generator. We focused on performing these automatic, localized, and semantic edits without requiring any user input. And these edits are also applicable for videos, as you can see here. So again, these edits are performed automatically without requiring any user masks or any types of additional information. And the key idea of applying text-driven edits to real-world videos is to use our pre-trained neural atlases and to replace our manual edits that I just showed you with text-guided edits. But before I'm going to show you exactly how we do that, I'm going to explain briefly our text-guided image framework. Okay. So when it comes to image, what we have an input image and a text that describes the target edit. And our framework trains a generator just using this information and a pre-trained clip, which is used as an external prior and allows us to establish our losses. Now, I don't know if you worked with clip. You probably know that this is a very powerful but hectic model that can often easily we can find ourselves with adversarial solutions and fall into undesired local minima. So our key idea in this work is instead of predicting directly the output image, we're going to predict an edit layer. An edit layer that is going to be represented by an RGBA layer, color plus opacity. And our output edited image is going to given to us by compositing this edit layer on top of the original image. By doing so, we can control the generation and the localization of the generated content by applying novel losses both on the final decomposition and the edit layer itself. Okay, so I'm gonna go over these losses really quickly. The losses on the composition are quite straightforward. What we want that the edit image will comply with the target text prompt according to clip and clip space. We also have a structure loss, also defined in clip space, which is aimed to preserve the general layout of the structure of this image. But now the interesting part is actually the losses that we can apply on the edit layer itself. We added this loss that we named the green screen loss, and it took inspiration from chroma keying, which is a very well-known technique in post-production, in video and image post-production and filmmaking. Specifically, what we do, we take our edit layer, we composite it over a green background, and then we have a loss that will encourage this green screen edit to fulfill a template text in clip space. For example, in this case, I want that the composited over a green screen will comply with the text fire over a green screen. And recall that clip was trained on massive amount of internet data, including lots of green screen images. In fact, you can find almost everything over a green screen if you search in Google. And this loss essentially allows us to really get fine-grained control of the generated content. So you can see in this example, we have this input image and we wanted to add smoke to the cigar. So we use the text, the smoking cigar. But the easiest thing for clip to do is just to add a new cigar. By adding our green screen loss, we can control the effect, because now we are requiring that the edit layer, when it is composited over a green screen, should fulfill smoke over a green screen, and then we can get rid of this unwanted content. Lastly, we have also sparsity constraints on the alpha that require that the edit will be minimal change to our image. So here you can see some of those edit results on images, and you can see that we can successfully locate the effect in the image and generate because we're representing it with an edit layer, we can get these nice semi-transparent effects without distorting the image content. Okay, so how do we apply this framework to videos, right? One thing to do is just to train on all the video frames, exactly the same framework. But this result, as you can see, is not sufficient. We get all these like low quality and also very flickery results over time. So instead, what we did is to use our neural layered atlas representation essentially as a video render, okay? So I remind you that this representation takes the video, decompose it into our neural atlases, and we can reconstruct the video out of this representation. And now, before we applied edit directly, manually, or by plugging them into some existing method, in order to edit the video. Now we want to achieve the edits in the atlas domain, but through text. So the way we do this is we take our pre-trained neural atlas, we discretize the atlas that we want to edit, let's say the foreground atlas, and now we train the same network that we trained before, this simple network that is only gonna feed it to this target text and atlas network. The way we're going to do this is that this network is going to get as input the discretized atlas. It's going to output an atlas edit layer that we're going to be able to map back to the video frames, to the video domain, using the pre-trained, the pre-computed mapping. And now we can simply just apply all our losses that I just described on the edited frames and their corresponding edit layers. And this allows us to perform this nice semantic and localized editing on various videos, as you can see here. Or in this example, again, we can add this semi-transparent effects to a video, like a foggy park or park at night, or change the texture on Lucia's dress. So clearly, our methods have limitations. We are currently limited by the type of videos that we can represent using neural atlases. Also, we cannot change the structure of objects. We cannot add new dynamic objects to the scene, but I think these are all very exciting future avenues. So with that, I would like to thank you, and I think I could take some questions.
Okay, thanks, Tali, for your wonderful speech. And also you proposed the many interesting future directions for the video editing. And we do have received a bunch of questions from our audiences, and I'll select most of them for you to ask. So first question is, have you interacted with CHI researchers to assess how to ship your research to digital artists? If so, can you comment about it? If not, which model you would love to ship to production?
Yeah, it's a great question. I think the current bottleneck is really sort of like what we see with NERF is there are two. It's not only that. It's like, first of all, it's the training time. These representations, the neural atlas representation is fitted to a given video, and it takes a few hours to train. But today, these tools are rapidly advancing, and you can train, you can do instance training of these MLP networks. So I'm pretty sure that you can. We haven't tried to optimize running time or to try to design specialized CUDA code to run this, but I'm sure that this is possible. I think another more fundamental challenge in shipping this to artists is the robustness. Again, we had some assumptions on approximately rigid motion, locally motion. I think that if you want to really deal with arbitrary articulated objects, we're still not there. So I think these are the two components that are currently missing. But of course, I would love to see this, in production or being used by artists, and it will be a very satisfying result for me. Yeah.
Yes. We actually can see a lot of works and efforts involved in deciding which part of the question need to be addressed from the work. Yes. And also another question is, how did you figure out the green screen prompt? Very interesting and intuitive design choice. So maybe as the audience is curious how you did come up with idea.
How we came up with this.
Yeah.
Yes, it's a good question. I think it started with saying maybe we can apply some text guidance directly on the silhouette that we got. Like, if you get an alphabet, maybe Clip knows what the silhouette of a dog looks like, or maybe it knows how a silhouette of a person looks like. And then I think my student was the one who said, oh, so let's make it a green screen loss. And I think the credit goes to Omer, my student, who suggested this. Yeah.
Okay. Yeah, that's indeed a very interesting idea. And we are surprised to see it really works for your loss design. Yeah. And we have another question, shows how does the layered atlas work for multiple objects in the video? Is it more challenging than single object editing? Because in most of your demos, you show the one object of the interest, but what will happen if we have multiple objects? So do we need to design multiple layers for that?
Yeah. There is no practical reason that this cannot be applied to multiple objects. We tailored the representation to 2 layers, but it could be extended. We actually show examples for more than 2 layers. I think we had a previous work, which is named OmniMat, in which we showed such results where you can decompose video into N layers. I think in this setting with the MLPs, it might be a bit trickier to pick up those correlations between objects and all, let's say, shadows and these types of stuff, to decompose them to the right layers. But I think it's doable, and with minimal changes to the architecture or to the implementation.
Yeah, thanks for your answer. And we have really many questions, and maybe I can pick another one. So is it possible to use the editing layer to make video edits outside the mask of the objects you are stylizing? For example, if you want to use a prompt, a swan with a long hair, so maybe the editing area is outside the original mask.
Yeah, so as I mentioned, I think right now it's part of the limitation of our method because the mapping doesn't change. Like the motion in the video is taken from the original video. We are not manipulating motion. So if you add new structure, you need to also generate a motion that will correspond to it. And at least you need to be able to adjust the alpha max or to be able to say how this new content evolves over time.
I see. Yes.
And
So
that's a very interesting challenge, but it's an open one. Yeah.
Yes, exactly. We know the consistency and the temporal consistency is quite important in video editing. So yeah, definitely. So we have another question says a common challenge in video editing is to no, this is already asked questions. So one audience interesting, is there any training bias with massive green background images? When you're using the green background images for training, do they introduce any training bias in it?
Training bias? Again, we haven't observed such training bias. We observed different types of biases in clip, but not because of the choice of rendering something over a green screen.
I see. Okay. Okay, so let's thanks Tali again for your wonderful talk, and maybe we will continue with our next speaker. Thanks, Tali.
Thank you.
So with no more delay, let me welcome our second speaker. So Professor Mark Riedl is a professor from the Georgia Tech School of Interactive Computing, and he's also the Associate Director of the Georgia Tech Machine Learning Center. His research focuses on human-centered artificial intelligence, the development of artificial intelligence and machine learning technologies that understand and interact with human users in more natural ways. And his recent works have focused on story understanding and generation, computational creativity, explainable AI, and teaching virtual agent to behave safely. And I believe many of the audience here today, just like me, always enjoy reading Mark's blogs on social media, which have shared many interesting thoughts and experiments on how AI and creativity can be consolidated together. So Mark, we are super looking forward to your speak today, and let me hand over you for the speak.
Well, thank you very much for having me. Please let me know if you cannot see my slides or you cannot hear me speaking. My talk is going to be a little bit maybe unusual for our community. It's not going to be a technical talk. Instead, I'm going to talk about questions. And so I have been in a fortunate position of being able to have a job where I can basically make things that do lots of cool things, right? And so if you don't know who I am, that's not unusual. I'm not kind of part of the video and you know, image generation communities. I actually come through story generation. So who am I? Once upon a time, many, many more years ago than perhaps I would like to admit, I built a story generator, and for some reason they gave me a PhD for this. And then went on to have a variety of kind of jobs doing research. Through the years, I branched out and I started thinking about not just the algorithms, but what it means to build systems that we might think of as being creative. And not that this person particularly any good, but just kind of put a timestamp. The first time I really thought about the broader issues of not just the algorithm, but how algorithms kind of relate to human creativity. From there on, I kind of did a whole bunch of other stuff. This is a little bit of my portfolio, right? I did more story generation, moving into machine learning systems. I built cinematography systems and computer game generation systems. And then most recently, and perhaps the one that amuses me the most personally, is a parody lyric generation systems that will rewrite lyrics for different songs. And this is just kind of give you an idea of the fortunate things that I've been able to work on in a broad variety of different kind of applications. I've also thought particularly about how we might make new algorithms using our understandings of human creativity. So how might our algorithms need to change if we want to do things like, say, understand or be able to recognize a Pegasus, a horse with wings, if we didn't have any training data to do that. Humans seem to be able to do this. How can our algorithms change? So I've tried to contribute to some of the theoretical background in terms of what it means to build systems that are creative in particular domains. And as we've heard throughout the day, right, we're really kind of going through this computational creativity hard takeoff, right? So it started with, arguably started with Deep Dream, Style Transfer, Dali, Dali 2, so on and so forth. I won't say too much about these systems. I think we're all familiar with them. They've gotten more and more elaborate, more and more detailed, and more available, which is particularly exciting to me as well. And then, of course, just within the last couple of weeks, 4 different video generation systems, which is just kind of phenomenal and amazing, and the things that are happening now. Okay, but if we step back a little bit, I think the reason why we're all kind of here is, well, we also want to think about the human side of things. So these are great tools, they can do creation. Are they also helping people create as well? And okay, so this is called intelligent creativity support. And I think probably any of us who have been playing around with any of these tools kind of also believe that they're actually not easy to work with. I don't do research into vision systems, but I play around with them way too much, I guess. And I've kind of noticed a particular trend here. So even as back in kind of the pre-deep learning or early in the deep learning kind of revolution, what we had were systems that were not easy to work with. And this is one of my favorite papers, not because it's particularly any good, but because it was co-written with Kirsten Stewart of the Twilight actor. So anyone could become an author on Archive by partnering and doing kind of interesting thinking about AI. Right, so even in 2017, people were writing papers about how hard these systems will work. There's a lot of trial and error. Back then, it was a lot of trial and error with getting your data set right, hyperparameter tuning on your trainer or your style transfer, multiple generation runs, and then doing a lot of post-processing with tools like Photoshop and other sorts of things like that. Now we fast forward to kind of the current day, and we have these great systems that can be prompted. They're much easier to use, much easier to work with, but it still requires a lot of trial and error with multiple prompts, multiple runs. We don't have to play around with the data so much. We don't have to fine tune or play with hyperparameters as much. And then, we get things that are almost quite kind of like what we want, and then we throw them into Photoshop and we start to edit these things as well. So this kind of, spurs us to think as a community about what's going on here, right? So we know that these intelligent systems, they can create art, it can create beautiful art, amazing sort of art, but it always kind of starts with this prompt or some sort of specification. And then that just seems a little bit too simple, right? Is there more that we need to add beyond just the creation algorithm to make these useful? So we might want to ask, can intelligent systems make people more creative? I think that's actually the wrong question. I want to rephrase that a little bit. I want to ask, can intelligent systems make people more capable of expressing their creative intent? So it's not that people are not ever creative, but we have ideas that we cannot express. So I can't make music. I'm a particularly poor artist, but I often have ideas of things that I want to create and see. So are those things kind of helping people get their ideas out of their heads into the real world? And now this is not a new idea, right? All throughout the history of computer science, people have been thinking about augmentation of humans, amplification of people's ideas and their work. And in the 2000s in particular, a lot of people from the HCI community, human-computer interaction, we heard a little bit about Kai, really started thinking about creativity support tools as an open, first-class research problem. Now, AI wasn't quite ready for some of those questions, but now, of course, we see in the late 2010s, the deep learning revolution in particular, we're now able to actually kind of get our hands on these things and actually try them out. So but now how do we try them out? How do we use them? And I'm going to kind of lean very heavily on a particular piece of work. It's really just kind of an ontology this person by the name of Lovelace put together back in the 2005. So this is just to kind of set the time frame for what this happened, in which with the HCI community really kind of started thinking, well, what is the right way to integrate humans and computers in creative context? And Lovelace in particular said there's really kind of 4 ways of doing this. Computer as nanny, computer as pen pal, computer as coach, and then colleague. The first 3 are really non-AI based, right? So it turns out you can make incredibly effective non-AI tools that really help people create. So nanny is about checklists and perseverance reminders. Pen pal is about coordinating multiple people's communications. Coach is about tutoring, giving tutorials on techniques and skills and things like that. But computer as colleague really is the place that I think we're most interested here, this community, because this is about computers and colleagues working together on more equal terms. And then of course requires artificial intelligence. So Lubert's idea is that any sort of colleague is going to require a user to propose an idea that is then acted upon by the AI system. The user always has to be an interactive participant in the process. So not particularly interested in just creation for creation's sake, but creation for the user's sake. And to set this in the particular period of time in 2005, there wasn't a whole lot of AI systems that we could say would really kind of empirically help anyone do any sort of creation. They really just weren't sophisticated enough. But now here we are in 2022, and I think now it's worth digging into this computer as colleague metaphor a little bit more. And I think we're starting to see some interesting ideas about how AI systems can be built to support human creators. And so I'm going to extend the ontology a little bit by digging in here and kind of proposing a number of different ways of doing this. Right. So the first way might be computer as a critic. Computer as a critic is something that can evaluate an artifact and then report back to the user on what that critic thinks. The critic might be an expert, so an expert in a particular art medium or the what makes art medium particularly good, or it could be the audience. What would your audience think? So again, most of us create because we want someone to see the things that we create. What is this hypothetical person that we really care about going to think? And we've seen there's actually a lot of interesting work and success that can happen in building critics. And sometimes the critics can actually be quite simple, even to have an effect on humans. And I've done a little bit of work there. My citations are the bottom. I'm not going to dig into my own work. You can do that. Computer as subcontractor is another way of thinking about humans and computers working together. And I think this is really where we are now. A lot of prompting, with Tali, with stable diffusion. A human gives it some set of instructions or a prompt to the system generates without further instructions, and you either like it or you don't like it. And if you don't like it, you prompt again, and hopefully you get something better the next time. And then co-creator, though, I think I kind of reserve this co-creator for something particularly specific here. I mean, this is when now we try to put the human and the computer into more of an interactive process. So the human and AI are both able to work on the artifact, the image, the video, the music, whatever it happens to be. It might involve multiple rounds of changes, and the human and AI are more importantly are communicating back and forth about what they're trying to do, why they're trying to do it, what they wish the other person could do. Think about teammates, right? How teammates are going to communicate a lot, perhaps even a lot more than they actually work on the artifact themselves. And then to the far right, we can kind of say, well, there can still be kind of different levels of how humans and computers work together, even as co-creators. It's really about who's in charge, right? So the peer is kind of an equal mixed initiative sort of thing. The apprentice kind of says the human's in charge, the computer is maybe not as capable, but is still kind of a valuable contributor. And then mentor flips the whole thing around. This is very hypothetical. I don't think we've ever seen this, but to say the computer is actually in charge and the human is kind of working kind of secondarily with the computer. So the computer itself is more capable than the human, for example. And so this again creates an ontology that says, how might we think about building tools and what metaphors might we understand those tools by? Now, since we're talking about AI systems here, we also probably want to think a little bit about whether these systems that we pair up with humans are themselves creative. In particular, if we have a human and a computer working together, how do we allocate creativity between the algorithm and the person who initializes it? So do we get good art because we have a good prompter, right? Do we have a good art because we have a good algorithm? Do we have a good, what is the role of specification versus the algorithm? And this is really, really hard to tease apart in a human AI kind of collaborative sort of setting, even when we think we're not working with a collaborative setting. Even the subprompt, the prompting, the human is still there, right? A lot of what comes out of the system is based on how good the inputs are to the system. And if we decide that our computer systems are creative, what attributes would we expect to see from them? And even the broader question, like, what even is creativity? So let's kind of dig into some of these questions now for the next few minutes. And I'll start with a big hard one. All right, I'm now going to reveal to you the grand truth of everything. What is creativity? All right, I lied, I don't know. There's a lot of different opinions on what this term creativity means. What is creative, what is not creative? How do we decide creativity? I don't know, and I don't really kind of want to come in and say, here's the right way we should think about it. But what I think we can do is, even if we don't really kind of understand or have a good definition of creativity, we can still say there are some things we would probably expect to see from anything, human or computer, that we might consider creative. Now, I will admit that this is kind of my kind of experience has led me to these 4 things. Take these with a grain of salt. I think there might be more, there might be less, there might be different ones. But I think these are the 4 things that I really think about the most when I'm building creative algorithms. The first is novelty. Now, I'm not going to say too much about novelty. I think we all have a good intuitive idea of what novelty is, but I just wanted to say that novelty is not necessary. It is necessary, but it's not sufficient. That is, that creativity is not the same as just saying we have a lot of novelty in the system. And we can kind of see that because once we have too much novelty, we start to perceive things as being random and then not as much as valuable, right? So too much novelty is not making things more creative, but at some point starts to harm our creative outputs. Now, if novelty and randomness is on one side of the thing, what holds us back? What pulls us back from novelty? What counterbalances novelty? And the thing that I think counterbalances novelty is something that I call expectation. And I think about this in several levels of complexity, but basically the basic notation of expectation is that whatever this AI system is, or this creative system is, it references some sort of shared mental model of semantic relationships. That is, we understand what it's trying to produce. And Dali is, old work, comes all the way back from 2021, right? 2020 maybe, right? But I love the examples here of the baby daikon radish in a tutu walking the dog, because we look at these and we intuitively understand that there is a radish, it's walking because it has legs, the dog is there, there's a leash, there's all the sorts of things that we kind of semantically set from the scene that's being described, right? And it also makes some mistakes as well. So we also see a floating radish walking a dog, and sometimes the leash is attached to the tutu instead of the arm, those sorts of weird little things like that. But that brings me to level 2. So meeting expectations is like the basic thing that we would hope to see here, but also intentionally challenging the shared mental model. So the example of the floating radish walking the dog is maybe not the way I would think of something walking a dog. And this challenges my notion of what it means to walk the dog. Now, the issue why I might not say that Dali has reached level 2 is because that particular image was probably an accident, right? It wasn't intentional. It didn't really mean to challenge my expectations. For whatever reason, it just kind of, it was decoded in a particular way. Okay. But once you start to intentionally challenge people, then I say you kind of have something that's particularly exciting and meaningful here. Another thing that I think I look at a lot in terms of creative systems is learning. Now, of course, we're machine learning people. We like to talk about learning a lot. Well, I look a lot at humans and how humans learn to create things. And I see 4 phases. The first phase is imitation. And I'm going to illustrate these through work that my son, a few years ago, who was probably five years old or something like that, did. He wanted to learn how to draw a cat. So he found a picture of a cat, kind of an artistic, stylistic picture of a drawing cat, and he started to draw it himself. Now he can't draw as well, so it's different, it's unique, it's novel, but he started to learn the skill. And I think most people start with imitation often. And then they go beyond that. They say, well, now once I've been able to imitate and draw something exactly like I see, I can change it. I can try my own, add my own elements to it. And so the next picture he drew a little bit later was he wanted to see a cat eating a cookie. And so he worked that in, and he, without ever seeing this particular image and seeing a cat holding a cookie, he was able to do something that I think we'd probably agree as being, successfully meeting those criteria. And then, so again, this term intentionality comes in. So now it's not an accidental deviation from the things that we've seen from the examples that we were learning from, but the fact that we are now able to manipulate this in a lot of complex, interesting, kind of novel sorts of ways. And so probably the next thing we really need to talk about that's come up twice now is this notion of intentionality. Oh, well, let me actually say one thing before. These three phases of learning also kind of sort of align with how we've been thinking about algorithms. So imitation is really what we think of, I use the idea of GANs. We've progressed maybe perhaps beyond GANs, but really some notion of minimizing some sort of delta between an exemplar data set. Now we've started to look at more complicated, interesting loss functions. And then now I think phase 3, though, I think is really the next area to focus on. And really, I don't think we really have a particularly good intuition on how to intentionally deviate from expectations. So we should talk about intentionality, though, because I think this is actually possibly even the core one, the most important here. There we go. Okay, so the first is given some sort of goal, trying to plan out or make choices that achieve that particular goal. Level 2 then is given a goal, achieve the goal, but in some sort of unexpected way. And again, also being understandable. So again, we want to balance against this notion of randomness. So we don't just want to achieve a goal in some sort of random or accidental sort of way. But the key here, intentionality, is the idea that we are really, again, challenging the user, saying, this is what you asked for, but I see another way of going about. And then level 3 is changing the goals. And again, this kind of creates more and more complexity for an AI system. We don't necessarily know how to build systems that can change the goals, but we do know that humans can do this. And we see it a lot in children in particular. So here's a picture of my son, who started out building a set of a spaceship, saw something about that he liked and started thinking about houses, and then started reconstructing the whole thing into a house. Okay, so I know we're probably a little bit pressed for time because of some of the issues, but the last thing I really wanted to kind of leave you with is the idea that we can actually track our progress in terms of achieving some of the things that we just talked about in terms of creativity as a community. As to say, can our systems actually kind of progressing in a way that we'd hope to see when we want to think about and talk about creativity. And to do that, I put together something called the Lovelace 2.0 test. It's named after Ada Lovelace. Ada Lovelace was a contemporary of Charles Babbage, building one of the first computer systems, actually a computer system that was never actually built. But Ada Lovelace did a lot to understand what it actually means to program a hypothetical computer in 1843. She actually started writing about and philosophizing about intelligent creative machines. And particularly, she said the analytical machine has no pretensions to originate anything. It can only do whatever we know how to order to perform. And on the surface, that might seem like she's arguing that we cannot build creative systems. But if you think about the creative systems that we're building, we are in some sense ordering them or teaching them how to perform the things. So, but what this is doing is she's presenting a challenge to say, how far can we push down intentionality? How far can we push our learning? How far can we push into novelty and expectation, right? So now, unfortunately, I discovered that I wasn't the first person to think of a test and name it after Lovelace. I'll talk a little briefly about the original Lovelace test, which is by Bringsford, Bello, and Ferrucci. Many of them later went on to build the IBM Watson machine. And their idea was we can test whether a computer machine is creative or not if we have a human who builds a machine or an algorithm A. That algorithm then produces some sort of output. And then the human looks at that output, and if that human, having built the system or knows what an AI programmer can know, does not understand how that output could be produced, then the system must be intelligent. And this is, to me, a little bit problematic for a computer programmer who's built an AI system not to understand how any particular output is produced, even if it's building off the data and using statistical properties. I think we can kind of dig in deep enough and understand it. It also creates a pretty high bar for what it might mean for a computer system to be creative. Now, at the same time, now in 2014, now there was a big call for rethinking the Turing test. There was a call to basically say, can we come up with alternatives to the Turing test? Now, I'm not so vain as to say I'm going to come up with something as great as Alan Turing, but I did start thinking about the relationship between creativity and intelligence, and in particular, the notion of composition, right? Is a system actually able to understand what a human is asking for when they ask for a picture that has multiple components that typically don't go together? So for example, a cat with spider legs and alligator tail being ridden by a bunny, right? And so, maybe the thing to do is to say, are our systems understanding and are able not only to demonstrate their understanding by being able to produce the art that corresponds with a request such as that. So that came out with the idea that we might come up with a new test. And this new test works a little bit differently. We have a human. They're going to set a set of criteria. So bunnies, spider legs, alligator tails, so on and so forth. We're going to ask an AI system to do it. Our human is not the creator of the AI system, it's just a regular person. That system creates some sort of output, and then we decide whether it meets all the criteria. And then just to make sure it's fair, we might have a referee that basically says, are you asking something that's impossible? Okay, now to kind of make this concrete, right, this is how it works. We start with one criteria. We take an AI system, we say, I want to see a penguin, okay? And if the system judges that correctly, then we go on and we add something to that prompt, right? So we ask for a penguin on Mars. And then we add for a penguin on Mars wearing a spacesuit, walking a dog next to Santa Claus, so on and so forth. So we're making the request harder and harder and harder. We're composing more and more things. And now we can basically count the number of times the system succeeds in producing something that we recognize as being responsive to the prompt. And this becomes the creativity index, and we can look and see how this creativity index changes as we update our systems or over time as more systems come out. The important thing here is that there's no threshold for creativity. We don't say you have to pass so many tests to get creative. We basically say, is our number on average going up over time? Now, in 2014, I thought this was just an experiment, a thought experiment, and I never thought it'd be run. And then within 9 months, people started putting together systems that were somewhat responsive, right? So stop sign flying in the sky, right? Not a great picture, but you can start to see that. So I really kind of start to freak out at this point, right? By 2018, we started just seeing more responsive images to more complex prompts. 2021, when Tali and VQGAN and all these things started coming out, we started seeing things that are really kind of dealing with more complicated situations and scenes. And so last year, I thought, all right, enough is enough. Let's actually try to run the Lovelace test. Let's see what happens. And at the time, what I had available to me was VQGAN plus clip guidance. Now we have much better things like this. And I actually kind of went through this set of prompts. I said, well, let's try this out. Let's start with a penguin. Not a great penguin, but I'm going to be lenient. I'm going to say that is penguin enough. Let's ask for a penguin on Mars. And yeah, I think one of these black blobs is probably a penguin on Mars. I'm going to let it pass. Penguin on Mars wearing a spacesuit. That's a really cool spacesuit penguin dude. I'm going to give you a pass on that. And this was, this is really amazing because a few years ago, I thought maybe we could do 1 or 2 levels. Now we've done at least 3. Let's go a little bit further. A penguin on Mars wearing a spacesuit and walking a dog. All right, things are starting to fall apart with 2021 technology. But if we kind of think that some of those blobs are some sort of border collie or something like that, I think maybe let's just try it. Let's go 1 more, maybe 2 more, right? A penguin on Mars wearing a spacesuit. Now let's make the dog a robot. All right, so our blobby robot things are, maybe a little bit more mechanical. So let's just go 1 more. I'm not saying we should go further, but I just want to see what's going to happen. A penguin on Mars wearing a spacesuit, walking a dog, robot dog next to Santa Claus. We get a lot of those components, except our penguin is turned into a banana. Okay, so at this point, we've lost some of the core things, and our system I would probably say, it's not really being responsive anymore. But this is amazing. This was 6 steps if we're allowed to be a little bit lenient here. And this exceeded my expectations. And I think as a community, we should really kind of be very proud about the progress we've made in just the last couple of years. Of course, Dali 2 and some other systems have come out just a year later. So we might ask, are we making progress? Have we actually made progress in 2021? Here's the same set of prompts from Dali 2. Penguin on Mars wearing a spacesuit. And when we get to walking a dog, we don't see a dog. We end up with maybe 2 penguins. So we got about 4 through. And this is super unscientific, right? Maybe different prompts we got in different numbers, but I was a little bit disappointed to see that Dali was actually having a harder time with composition. Stable diffusion, kind of same sort of trend, really great images, much more clear. Penguin on Mars wearing a spacesuit. I'm not sure I'm going to call that a spacesuit, so we're at the 3 or 4 sort of thing. Now, so what we're kind of seeing is that maybe our images have gotten better, but maybe our compositionality has not actually kind of gotten better. And then just to say, have I asked for impossible things? Here's me drawing a penguin on Mars, walking a robot dog. And here's my, I think he was 7 at the time, son drawing the same image. So I think these are things that we should expect humans to be able to do. All right, now there's unfinished business. This test was never really meant to be run. There's a lot of questions about how this should be performed. Who should be the evaluators? Should they be experts? Should they be people off the street? How lenient should they be? Should the evaluation be binary? Should we allow multiple runs? Or does it all have to be, the top one output? Should we run across multiple evaluators? Should we allow multiple runs? There's lots of questions that if we really wanted a good scientific a number in terms of our progress, then we would want to be able to answer some of these things. But I think even this kind of rough experiment kind of gives us an idea of where we are at this particular time and where our systems are getting better in terms of understanding our inputs and responding to our inputs. And so I'm going to finish up here. I think these are things that we all really believe in. We want to study computational creativity because we want to understand why things that seem easy for humans are hard for computers. We want to learn how to build better systems. When we have systems, we want them to be able to work with us more as peers than as subcontractors or apprentices or nannies or pen pals or things like that. And I think this last one, building co-creative assistants, is going to be a really super powerful sort of thing that's really going to change how humans think about art, how humans make art, how humans just kind of feel better about their artistic abilities. And so I'm going to wrap up there. Thank you very much for coming and listening to me blather on about these kind of somewhat philosophical and very difficult to articulate and put into terms concepts. If we have time, I'm happy to answer whatever questions we have. I apologize for the Zoom bombs, and I look forward to being in the panel later today.
Okay, so thanks, Mark, for your so impressive and insightful talks, especially many philosophical thoughts and concepts proposed here. Since we are running out of time, so maybe we just pick one question from the audiences. One question is asked a really interesting way to evaluate the kinds of models. So do you have any idea on how to scale such tests up? So how to come up with a unified metric for measuring this kind of generation models? Is it even possible?
Yeah, so I mean, I would maintain that the gold standard, if we're dealing with creative systems that we want humans to consume, is we have to ask humans to consume them, to look at them, to read them. Most of my work is done through story generation, and at least in story generation, the primary way is still dealing with human subject studies. There are ways of making those human subject studies more objective as opposed to subjective. We can do better than just ask, do you like this art or do you like this story? We can ask about the properties. In particular in stories, we can ask about coherence. We can ask people to answer questions that we'd expect people to be able to answer if they'd read such a story. But all these basically say you still have to have lots of humans through Mechanical Turk or things like that. Until we have objective criteria that we trust, it's going to be really hard to automate evaluation. And once we have objective criteria that we trust and can algorithmize, then we've also sort of solved the creation process as well, because we can always take any sort of objective algorithm that evaluates and turn it into a guidance criteria, some sort of genetic search or reinforcement learning or even kind of deep learning search. So I wish I had a better answer. Sometimes we can kind of find kind of good proxy evaluation terms, but to me, when I do my work in it, whatever I'm working on, we always go to humans, and then that's expensive and it's hard and it takes a lot of time. So sorry to the person who asked the question.
Yeah, exactly. So maybe we are looking forward to ask more questions in the roundtable session. So thanks again for Mark. And maybe it's time for to hand over to you for our next session.
Okay, thank you, Lini. And can anybody hear me?
Yes.
Okay. So yeah. So so there are many great talks from the academic side, and now that's welcome the first industrial one. So the next speaker is Misha. He is the CEO of a startup company called Edit Mentor. Edit Mentor focuses on developing tools for video creativity. Today, he's going to talk about the company's effort to make future tools for learning video editing. During Misha's presentation, if you have any questions, please leave them on the chatting board. And we also have a QA session after Misha's presentation. And Alejandro, please make Misha the co-host. Yeah, please.
1 second.
Okay, now so
Share.
okay, now let's welcome Misha, and please take over, Misha.
What's up? You can all see me and hear me okay?
Yeah,
all good.
great.
Okay, excellent. I'm going to share my screen. Hopefully you can see that.
Yeah. Hey, Misha, just one quick tip. Like, we were having some bombing before, so I think there is a way you can actually prevent people annotating on your screen. So I think only you can do that. So if you go to the 3 dots on the right where it says more, then you should be basically disabled.
Annotation for others.
Yeah. So,
okay, it's disabled.
Awesome. Yes, take it away.
Well, welcome everyone. I'm humbled and honestly a little surprised that you asked me to be here today, because I'm the owner of a company that teaches human beings how to make engaging videos. We don't have AI completely in our tool yet, although it's something that we are working on, and I'm going to kind of show you an example of it today. I do believe that AI's rise in video editing is inevitable, and it's a good thing. I'm not afraid that it'll replace all the humans, because I doubt you'll be able to get the humans out of it. Anyway, and since I'm not an expert at AI, I needed a lot of prep for this presentation. So months and months worth of Udemy courses have led me to make the following algorithm. Basically, I think this is what you guys are doing. If someone gives you a heap of footage, you add some AI to it, and it should spit out a cut that looks smooth. It should be to tell a coherent story in an engaging way. Before I started Edit Stock and Edit Mentor, I worked on TV shows in LA. And perhaps the most enjoyable part of that time for me was working with extraordinary editors, the best editors in the world, people who had edited the TV shows that I loved and watched. And what I learned from them, and what they all had in common, was that they added this bit to it, which is vision and perspective. A very clear vision of the story told through a specific character's perspective. Understanding the vision of a story starts a long time before editing, and I hope you guys factor this in while you're making your algorithms. Understanding a vision, having a vision of the story, it's an idea that's revisited hundreds of times. Great editors look at the dailies. That's the footage shot that day, and they understand the director's vision for how the scene should be put together. They'll read the script and they'll understand the writer's vision for how the writer wanted to put the story together. And they start assembling the movie in their mind's eye while they're watching the raw footage before they make any cuts. And they apply that vision to their decision making. I want to share with you now my entire screen. Let's see here. Okay, and I'm just going to give you an example of that vision. This is a very common problem, you know, which shot should come first. This is a scene from a movie called Bingo Night, and we have several camera angles. This wide shot here starts from behind, you know, an item in a pawn shop. Okay, and then we have, this is the main character, and this is the pawn shop owner. And he's buying her used jewelry. She's trying to raise money to stay in her apartment. Okay, we have a close-up of each actor or actress. We have her close-up. I think it's very common to want to create a rule here. We have his close-up. Okay, and then we have several other, we have another character in the background. And then we even have this kind of cool pinball insert here. We have a couple of these. So I think it's a pretty common question to ask, like, which one of those do you take first? And it's normal maybe as a researcher or as a student to think like, well, there should be a rule. We always start with the wide shot, or we always start with an insert, or based on the shot before, we do this and that. But there's a human element to this that a great editor will use. And that is, like I said, the vision of the story. So I know that this shot needs to go first. Let me share my whole screen again. Okay. The reason that I know this shot needs to go first is because the director put in effort in getting it. I mean, it's such a silly thing, but this camera move is only for the beginning of the scene. After that, the shot is locked off and it's just our wide shot. So I know that this was the plan. It might not end up being in the final movie exactly that way, but the first instance of it, you need to show the director their vision of it. You know, so this is like a human element that's very difficult, I think, for an AI to capture. The second item about scene character perspective, we're going to talk about in a second. Oh, I also wanted to mention there are also times when when an editor catches things, an experienced editor will catch things that an inexperienced or less experienced director might make a mistake. So here we have a script from a movie called Authentic. And this is the first scene, and we're going to introduce a pretty main character here. This is the chef. So the chef is going to send the main character on a mission. But if you look at the line script, you can see squiggly lines here. Squiggly lines mean he's off screen. So the first time that the chef speaks, we're in scene 1 on page 1, he's never on screen. And when we created our advanced class, so we have to start the movie like this. Any second now. Okay, that's the chef talking. Gather up. You too, Nicholas. This is the only shot we have of this moment. And the editor I was working with on that project noticed it right away, just looked at the script, looked at the coverage that was shot and said, you have to introduce the main character by showing their face on screen in an interesting way, and they don't have it. So they can actually inform the production on how to improve the project even before they cut anything. So great editors are also anticipating and identifying problems with the vision when they see the footage. And I don't know how you teach that concept to a computer. So what I learned from great editors is they always have a set of rules of thumb. And we all know this, and hopefully you're all working on these rules of thumb in your projects. those rules of thumb are often multiple factors, including some that are not in the footage, like, for example, how the director feels about a certain shot, or how much effort they put in, or their relationship with the director or producer. The list is personal. So this editor's personal list is going to be slightly different than another editor's list. And it includes their life experiences. And I'd just like to make perhaps hopefully obvious statement that two editors with the same AI tools should spit out a different thing. You're not looking for a perfect thing. You're looking to include the vision and perspective of the person who's making the video. When I was working in those cutting rooms, I cherished the nuggets of wisdom that were offered to me by these great editors, but they were often difficult to come by, which is why it can take great editors years to collect that wisdom. For example, I heard a great editor named Dan Lebenthal, who edits Iron Man and a lot of other Marvel movies. He told me once, when you're cutting parallel action, that's two scenes taking place at the same time, you should always leave one scene on a question. And that's just such a terrific rule of thumb that he carries around with him. But if you work on say 3 movies a year and only one of them have parallel action in it, you don't have a lot of opportunities to practice it. So that's where the seed, that was one of the seeds that came to my company, to forming my company, Edit Mentor. Edit Mentor is a pioneer of teaching video literacy. But the science of learning methods that we use are not new. Other subjects like computer coding and language literacy have already figured out that education for literacy, for these rules of thumb, it needs to be interactive, it needs to be fun, it needs to show you progress, and it needs to give you lots and lots of short examples that build up your expertise. Okay, and with that, I'm very proud to share with you all Edit Mentor. And hopefully you're seeing my screen right now. Somebody mention if you're not. Edit Mentor is a browser-based NLE. Everything you're looking at here, we built from scratch. This is running in Chrome. It's not Adobe Premiere. It's not Final Cut Pro. It is Edit Mentor. And you can see we can trim clips, move them around. But what we have here are preset examples. And the lesson we're teaching students today is how to tell the story from the main character's point of view. And to tell a story from the main character's point of view, there's a simple rule of thumb, which is they need to be on screen for the most number of seconds. So I'm just going to play this cut. It's between Don, who's the main character, and a delivery man. I'm not even sure if the delivery man has a name in the script, but essentially they're delivering a spa or a hot tub to the main character, and he doesn't really necessarily want it. He's lost his wife. So I'm going to play, and it was a gift for them. This is a 25-second scene.
So when she's full, just turn her on and she'll be cooking in no time. Is that everything? That's it? Knock off! Boy. So, Mike, when's your wife back? I have someone to Christmas with.
Okay, this is a real cut from a real student that was submitted to us. And if you were to just watch this cut point, you might follow the rule of thumb, which is cut on action.
Knock off, boy.
All right, we have a cut right on that high five. And what a great editor will tell you is that we want to tell the story from the perspective of the main character. So they're balancing that second rule of thumb, which is we want to show the main character on screen the most. And we ask the students to make an adjustment in the timeline using the rolling trim tool to extend the shot to include more of the main character looking sad. And I'll do it just right before that head turn to make sure that our action matches. And then.
So, Mike, when's your wife back?
When's your wife back is a very loaded line because the story is about the main character losing his wife. So we're going to cut to him right on that line.
When's your wife back? I have someone to grip my whip.
Okay, and hopefully now you feel like the cut is told through the main character's lens a lot more.
Is that everything? That's it. Knock off. Yeah, boy. So, Mike, we'll do what back? I have someone to grip my whip.
It's a much better cut. And now the fun part, I'm going to submit my answers and I can see if I got it right or wrong. And I can view all the possible answers. And I can see that if I had trimmed anywhere in this range, it would have told me that I got the answer right. But if I had trimmed a little too far, it would have said, oops, you know, you extended Don's shot a little too much. He's turned away. He's not giving the audience very much information at this moment. And on the back end, if we had trimmed, like added a little bit of Don, it would have said, good job, but keep going. You can add more. So it's a much more engaging way to teach students this rule of thumb. And if you look at our lesson, it's the entire lesson is all about giving one character or another more time on screen for various reasons. So we're practicing these rules of thumb. Our curriculum currently has 400 interactive challenges offering different rules of thumb. We teach things like watching and responding to footage. So how to think. You remember I told you that editors, when they start watching the footage, they already know how they want to use a shot. So here we have practice to do that.
All right. What's up? Need a favor. Tell me. Anything from my favorite dish. The chef needs to make just as many of these. Same flavor. What? If he's for having in the corn,
and then we would ask the student, what is it about this moment that the editor might notice? He likes Nicholas's reaction. He likes Ricardo's hand movement, or the editor doesn't like this moment. So a really fun, engaging way to learn. We keep statistics about how all the students answered the questions. So here you can see last year we had 30,000 students go through this lesson. And we can tell, we aim for an average score of an 85. So we can tell that the fourth lesson about ripple trimming is a little bit too difficult for students in a classroom, but the shot coverage lesson maybe is a little bit too easy. And then when we want to know what is it about ripple trimming that's difficult, we can drill down and find out, okay, 19% of them are getting the first question wrong. So we have a lot of great data, and this is a two-way street to help us understand how best to teach this stuff. How am I doing for time? I want to ask. Someone can help me out. Okay. The next phase of our mission is to allow students to upload their own footage and be able to edit their own projects and receive the same rules of thumb that I was just talking about. Which character, not showing the main character long enough, crossing the 180-degree line, leaving in common mistakes. And we have these, what we're doing is using our footage to build these templates. And this is all internal stuff. We haven't released this to our customers yet, but the idea is that we'll have a check my video button, and then the system will return where the student is making mistakes. So it'll say, you might want to add a little more time to the main character, or you cross the 180-degree line. In this case, the only rule we have turned on is that the student left in some black frames in the timeline. This is not a particularly difficult rule. It's more just to show you kind of the concept of what it's going to be. But we do have several rules working, and those rules are created by our AI engineers. Well, the rules of thumb, we have a list on a spreadsheet, but the actual implementation is done by our AI team. So I'm not sure, let me check on time, but I feel like I still
have some time, Misha. I think like at least a few minutes. Yeah.
Okay, then why don't I show you a couple of other, normally I start a timer on my side. So why don't I show you a couple of other challenges that we have in here from our broadcast journalism class. By the way, we teach lessons outside of editing in Edit Mentor. So for example, conducting the interview, we ask students to identify open-ended questions. You know, a little bit, I do feel like the AI shouldn't be used to just magically like do away with the editor. It should be a supportive tool and they should work together. In this instance, we're teaching students how to ask open-ended questions. And we hired students from a high school to make fake questions. So here we go.
Do you waitress or are you a hostess?
Do you waitress or are you a hostess? That's not an open-ended question.
Is it hard balancing school and your work?
Is it hard balancing school and your work? That might be.
What are the biggest challenges of balancing sports, work, and school?
What are the biggest challenges of balancing sports, work, and school? That's a great question. So I'll mark that one and submit the answers. We have different ways of answering questions. You can delete clips, trim clips, answer interactive multiple choice questions, or mark clips. We have plans to have them reshuffle clips and other question types in the future. Then if I press view possible answers, you can see we have these answer ranges within the timeline, and you can read about why an answer might be right or wrong. It's a very engaging way to learn. There are 250 pages of text within each course, which is difficult, which would be difficult for a student to read, but to absorb this way, they're much more likely to learn. And then finally, I can leave you with this thought, which is that, you know, when you see online there people saying like, you don't need film school, right? You don't need, or like they're, we can argue definitely about the value of film school or the cost of it. But what we should not ignore is that teachers actually know quite a bit about the science of teaching. When we were building Edit Mentor, when I had the idea for it, it was largely the tool, but it was only once I hired a teacher that my understanding of how to teach people actually came to life. And a great example of that is this chart called Bloom's taxonomy, where as a student is going through the learning process, the first thing they have to learn is simply to remember stuff, remember words. And then they have to be able to identify those words and define them themselves. And then they have to apply it to a new concept. Then they have to be able to analyze and then synthesize, which is when they're actually creating their own content, and finally evaluate where they're looking at someone else's work. So that we actually build this into our lessons. They start out in kind of an identifying way, then they move up to critiquing. Okay, so this is a little bit about Edit Mentor. I'm happy to have any of you guys contact me with questions.
Yeah, thank you, Misha, and it's a very amazing talk. We can see the great passions that you and your team on making such wonderful project. So the audience are very interested into your work. So we have collected several questions for you. And I think the first one is people are curious about where do you get the raw pre-edited videos from? And we know that you mentioned that there are a lot of efforts from some thoughts to final edited videos, including the vision as perspectives. And but for scientists, they are ambitious about how can we train the machine learning models. Is it possible to learn these techniques with already edited movies?
No.
Yes, that's so.
It is not possible to learn the techniques with already edited movies. And the way that you learn them is you follow the humans. I think the previous speaker said the same thing, because that part of the process starts significantly earlier than the finished movie. Clearly, there are editors. There are editors who get associate producer credit because they start so early in the process. They start almost from the script stage.
Yeah.
I
Where do
wonder,
I get-
like on this question, like I wonder if there is a relationship with writing, right? Like I wonder, like, is there an equivalent question? Like, can we learn to write or be better writers by reading other people's like finalized work? I wonder if there's an analogy here with movies, right? Like if you watch a lot of movies, I wonder if you are able to catch up good techniques or good kind of like editing patterns from there.
I think there is some that you can pick up. Mostly what you pick up is what's called style. And style is a whole separate category besides story and perspective. You story and perspective, which are the two most critical elements. Like, how do you teach an AI what lines to remove from a movie, or to remove a line from a movie where the person says the thing they feel? Like, let's say a couple is having a debate of, you know, like, I love you, will you marry me? And the other one says, I'm not sure. How do you teach an AI that it's better to take out the line, I'm not sure, and instead have a reaction where the person just looks and goes, and there could be a huge difference in the emotional impact of that. So I'm not sure how you teach an AI that, and you definitely cannot find that answer from watching the final movie without the source footage. The question about where do I come up with the footage and the examples? I'm also the owner of Edit Stock, which sells unedited movies to film schools around the world. Every major film school you've ever heard of is my customer: Emerson College, AFI, Chapman University, USC, down to high schools and middle schools. I've sold footage to, you know, the last week it was the education ministry in Israel, and this week it was to Malta. So all over the world, people are using edit stock footage.
Yeah. So yeah, based on the previous discussion, I also have a question from the audience. So they would like to ask, do you think editing professionals are the best to drive the coming wave of AI-powered editing tools, especially aimed at younger user base like Gen Z publishing videos on TikTok?
The answer to that is one that I give to business associates, which is ask customers about their problems, but not for their solutions. And if you were to ask an editor, a terrific editor who's won Emmys and Oscars, what tools they would like, they will ramble nonsense mostly. What you should do is give them footage and say, put this together and talk out loud as you do it. And you should give them cuts and say, review this cut and talk out loud as you do it, because those nuggets of wisdom come spilling out.
Yeah, that's awesome. Okay.
Oh, and
so,
Gen Z, do not for a moment underestimate the storytelling skills of Gen Z. I'm meeting with an editor next weekend who works on projects for YouTube. We're hoping to maybe collaborate on a course together, or at the very least meet each other. He edits for Mr. Beast, who has 100 million viewers on YouTube. 100 million, a third of Netflix's viewership, one guy. So you're going to tell me you're not going to listen to that editor?
But I mean, like the edit mentor, like, is it? I mean, like, who is the audience? Like, is Gen Z people working on TikTok? I mean, what are they interested on? Like when they join Edit Mentor?
From a business point of view, Edit Mentor is targeted towards high school and even middle school students, though we have colleges on the platform. A lot of our tools, I didn't even show you I just need to make sure to show you this because it's too cool to not show you. Hopefully you can see my screen. We also have a dashboard where the teacher can see the student scores. And then from the student's perspective, they can see their scores and they can see how they are progressing. Unlike what normally happens, which is where a human has what's called imposter syndrome, where they're not sure if they're actually getting better or worse, because the only way of measuring that is to show their cuts to people and get feedback from humans. But here they can see like, oh, I got a 59 in this lesson. What did I do wrong? And then they can review their answers and they can actually see like how did they answer? They got a 5 out of 10. They got this answer wrong, and they can get a different answer. So it's really, really cool.
That's really interesting. Yeah. So I think the time has already run out, but we still have a lot of questions. But I think we can continue the Q&A session on the chatting board, and then let me hand over to Alejandro. He will be hosting the next session.
Thank you. Can I add just one more thing? The very last thing.
Of course.
We are, I think a big reason why I wanted to give this presentation is because of the people in this room. We are looking for partners. We are looking to, we are looking for partners. So if you want, we have data that we're willing to share, or at least willing to collaborate on. So if you have any interest in that, reach out to me, please.
Yeah, please connect to Misha once if you're very interested. Yeah.
Amazing. So, thank you. Yeah, thank you, Misha. Thank you. It was an amazing talk. So now, following with the industry speakers, we have Pinar. And let me know, Pinar, if you can hear me. You can unmute yourself. I think I made you co-host already.
Yep, I'm here. Hello.
Okay, great. So let me introduce to you, and then I hand it over. Okay, so it's my pleasure to present Pinar. She is the AI director, an multidisciplinary creator, and an advocate for the conscious use of technology. She co-founded the AI studio Seyhan with her partner Gary Kopke. The firm has become the bridge between the cutting-edge science of creative AI and the world of entertainment. She has been one of the first creatives using face tracking, the first XR catwalk in 2016, and in 2018 she became one of the world's first AI artists when Google made a unique tool for her to create with artificial intelligence. Pinar's work also resides in permanent collections in several museums all around the globe, like Zurich, New York, Santa Barbara, and Amsterdam. She has talked about how humans will remain relevant in the AI age. So after this impressive CV, we really look forward to your talk, and I hand it over to you, Pinar.
Thank you. Thank you, Alejandro, for this introduction, and thank you all the organizers of this event. I'm already having the best day of my life. I'm learning from everybody. What a great high-pitch lineup. I'm so honored to be in your presence. I will just dive right in and will be sharing my screen with everybody. If somebody can remind me what I need to do to avoid funny drawings on my screen. So more, and I have to
disable annotations for others.
Annotations for, okay, I got it.
That will be it.
Perfect.
Awesome.
So all this while, everybody can see my screen, I presume. I hope you don't see this bar that I'm seeing. But anyways.
We actually do see the bar, but the thing is...
Let me do it again. Stop sharing, share screen, and desktop one. Okay, I don't know how to avoid it. But let's hope that it will disappear itself. Do you know how I can avoid this?
Not really, but I think it disappears with some time. Let's hope so.
Okay, all right. Anyways, I will have to start. Okay, great to meet everybody. Like this beautiful introduction. I am the AI director, co-AI director, and co-founder of Seyhan. It's been an amazing 2 years in the industry where we have become the bridge between generative art models and motion pictures. We are discovering the latest talents of AI artists and the latest generative models, and educating filmmakers, directors, production houses, advertising agencies in the best ways of how to welcome this life-changing technology. Our team is made out of filmmakers, computer vision specialists, generative artists, producers, writers, and in all, the main point of why we are in this is because we are simply fascinated with what this technology offers us, but also we crave to put human and the human power and the human vision and human creativity, human imagination in the center of all productions that are made with AI. We consider AI nothing but a tool that is helping us make cool stuff with less time and less funds. This simple image demonstrates why I'm here. This is taken in 2019 at Google I/O. I was minding my own business in 2017 when I received an email from Google Brain Lab in Zurich and Google Arts and Culture in Paris saying that they discovered a novel way of in simple creative words, mimicking the moment of human perception in complex academic language, the very moment how artificial neural networks visualize futures of an object. The person who invented this tool is Alexander Morvintsev. I'm pretty sure almost everybody in this room know who he is. He's the inventor of Deep Dream. So the first raw is his work, 2017. He published it in Distill.pub. It's called Future Visualization. It's credited to be one of the very heavyweight contributors to in the advancement of generative art. And the bottom row is my body of work as an artist, until I found myself being consumed by the fire of generative art in 2017. I was an artist doing my own thing. Like I have a collection at IKEA and I did cool stuff with patterns. I had my own fashion line. I've always been interested in advanced technologies, but this very moment really did change my life because Google said basically what they invented looked like my body of work. And ever since I have left all my artistic career in getting this technology to find its place, find its desired place in culture. So this is an image of my former work, my IKEA collection. As you can see, I have always, I mean, when I speak with academic people, when I use the word quantum, it's very complex for them to understand what I mean, because when you say quantum, it's like quantum computing. But when I use the word quantum graphics, I want to, what I mean is that they're multifaceted, ecstatic, complex, all in all, unexpected, out of the simplicity spectrum. I have always been interested in this type of image making, graphical manifestations. So I can say that I have a very intuitive understanding of generative models and have a great overview of how generative neural networks think and behave. So this was the outcome of my Google collaboration. Together with Google, we had a tool that was called Infinite Patterns. And so I am basically one of the first generative artists to have its own personal Google collab. I still don't understand the word of code. We have a team, an amazing team that master code, obviously. So Google made this tool for me where I was basically sliding some buttons and then writing some numbers, and these images were appearing on the screen, which made me super happy. So with this, we made paintings, we made digital patterns, and then in 2018-19, Google opened this tool for everybody to make art like me. So after that, what happens? Please, this is a little gift that is made by our team for everybody in this room that can understand Python. I just leave it for you to decipher, and then I will be explaining what it means in simple layman terms. It says with AI and creativity, we can change entertainment and film industry. So for the rest of the 15 minutes, all my talk about what we are doing at Seyhan, how we are bridging machine learning and filmmaking is based on creative thinking and imagination. So I will be showing very cool works that we have produced over the past 2 years that involve all your favorite models, generative models that you know and you may not know. My work partner, Gary, and I, we have this analogy. We call academia the manufacturer of guitars. And we at Seyhan, we write the songs, but we also make the fuzz pedals that make the sound different than the original guitar. So we not only do storytelling, create and produce our own films, make VFX for films, or we make installations immersive or NFTs, but we also develop our own tools for advanced filmmaking. Different ways. So my presentation will be structured in different chapters. One, I will be showing different ways we integrate creative AI into film production. Then I will be showing some examples from our productions. And the last one, I will conclude with our creative AI lab. So one of the things that our studio offers is concepting. This is actually a recent request by a producer based in Los Angeles asking us, okay, I want all the investors to imagine, and the director that I'm going to find, how a movie of that is a combination of horror and Jurassic Park would look like. For those that are familiar with generative models, this is we used Dawit to be able to visualize these concepts. Of course, before generative models, people still could do concepts, but obviously this is such a fast tool. And also it inspires us in our thinking process. So to make this image, we use only this face of the T-Rex and also this corner of the image. And all of the rest that I am amplifying, that I'm structuring here, is generated by Tali. But of course, when I'm saying, like, I will be regularly using made with, generated by, but all I know is that none of the things that I will be showing you would look as good as they are unless the imagination and aesthetical vision of the creator who is co-creating with the machine. This is another service that we're offering. This image that you are seeing, a storyboard, is created by one of our collaborators, partners, John Gospel Iberum. Currently, together with him, we are working on the storyboard. We are generating a storyboard for an LA-based production. I wish I could show you the cool stuff we're doing, but I cannot. Instead, I will be showing the sample from John Gospel's, his own work. This is a little bit of an insider thing that we discovered while working on stable diffusion plus Epson. This sample, this mocap sample, is made by using these two technologies. Is that if ever you're using mocap for very bright images, it doesn't really work. But with horror, since everything is a bit dark and misty and like smoky, the creative, like the theme of the movie can shade some of the imperfections of the tools we are using. So I'm only guessing that academia will involve in mocap, and we will be having much more amazing results, and we will be using in many different titles and pictures in the future. Color and ambience. This is again, unfortunately, this is a Google Slides presentation, so it's not super high definition, but when it is 4K, you can see that with generative models, we can add very slight texture as if this is a painting to the picture. So that enables us to go beyond the regular color correction for pictures. And VFX, those that are familiar with different generative models, this one is made with Stable Diffusion's the forum. Of course, it has been 2 years, actually 4 years for me since I'm in this, since 2018. Like, I wake up and all I do is to identify the top talents in the industry, like the best people. We call them AI whisperers. When academia or researchers, publishers, they publish a notebook, that doesn't mean that they are the experts in how to use it. They are the experts for the genesis of an invention. And then it's up to the best creators to connect that sample with the audience. So we are very proud that we have the capacity to use in the most artistic manners already existing generative models. And this is an opener sample. This is in-house. It's not made commercially. I will be showing you, this is an idea for an opener where we can use generative art. It plays a little bit low resolution the first time, so I will be playing it 2 times. It's a very short clip. Oh well, we're in luck. It played high definition. Okay, so these were the services that we offer as a studio, and I will be showing some examples from our productions. Connections, it's a short film that we have done for Dekel. For those that do not know the brand, it's one of the world's biggest home appliance manufacturer, and they were the main sponsor of FC Barcelona. So I will be giving some statistics about this film. So the client that hired us, Dekel, directly, so we created and produced the film. The film has 90 million views in YouTube, and it brought us the Oscars of advertising, which is D&AD Awards in VFX Emerging Realities. And the client was very they really love to measure metrics, like measure data about how well the world's first high budget short AI film performed. So what they discovered is that before this movie was made, which is about their sustainability stand, all the other ads that are about their brand featured Messi and other like famous football players from FC Barcelona. So our film, which is about nature, you will be seeing it, it's just a minute, performed 28 times better than any other ad that featured Messi. And when people were asked, like, why are you watching this? Because they're like, I have never seen something like this, and I want to know what's going to happen. So hereby, we learned that actually generative art really like captured the attention of the audience, because we all became experts, especially since COVID, of content watching. So we're watching the same things over and over, but whenever there's something novel that is introduced to the screen, people are captured. They don't want to stop watching. Okay, I leave it with you. It's only a minute. Please enjoy. I will be happy to answer all your questions. Oh, sorry.
When did we decide that we were above it all? As if nature were apart from us, when the connections are many. We are every blade of grass. We are every flower, every breaking wave, and seashell, every leaf. Every creature that has ever drawn a breath, or taken wing, or plied the depths. We think we aren't connected, but we are more than we will ever imagine. What happens to one happens to all.
Yeah, this was a great example on my analogy on guitar, fuzz pedal, and writing the song. Obviously, we wrote the song, but then the song involved style GAN. I'm pretty sure everybody knows what I'm talking about. So we did. So we first wrote the script, and then we made storyboards. The client approved the storyboards, and then we started shooting the movie and creating data sets for our custom style GAN outputs. So we did 20 different, but then we ended up using around 8 and 9. But then our biggest problem was like the creative input required a seamless transition between the ending of a GAN and the beginning of a GAN. But then when we selected seeds and then we outputted the GANs, then the ending obviously didn't connect with the beginning of the next one. So we had to write a very short notebook about how to take the ending of a GAN and to create a seamless bridge to the beginning of the next GAN. So with this film, we use mainly style GANs, but also there was a tiny style transfer. I believe you spotted it. If not, ask me, I will tell you. The next movie that I will be showing you, sorry. Oh yeah, this one. This is for those, I don't know if there's any Web3 enthusiasts in the room. If so, I'm pretty sure you're familiar with Star Atlas. They're a Solana-based video game that is going to be launched this year. And they didn't even launch, but they raised more than $200 million only with the power of selling NFTs. And we had the honor to make their mission statement. They're a very power to the people group of people. So they're all about using blockchain, AI, and all these advanced technologies for the elation of humankind. So again, this is another production that we wrote, created, and produced. It's a minute and a half. This time there's a tiny bit of live action, but it's mainly the CG that they have given us, which is the trailer of the movie, and the AI that we have used. Please watch, and I will be answering other questions later.
I am Joni. I live among the northern stars. In your world, they do not exist. But in our minds, in this moment, we are connected. Are you listening? For the reality you know is an illusion, a figment, a thought experiment, an idea scribbled on the back of a cosmic napkin. Soon, it will begin. New universes will arise, not from big bangs or distant stars, but from within you. From within you will come forth things the likes of which you have not dared dream. Stars and planets, and creatures that never were, worlds without beginning or end, ruled by love and light, where humanity can rediscover itself, touch the face of time, rise to the greatness you are capable of, unbound by the shackles of those whose power controls you. This is the metaverse. Here, at the confluence of what is and what is possible, the infinite nexus that is Star Atlas. Make ready. The great transcendence is upon you, upon all of us. Take my hand. The journey is about to begin.
I will be also present in the next panels, and there I would love to talk about how we have solved the technological problems of the limitations of generative models with our creativity. But I believe I will not have time right now. So I'm moving forward for the next production. This is a film by Maartje van Nijwegen. She is Dutch. And this movie is about the power of psilocybin and meditation on human psyche. It is sponsored by the institute where Carl Jung taught, Zurich Institute, and the director in 2020 challenged us in making sequences, AI sequences, that will remind people of psilocybin journeys. In other words, make the spectator feel like they're tripping without taking mushrooms. And with AI art, as you know, like it almost needs to come with like a warning of like strobe lighting. So it was really not hard for us to make people feel like they're tripping, but then we had to do this in the style of the movie that fits the whole aesthetic visualization. So during this trailer, that is about 2 minutes, I will please try to spot the generative arts in between. There are in total 5. I can explain what they are later on.
Psychedelics have been around in human culture since before recorded human history.
What does this mushroom know that we don't? What does it do that we can't?
Psychedelics are all about connections. Indigenous communities have known that for centuries.
When you look into the eye of a child, it's all wonder. And then, of course, we have to restrict our wonder to the practical things to do. And the price we usually pay is that we forget the total mystery of it.
My specific question was always trying to understand the gap between the psyche and the brains.
They have been looking at the brains for all these years from the outside, and we have been looking at the brain from the inside.
We were interested to know how meditation training enhances the effect of psychedelics.
My question to them is that helpful to you? Science can open up as much as psychedelics can open us up to appreciate the mystery or to be in awe. I'm very worried. I think we are destroying our biological base where we are depending on to live. And we are seriously threatening that kind of balance. We are so stuck in this materialistic worldview that we need something that really can get us out of it.
I have another insight about the power of generative art used in motion pictures. Marcia, who's the director of this film, she had this controlled audience, 200 moviegoers, before it was launched in film theaters. She made them watch the film, and she said that the audience made, so as you have seen, excuse me, I wanted to precise this before, the trailer has two different generative models that we use. One is obviously style GAN with the mountains moving, and the other one, this infinite zoom that is made by, it's a custom model by Alexander Morvintsev. It was his 2020 or 2099 submission to SIGGRAPH. So what Marcia said that there were two times very long sequences of generative art. One was a zoom and the other one was the mountains. And she said that only two times during the screening of the trailer that the audience made euphoric sounds like gasps. And she said that these were the times of generative art. It's an amazing insight for us to continue doing what we're doing. This one is super fun. It's mainly only style GAN. It's a music video that is a remix of Alanis Morissette's You Oughta Know song. It's something around 3 minutes. I let you watch like a minute and a half. It's really fun, and I will move on to the next production.
I want you to know that I'm happy for you. I wish nothing but the best for you both. An older version of me, is she perverted like me? Or she go down on you in a theater? Does she speak eloquently? Or will she have your babies? I'm sure she'd make a really excellent mother. Cause the love that you gave that we made wasn't able to make it enough for you to be open wide. No. And every time you speak her name, does she know what you told me until you died, but you're still alive. And I had to remind you of the message you left when you went away. It's not fair to deny me all the cross I bear you gave to me. You hard enough. You see.
Okay, I'm going to move forward. With, of course, every production, we are learning how to master these tools, not only just use them, but use them like an AI whisperer. It's a word that we came up with, how to use them in the most optimal manner. And we use that, actually, you have to color correct in productions again before you train it, because if not, it creates really messy results. But anyways, this one is not from film, but from an experiential industry. It will be shown in Outernet, the entertainment district of London, on big screens. It is developed with Vadim Epstein. It's actually originally a 12-minute sequence that is about from Big Bang to Bitcoin. It's a sequential experience that shows all the most important inventions and happenings in the history of Earth and humanity. I will only show a few minutes and then I will continue. Oh, sorry. Okay, I know I have 2 minutes left, so I will be wrapping this up. I will be showing some examples from our Creative AI Lab. This is again currently, this is filmed in Outernet, again, the entertainment district of London, an artwork that we did by using the model Jax that is based on Clip. As you can see, like it's an ongoing quest of our studio is to create beauty, like human standard, ultimate, tasteful beauty by using generative tools. I'm going forward. Oh, this one is very cool. It's a sequence that we made for an installation in Istanbul, as you can see here, and we use disco diffusion, and we collaborated with one of the main contributors, model writers, contributors of disco diffusion, DevDev. Okay, this one is really cool. It will showcase very clearly the limitations of the technology, but it also promises the future where physically, geometrically, and temporally consistent pictures are made. So as you are seeing, you're thinking, how did they do this? Let me tell you, we used nerves and stable diffusion together to give the impression as if we are filming Johnny Depp in Pirates of the Caribbean. So we are entering with nerves, we can enter in his glasses, and then we see another reality that is generated by the forum, and we come out and we are back to the same person again. Oh, this one is a very cool sample. We are partnering with like brands. This one is Doritos. They were wondering how generative art would influence their content, so we made some samples. This one is Porsche. This is quite an early sample, 2019. If we were to do this right, we would of course have Porsche cars, film them ourselves with the same lighting from the same angles, train them much better. But it shows the research in our Creative AI Lab. And I am ending with two images that I'm not going to explain, but leave it as a suspense. One is this one, and the other one is this one. We will be revealing two creative tools that we are going to put out for the film production in the next weeks. Thank you so much. And this is me if you wish to get in touch with me. And just like Misha said, we're constantly looking for partners like Tali, who showed these amazing tools that we can use in professional production. Or if ever you invent something new and you think that it can be used, we would love to be the first ones to connect it with the film audience. So thank you so much, and I'm happy to answer any questions.
So thanks, Pinar. It was an amazing talk. It's amazing to see these kind of works actually working. You know, we are in the research environment, we see the images, we see the videos, but like seeing it in production and seeing it like making real things is just really exciting. So we will have time for one question because we're moving forward to the panel discussion. So then we will have more time to talk. And this question is actually from the YouTube stream, and I will just read it. So David Lin says, I really like the connections video. The transitions between concepts are pleasantly seamless, from hair to grass, for instance. Can I ask, is there any particular way of finding these concept links? Do you basically, how do you find the link between hair and grass? Or how do you actually do this? Or is the AI who is figuring it out?
No, AI doesn't figure it out. Like I said, all imagination, creativity, and vision lies here. The one who's being clapped when you finish a lecture, you're never clapped for your factfulness. You're always clapped for the power of your spirit. The human spirit is the innovator. Never the machine is the innovator. Machine is always a tool. But one of the insights that I would love to give about creativity and using generative tools is that currently, as you can see, things are a bit mushy with generated pictures. Like they're not like crystal clear. They're not like 100% 8K. I'm talking about when generated, not upscaled. So there's like limitations. So what we do is that, for example, with the connections, the writer that we work with, we educated him for like ongoingly few days about how generative models work and what their limitations are. So he custom wrote a sequence, like a movie sequence for a custom script for the film that we would shoot. Whereas for the Transcendence film, it was a normal script, but then a normal script, just like the writer wrote something, but then we found the answer in the use of AI, like why all of a sudden CG turns into AI and AI turns into CG and why things look different than we're used to experience them. And then we realized that Star Atlas's main character is an alien, that blue-faced alien. She's the main character of the game. And the way aliens see the world is different than the humans see the world, I presume. So this whole movie is told from the perspective of an alien, how she experiences the world. And then she says, come join me at Star Atlas. Then we are showing much more CG. So with creativity and imagination, we found a reasonable explanation of why we're using generative motion pictures.
Amazing. Yeah. Okay, awesome. So this is it for Pinar, really. Thank you again for joining us. It was a great talk. And now I'm going to leave you all with Ali. He will be the host of the next session, in which we will have a panel discussion with all of our speakers. So you just can take it over, Ali.
Thank you, Alejandro. Hi, everyone. I'm so happy to be here hosting this panel discussion. We got so much nice feedback last year from everybody, how much they like these discussions. So on this edition, we have not just one, but two panels. And we're going to start with the first one. And if I can ask our invited speakers and panelists to maybe turn on their cameras and show around so we can all engage in this discussion. This is a panel about academia and industry in this field of creative video and image generation and editing. And we're gonna try to touch these topics. So what we will do is we curated a list of questions that we got from Twitter and from engaging with a bunch of people. We try to cover everything that we're asked. We're gonna spend an hour talking about this. I'll ask some questions, direct them to maybe one specific person to initiate the conversation, but please feel free to raise your hand or engage at any point. Maybe what we can start with is some really short introductions. I know some of you guys already contributed and talked, but some have not done so yet. Okay, I can see that everybody. Are we missing anyone? I think we're okay. Okay, good. So let's just do very quick introductions, and then we can start with the panel. So maybe we start with the people who have not spoken yet. So who do we have in here? Yaz?
Hello, I am Yagiz Aksoy. I am an assistant professor at Simon Fraser University. I'll give a talk later today. I work on computational photography. I guess that's all you need.
Thank you. Who else is here? Russell?
Hello, my name is Russell. I'm the co-founder of a startup in Silicon Valley called Cyberfilm AI. And we want to use AI tools to help people make movies. And we also make our own movies. So we use the tools that are talked about here today. So thanks for having me.
Thank you. Is Raffay here? think he's not. Okay, we can continue. Maybe Mark, you want to do a quick reintroduction for the people who just joined us?
Yeah, hello everybody. My name is Mark Riedl. I'm a professor at Georgia Tech in the United States. I work on a variety of AI techniques for a variety of sorts of things in creativity involving story generation, game generation, everything but video. But I keep one foot in human-computer interaction and one foot in artificial intelligence.
Thank you. And Misha, you want to do a quick reintroduction as well?
I'm Misha. I'm the owner and CEO of Edit Stock and Edit Mentor. Edit Mentor is what we presented today. We're an educational company, and I'm happy to pitch in when I can.
Thanks. And Pinar is still here. I guess everybody's here. Maybe a quick reintroduction as well.
Yes, absolutely. I am the AI director and co-founder of Seyhan. You have seen our work in the presentation of before. My biggest interest of why being here is generative models that enable filmmakers to create sequences that reside outside of our perceptual realm. Generative art creates different outputs than CGI and real-time on camera. So I'm really interested in these otherworldly graphics that belong to the transcendental realms.
Thank you. Okay, and I'm Ali, as I said, so I'm a research manager at Meta based in Zurich. So my team works on tools for content generation. And we have a nice mix of research and products. So I'm really happy to be in this panel where we're going to hear from industry leaders and academic leaders about the things that are going on in creativity and generation. And I'm going to kick it off with a question targeted to industry, maybe, and maybe Pinar can take this one to start with. And like I said, just raise your hand or interact at any point. And one of the big questions that always arises when you work in academia is basically, what is of interest to the industries? What are these topics in the field of creative generation of images and video and on editing that you think are at the core of what you would like to see and what you want to work on?
Thank you. This is an amazing question. I don't ask any other question to myself other than this question. So you just asked my day and night and my dreams all in one sentence. It's actually, I give this information to our partners as a service. So I cannot exactly say what I think should be invented right now publicly. However, I will still touch upon the basics of what I think should be invented. Like I explained earlier during my conversation, AI shall all times be in the service of the people. So what shall be that service? First of all, it can be inventing something that has never been residing in the perceptual realm of the creator. For example, what Paul Debevec did with Campanile movie in 1997, that ended up being the main reason, the main technology behind the bullet time of Matrix, photogrammetry, HDR, and which is also the main technology behind NERS. So that sample created an entirely new way for us to understand the reality around us. But then when we are right now, for example, what the forum or what like these generative models, CRIP and VQGAN, what these are providing to us is a reality that resides, again, just like photogrammetry outside of our perceptual experience. So I'm extremely interested in for these tools that only parallel processors can create to be improved. And like Tali said, physically, geometrically, and temporally consistent tools that are definitely necessary, because right now with these generative art tools that are being toyed with artists, it's very nice for them to be the first. Oh yeah, look at my visual magic, I'm the first to do that. Film industry doesn't give a damn about if you're first or last. All they want is control, rightfully so. So all they want is the execution of the producer and director's will, which is great, because to be a director of a set of 1 million people, okay, I'm exaggerating, but you see what I mean. you need to have a certain control and malleability in the tools that you are working with. So if I were to, so this was the intro to my answer, but to be more to the point to the answer of what should be invented, we have to catalog and analyze who the creators are. Like, for example, the needs of the creators emerge while they are using the tools, but who are these creators? Like, the needs of a producer is different than the director. The needs of a VFX artist is different than the director. The needs of a VFX artist that works on the virtual production stage is different than a VFX artist that works on a game. Or to be even more granular, a VFX artist that is specialized in compositor and shading is different than a VFX artist that does lighting and texture. And the insane part of it all, they do not know what they need until we show it to them. So who did we know that we had to be hooked with Midjourney and type away our dreams, you know? So and for all of that, I mean, I think it's going to be one of the next topics that we will be talking about in these inventions of what is next. I highly recommend healthy dose of creatives that are partnering with academics, because with their way of thinking outside the box, they can help academia on advancing their inventions.
Thank you. Okay, so we need creativity to inspire creativity, in a sense. So thank you for that. Russell, you had your hand up. Go ahead.
Okay, thank you. Can you hear me?
Yes.
So all the talks so far have been really great. Thanks for inviting me as industry or a budding industry, sort of a startup, maybe one day a big company. But so I had a question for Misha, and actually at the end of his talk, he said, hey, does anyone have any ideas? You want to reach out, collaborate? And so just shared some notes with my brother. He works as an assistant director on like Hollywood movie sets. So you mentioned that you have data. It's hard to watch someone edit, but you have sort of editing data. So his idea, and my question to you is, do you think this would be interesting? What about like a little add-in for Adobe Premiere Pro or Avid or Assembly? And so it would read the editor's report from the script supervisor and then assemble the best takes and do a rough cut, and maybe even read the script and use the AI for transitions and basic effects. And then the human editor, you know, that's an ACE member, could actually take that and do the final job. So there's still a human in the loop, but it could be an interesting product for the editing industry. What do you think?
I think
open to everyone as well.
I think, well, okay, just before I do, Pinar, your answer was amazing. Your presentation was amazing. I learned, thank you for being here and for that answer. And you're right about everything you said about, especially at the end. Okay, the reason that Edit Mentor exists in the browser and not within Adobe Premiere or within Final Cut Pro as an extension is because our target is education. We don't want a student to be required to have a certain piece of hardware. They don't have to have a Mac to run on Final Cut Pro. They don't have to have you know, a MacBook Pro to run Premiere. And also because when we create it ourselves, you know, if we were to create an extension, it could only do whatever Premiere can do. So having things pop up over certain clips is not something we could program in. There is actually an Adobe Learn panel. We just think our way is better. There are already products that will create rough cuts for you. I strongly recommend checking out Philip Hodgett's Lumberjack, which is a logging program while you're on set, and then you get a transcript of a speaker talking. You can edit it like an email or a Word document, and then it spits out a cut for you. I think there are obvious next steps to that, which is the tagging of B-roll that can be added on top of clips that use the same words. We're going there. And, you know, probably there's nothing to fear because it's going to happen and it's going to be helpful. What I'm talking about is like getting past competency to amazing. Because no Hollywood, you know, for yourself, for your home movie, competent can be plenty, but no one in Hollywood will take good over great if they have the time and resources.
Okay, thank you.
Thank you both. Okay, let's move on and kind of reverse the question a bit, and this is more directed towards the academics that we have with us. And basically, we want to know what do you think are the areas where academia should focus on from your perspective, and how do these affect the process of the creation of these products that we want to see shipped? So maybe Yaz, you want to take this first?
Sure. So a lot of things are happening in academia. We are seeing the generative models. We are seeing the text to image, video, whatever synthesis models. We are also seeing a boom in the computer vision capabilities that we have, which means that we are about to be able to re-render a photograph we take, because now we are able to get the geometry out of it, and we are able to understand and change the illumination out of it. We have great demos. Our results look great. It is very hard for the artists to use them. It is challenging for the industry to integrate the near vision capabilities into existing pipelines. So I think once in a few years we figure out all the necessary computer vision parts that will enrich our image editing and video editing capabilities, I think we should start focusing, as it was mentioned before, working with artists who will use these tools for real in everyday production more and more, to develop like intuitive or productive interfaces that can be used by masses, essentially. We cannot hear you, Ali.
Yeah, maybe a follow-up in here. You mentioned that some of these things are not easy for artists to use or to get them into production. What do you think are these big constraints that we're facing today? Is it just a matter of compute? Is it a matter of data? Or are we designing things with the wrong perspective in mind?
Well, when Pinar has been doing some great work on integrating these tools into a real production pipeline. But that's what she does, right? That's what she does. It's not not everyone can do it. That's her specialization. What we want to have is for any artists who are using Premiere Pro every day to use them as a part of their daily life. Right now, they need specialization. They need to either learn to code or find some people who can code, you know? So one challenge when working with production teams I faced is the unwillingness to change their pipeline. They like their tools, they like their extreme control they have over them. They want to keep using Nuke or whatever they are using. We want to put the tools that we have. We need to be able to, you know, adapt the capabilities that we have into that pipeline so that there won't be a resistance from the artistic or production teams, or that it won't be very costly for them to relearn an entire new tool or something, and instead augment the existing tools and pipelines to support the new capabilities in computer vision we have.
Thank you. Mark, you want to give it a go as well?
Yeah, I'll weigh in. I think Yagiz says all the important things, right? So, you know, there's many facets to the research side of things. One is obviously better algorithms that produce better quality. But, you know, at first the algorithms are designed without the user in mind, right? It's about technical achievement. And I think we have to kind of now start thinking about what users need. And this is often more of a human-computer interaction sort of issue, or human-computer interaction working with kind of AI experts. So should we be talking about, you know, who are users? Are they experts? i.e., are they studios who might hire AI people or studios to do the AI? Are they amateurs, home people who will never have those sorts of resources or the time to figure out these tools. Their needs are going to be very different. Also, what success means for them is also very different. As I think, Misha said, competent versus, great, right? In terms of, but I think, a lot of people are thinking, well, to be a successful academic in here, I have to be, I have to work with, I have to invent the next Tali, right? But I think there's actually a huge array of research problems that span between artificial intelligence, machine learning, and human-computer interaction, usability studies, human factors, and psychology. So for example, just the question of, should our tools be designed with all the knobs necessary inside for amateurs to use up front? Or do we come back in and we take great technologies and we build, user interfaces around to expose knobs? How do we expose those knobs? Do we need explainability, interpretability, so we know when we turn these knobs, these sorts of things will happen. When I turn these knobs, other things will happen. Or do we leave it more as for users just to kind of explore what all these esoteric hyperparameters mean? And I think the big one, picking up on what Yagiz said is, Pinar said this, controllability, right? A lot of our tools are kind of one shot, fire off. If it doesn't work, go back to the drawing board, try something again and again and again. How do we kind of allow the human user, whether they're experts or novices, to inject more of their understanding of what they want? I don't think that's just fancier prompts, but there's a lot of things that are in our heads as human creators that are very hard to articulate and state. And yet that might be the difference between success or failure. How do we expose what the creative processes in the human mind are to our algorithms, just to kind of flip things around?
Thank you for that. So I think this kind of segues to a similar question based on what you're talking about. And we've mentioned professionals and we've mentioned amateurs, and we're talking about today, I think Misha talked about a one person having a YouTube channel and they reach an audience that is massive. So we have a whole range of people who can benefit from these kinds of tools. My question here is, what do we see as the main differences to create products, whether it's in the research realm or in production? What are the main differences that we need to take in mind when we want to create products for what I'm calling now, for lack of a better term, amateurs versus professional video editors and creators? And what do we have to keep in mind where we're designing these things, whether it's in research and production? And I think this is a good question for everybody. So who would like to give it a shot first?
I can go ahead.
Yeah.
Two things for the film industry. Like I said earlier, they're not interested in drawing like a professional artist. The two things that they're interested in: first, how can you do this for less money? Two, that is the B of one, how can this cost less for me? And three, which I am here, how can you make something that we cannot make with any tools, any other tools that are available for us? Then this the Campanile movie, the bullet time of Matrix, comes into question. And whereas for the artists, for the amateurs, there has, the word art is can be very intimidating for a lot of people because of this like mysticism that is created by like these like phenomenal like tabloid headlines like Picasso being sold for $200 million, or like this art exhibition you cannot talk, you cannot touch. So people has been like viewing art as something like a hierarchy, like where they feel inferior if they cannot paint or draw. So these generative art models are absolutely taking away the mysticism of like the artist. I mean, I don't want to say mysticism, but like the unattainability of the creator. And any tool that supports the creator in feeling freely self-expression and feeling freely in the same line as a great maker like Picasso, that is a win. And I have a few other points, like the one which one was it? Yeah, the other is for example, with the filmmakers, like it's very, very, very important for them to be able to, when talking about generative scenes, my main specialty is more generative art. Like, for example, if ever when you receive a script and when you are translating that script, it doesn't matter how creative you are in the way you interpret the script, like a creative and an amateur. Like in the Star Atlas movie that I have shown, we have used our creativity in interpreting the script that our writer wrote. Film industry of $100 million budgets of superhero movies can't care less about your creativity. It's all about, okay, here is this plane from 1920s. You have to make exactly 1920s plane that crashes in a building, and while crashing, two characters which need to look exactly like this, let's say, and exactly like a robot with pink elephant ears. And they have to be chatting and saying these words to themselves while the plane is crashing into a tree or whatnot. Like you can't make this with the fun and artistic qualities of generative art. So in order to understand what filmmakers want, or how this works and how we can serve them, I suggest identifying the lacks or the holes or the difficulties of the production scale. For example, VFX is extremely expensive, like really extremely expensive. So already like for example, if you want to make a city, like a good city costs $650,000, like the background of whatever Batman. A low one that is unusable is $150, a mid one is $350. Like this is a problem, it's like really expensive. And people idle away doing repetitive tasks. The second one is revisions. Like you're a storyboard artist, you know how many revisions you get? Unlimited. Like you don't sleep when you're doing the storyboard. So if there's a way to take that burden of revisions, it's not the fun part. The fun part is the invention part. So I think I suggest like for the academia or the developers of tools to study the unfun part of the creative process. So we leave much more time for humanity to remember that we're born to be visionaries, not like repetitive, robotic, like assistants.
Thank you for that. Russell, go ahead.
Sure, yeah. So that's a great answer. But so if I add anything, I actually mentioned in the chat earlier sort of what is taking amateurs to professional, or what's the difference now between AI generated video and what Martin Scorsese would call cinema or a film. And it seems to be, so touching back on an answer Mark gave earlier, seems to be that AI lacks the intentionality to share wisdom or a lesson about humanity with the audience. It's a collection of images and sounds, and that's why it makes a good music video, but it's not a movie because like the robot, it's not trying to make you a better person or teach the audience something. And so that's why our model, we really believe in still having a human in the loop. So it'll never be, Netflix reads data and then generates a movie and auto publishes it. It will be humans, like Pinar was saying, using the tools. But at the end of the day, there's still a human filmmaker. They had a vision. It helped them execute the vision for cheaper and maybe better quality than they can afford, but they still put their name on it. So the human in the loop adds the intentionality. That's what I think is missing.
I like this perspective. I think this is one of those things that if you're a hardcore academic, sometimes you're too focused on solving these very scientific problems. And we forget a bit that this thing will eventually make it to the hands of somebody. And I also think this all ties to the definition that Mark was trying to do about creativity. I suppose that's a bit hard to define, of like, what does it mean to be creative, to create something? Thank you for this contribution. Misha, you've worked with, your company does a lot of things for students, as you said, but you also have involvement with other editors. And I suppose you've seen the spectrum of professionals and amateurs in this field. Based on what you've heard and the things that, what do you think should be the focus of these AI tools of the future for these different audiences, or what would you like it to be?
The focus of the AI tools of the future. Okay. To Pinar's comment, I worked on the first season of American Horror Story, and over a Labor Day weekend, I remember sending 3 shots to our visual effects house who had created Benjamin Button, if you know that movie. And at the time, it was really cutting edge that they could age a person back. So we aged back Jessica Lange, and I remember the lead editor telling me it cost $60,000 a shot, and each shot is 3 to 5 seconds long, and we sent 3 of them. And it's astounding how expensive. I've worked on a show with Chris Carter from the X-Files, where we shut down downtown LA and had a helicopter crashing, virtual helicopter crashing, and 1,000 zombies and whatever else. To the academics here, I just want to liberate you from the pressure of making money on your ideas, or making them practical, or making them marketable. Just make them cool. That's it. That's your guiding light. It should just be, can I do it? Plenty of people will come along and figure out how to make money on it. And that's our job. Don't feel like you need to do everything. If you work for Adobe and your job is to put something into the marketplace, basically your job is to reduce drudgery. I've never worked with an editor who wishes that they could sync all the dailies themselves and hates the fact that they have to hates the fact that they automatically sync dialogue with picture. The future of AI tools, all I know is it's coming. And I don't think any one of us, there's this hive mind. I don't think any one of us knows, as my father would say, it doesn't matter what any of you in here are doing. It matters that you do it, because collectively, the best or the most useful ideas or the most fruitful ideas will come to the top. Anyway, take the pressure off yourself. That's my message.
Thank you for that. That's amazing. Okay, so I hope everybody listening, all these PhD students that go through the daily struggle, you get something out of this, and it's try to enjoy it somehow and come with the cool things. I really like this perspective as well. I think once you go and work in industry, you have to face the fact that some of this has to go into products, and then you get the pressure of doing that. But for those who are still working in academia and are students, this is the best advice I've heard. So really take it into hand. I'll also direct this question to the academians that we have in here, and what's your perspective on designing research that makes it into production, thinking about amateurs and professionals? Mark, you already touched kind of on this in your last answer, but do you have something you want to add?
Oh, well, I never think about putting things into production, right? I mean, Misha really kind of said it. The academy exists to be 5 to 10 years out from production. So, our job is to think about things that people have not thought possible, to make them as possible as we can, and to find new ways of thinking about things that we know is possible, to make them better, more interesting, more usable, those sorts of things. I'm going to take this question in a different sort of way, because I think a lot of the things that are coming to light today, and I think, and in the image generation and the music generation communities as well, are kind of these parallel communities here. I think we are all kind of starting to recognize that, you know, these things can transition from the lab into the real world. And so I think there is a realm of interesting questions about how to facilitate that. Because if we do understand and build for use and users, you know, maybe it will transition out into the real world. But at the same time, you know, there's certain people who are, you know, should also not be thinking about that, because those sorts of constraints can also kind of be inhibitory as well.
Yeah, absolutely. And I think that brings maybe another question based on that. And I'll give it to Yaz first, and then we'll come back to Mark, which is, if when you're in an academic setting, then, you know, you might not be thinking about this production end goal, but you get some creative or inspiring ideas coming from somewhere. So what's the process in your research group and for yourself to come up with these ideas, or to choose these ideas that you want to focus on in this field?
Well, we are a very, very highly applied field. Of course, we have to think about production. Like what we do is maybe the future's application, but it is still application. I am not in directly the generative process of research. I am working on the computer vision side of it. And how do we develop? Well, we have an overall goal in in my group. We want to understand everything about the world from a single photograph. We want to re-render it completely so that we can so that Photoshop becomes a Blender, you know. It's very far away. It needs a lot of work on it, but that's our goal. As we see the developments in the computer vision research, and we realize new applications, new ways to apply these new findings to computational photography processes. There we have to be aware of the applied science side of it, but we really have to have the background necessary in the academic computer vision side of it. And somehow they come together, they get developed into full-on papers and applications in the end. I cannot give you any more details on how does that connection work. It naturally works over months and years as we work as a team, I guess.
Thank you. Mark, you want to add something to that about the process in your team or yourself?
Yeah, I mean, that's so hard, right? Because research groups are different, research challenges are different. You know, what I said about thinking 5 to 10 years out, I think is key, right? I mean, I think we can all imagine, what do we want to see industry, the real world, being able to do 10 years from now? And then I think we can work backwards from that and to say, well, what's the next step from the current state of the art that we need to get there? And then you take a small step and you say, you reassess and you say, well, have I moved the delta towards this long-term vision? And then take the next step and the next step. And predictably, these next steps are paper-sized, 6-page nerds, super-sized contributions. So scoping is also important, because you can't take an entire 10-year agenda and then just say, I'm going to work on this thing now. So, you know, planning out is great. And I think, you know, my personal experience is sometimes you plan out into the future and you take this little step, and the first steps are often algorithmic. You know, like, well, we just don't have algorithms that can do anything like that. And then either you discover more about the algorithms that aren't working and you make them fancier or more sophisticated or more capable, or whatever the right term is. And then sometimes you also kind of say, well, they're actually starting to work a little bit. Now let's think about how people might actually put these things into practice. And when I introduced myself, I said I kind of keep one foot in HCI and one foot in AI, because there are first-class citizen research questions about how people can do the things we want to do 10 years out. And sometimes I jump the gun. There's this nice technique that HCI has introduced, which is called the Wizard of Oz study, which basically says, let's put a human in place of an AI, pretending to be an AI, who is, human level capable of doing art or editing or whatever it happens to be. And let's see how people interact with that human, study that interaction, so that when our algorithms are ready, and they're still not ready yet, we know something about, let's say, the knobs, as I call them, the parameters, which ones are useful, which ones are not useful. Right, so it allows us to basically do speculative fiction, imagine the future earlier than we might be ready for the future.
Thank you. Yeah, so I mean, research is creative in its own way. So that's part of the discussion, I suppose. Okay, let's the next question that we have is about basically what's happening now that we have these tools in here. And I think, Pinar, you will be a great person to start this discussion. And some of it you've already covered in your presentation. But what does everybody see as being new inspirations for these artists and creators now that we have the tools that we have today? What have you seen and what would you like to see?
Great question. Of course, text to image is such a magical thing. It's something, it opens new doors in my mind as a creative. Meaning, as a creative in a brainstorming session, you have your own algorithms that are different than the algorithms of others. Meaning the way you reach a creative solution is different than how Joe reaches to a creative solution. But then by working with generative tools, I am expanding my own algorithms on how to reach to a solution because they're opening up new doors in my own perception. Again, I give this as a service professionally on what needs to be invented, so I cannot go in great detail in what I think will be the next thing. However, again, I can broadly cover some main points. These are the usual suspects, but temporal coherence. If ever somebody, I think Mark said that, we have to think about the end game and then imagine the steps until we get there. Temporal coherence, temporal cohesion, both. I always mix them up. One is about a succession of images that are coherent with one another, but then the other one is the fact that the frames are generated smoothly. Another is that I would love to see a character, the character that I already defined, for example, him. Let's say that our character is this face, and I would like the machine, the algorithms to place that particular character in space-time that I will be defining. I would like the AI tools to understand, again, space-time and real-world physics. So there's a room, there's a definition, or how big is the room? What is the definition of the room, or what is the ambience? Light, different camera qualities, different angles. These would be the inventions that I would love to see. And another, this is more professional talk, a bit the surface of things. But in the amateur talk, I was, for example, my auntie never has experience with imagination. So even though you give her a mid-journey, she doesn't know what to type. Because it's on Discord, it's too complex, she cannot figure that thing out. So if ever there was a tool in her phone, just like Instagram, where she can experiment and play and make little things that she can show her friends, I think it's a very important factor for an amateur tool. Look, I made this. Because you're dealing with a business person that never ever had any experience with creative outlets. So this whole I made this is so very important. So of course, when I say something, you interpret I made this different than any other. So I'm hoping that this I made this aspect is an important point.
Thank you. Absolutely. By the way, for the audience, if you guys want to throw in any questions, if you're following us on the live stream and you want to write them on YouTube or here on the chat, we still have a few minutes. We can throw 1 or 2 questions before we're done. I'll also direct this or a similar question to Russell. What are with the current tools that we have, is any of this inspiring some new things and your company, or things that you want to, that maybe you've not developed them yet, but you want to develop them in some way?
Yeah, I'll give an example which I've seen, I think everyone would appreciate, and then just one about myself. So recently I saw that an architect, a professional architect, was using an image generator, stable diffusion, I think he had an idea or a dream for what if there was an apartment built in a giant redwood tree that grew, and the apartment buildings all grew as the tree grew, and it drew it perfectly. And he got featured CNN and Architectural Digest. So I think it's all, as everyone's been saying, it's a tool. If you give the same tool to 2 people and one's skilled and one isn't, you're going to see crazy results from the skilled person and probably nothing from the other person. And so that's why I never think it's about replacing jobs. I think it's about growing them and giving more skill to people who just don't have enough time to draw every idea that comes to their head. So then as far as an example for us, so like I said, my co-founder works in Hollywood, and we make indie films based on our own stuff. And we have a screenplay, and we went to go do a storyboard. And we had to hire a director, photographer, cinematographer, and they were too busy, and it's going to cost $10,000 and take 8 months. So we just took his script and copy pasted all the scene descriptions and pasted them in. And you just say a sketch for a movie that is of a man and a woman about to kiss on the top of the Eiffel Tower. It'll give you like 10 options. And then you can say, oh no, I wanted a portrait or a medium shot or an establishing shot first. And it'll do it. So we saved ourselves a lot of money and a lot of time. And so I think that stuff like this is inspiring. It's not about AI will make all the movies of the future. It will be the 2 kids in rural Idaho who, never had a chance to make a movie can now make a movie and a storyboard and do writing. And maybe one day deep fakes and Unreal Engine 5 and all this stuff, right? And just film it 2 people with motion capture suits. And so I really think it's going to grow the creative industry.
I love it. Okay, yes. We do have a question from the audience. We've mentioned a lot text and text to image or text to video. And it seems this is a hard problem to solve in a sense. And the question from the audience is, do the panelists think that text is a good expression of creative intent when it comes to generation, or should we be thinking about, generating from image to video or video to video or some sort of other prompt in here? Yes, yeah.
Well, that's text or language is what we use to communicate with each other, our artistic intent, right? This new connection between text and image, text and videos blow my mind. It's amazing. I've been waiting for it for many years. I think it is a very effective way. It doesn't have to be the only way. And when we are using it, we are not able to use it right now as if we are talking to each other. We are not describing our dreams. We are finding the keywords and the name of that artist who we would like to steal the genre from, style from. And we have to put 20% this, minus 20% that, whatever. Okay, it is still much more richer than us drawing something or us having to find an image that somewhat describes what we want so that we can feed it to the network and stuff like that. So I think text is very promising. I think language is very rich and we can play with it in multiple dimensions.
Thank you. I mean, I like that, we highlight language in here, right? I mean, it's because we say text sometimes, but obviously what we mean is language. So thank you for that. Anybody else from the panel want to give it a go?
I can chime in, I guess. Language is a primary modality from humans communicating with humans, right? We don't have to learn how to express our ideas through language. But it's also not, and I'll say it's got some advantages over, say, video to video, because, producing an example video or an example sketch or something like that may actually be harder than talking. But language, I think, ultimately is got a couple limitations. When I think about when I interact with my team, my research team, right, we're often multimodal, right? We're talking, there's got to be feedback, talking back and forth, not just one way. Sometimes we have to bring in a whiteboard. Sometimes we gesture a lot and say, I want things here and things here, I think that there's a lot of stuff that you don't have in language. The other is technical. These language text to image, text to video things, they still kind of get pick and choose what they want to attend to. And so they miss our intent, right? So they're not perfectly capable of reconstructing our intentions from language. So my sense is there still needs to be something else in addition to language. I'm curious what those things are. I don't know what they are, but the more multimodal we can make things, the more we can make our AI systems actually kind of handle the understanding problem, because I don't think they actually understand us. The more we will have successful collaborations, and the more we'll feel like these systems are our partners with us, as opposed to, kind of mindless tools. If that's what we want, right? There's also an argument that says, we want them just to be tools, too, right?
Absolutely, yeah. Anybody from our industry panelists?
I have an out of this world idea that doesn't fit in none of the monetary gains that one can ever have. It's not related to the industry. It's for my own pure artistic satisfaction. So about this, answering the question, video to image, or image to video, or video to video, or text to video. How about frequency to video? For example, Earth has its own frequency. Have you guys seen these guys that, I don't know what the name of that machine is, but mushrooms, mycelia, have their own frequency that is different than the frequency of light or whatnot. When you stuck this machine to mycelia, they make this otherworldly sound that you didn't hear that sound produced by a man. It's really weird. So, like I said, I'm much more interested in academia putting their efforts, both save me from time and money, okay, but also create some things that I can self-express in ways that I cannot self-express with the limitation of my linear mind. If academia were to come up with a way to visualize frequency, wow. And you're partnering with me when you're doing that.
All right. This is recorded.
For real. Yeah, for real. Yeah. It resounded. Even it traveled, like even through on a screen. Yeah.
Okay. Thank you. We are almost out of time. So I want to give everybody the chance to tell us a bit about your vision of the future. And it doesn't have to be, we all agree that it's very hard to predict anything, and it's very hard to know where things are going. But we can all have a vision and some dream of what we want to see in this realm and in this field. And the best thing about visions and dreams is that they can be as crazy as we want. They don't have to be rooted on any science right now, or anything in there. And maybe one way to just inspire everybody is for each one of our panelists to give us their vision of the future in the next 10, 20, 50, 100, or 1,000 years, who knows, of where this field is going. And I have Russell with your hand up. So yeah, you can go first.
Sure. So get asked this a lot about AI replacing jobs, impact on the creative industry. Will there be no more artists? I think it's crazy. There will always be human artists, but AI might take over a job like a truck driver, which I would say is not healthy. It's not desirable. It doesn't even pay that well. let's say robots do take all those jobs and maybe there's a universal basic income. It's a topic here in America. The government just sends you money every month to just be yourself. What would you do with all the time? I think that most people would go into the arts. So they would start a band or write poetry. And for me and a lot of people, and I think 1/3 of US teens, their dream job is influencer on TikTok, video generator. So I think there will be an explosion of creativity, diversity of voices, and these tools will just help them do this stuff they never learned because they didn't go to film school. They don't know anyone who edits. It's very hard stuff to do. But I think eventually we will have these sort of one person think of an idea, press a button, and get a full movie made. And for better or for worse, I think it'll be awesome though. I want to see all your movies.
Thank you. Thank you. I love this perspective of it will give voice, and it's always good to hear diverse voices around the world. Thank you for that. Yaz, what's your vision of the future or in this field? What do you want to see?
That's a very tough question, Ali. Now everyone will say just some random wish they have because I don't know. As you said, in 5 years, in 10 years, 2 years ago, did you think we would have Dolly and Stable Diffusion? No, you wouldn't have. You know.
Mm-hmm.
But the thing I like here is similar to what Russ is saying, is the democratization of the artistic process. Now there has been discussion in the chat that, language text is not enough for artistic intention. Well, yeah, nothing is enough. Video is not enough, right? You have to create the artistic thing with the intent that you have so that it is there. It will never be possible to give that artistic intent, like describe it perfectly so that the computer can do it. That's what we've been talking about as well. The human has to be involved and so forth. I do not have as positive of a view on with Russ in terms of in general overall society-wide how AI will affect us. Truck drivers losing their job will not automatically come with universal income. Not in the US. I would be very surprised. I wish, but I don't think so. It will create more and more problems, I think, because we do not have the systems to deal with this industrialization level of change that we will see as AI tools dominate every place. In the artistic domain, we are happy. We are excited, right? In the 90s, we had Photoshop. Now everything is Photoshop. We do not even think about it. That's what's gonna happen. In terms of what Pinar wished, not the frequency stuff, but going into the physical space and essentially recreating the studio so that you can do any edits that you forgot to do in the studio or during the shot. Now you can do it. I think that's where we are going. I am excited about it. This will also make it possible for a rural teen to make their own movie, but I don't think it will be me clicking a button and making a movie. I think artistic process, whatever tool you have, is a long process, and it is often a team-based process. I think we will get more and more tools to support this digitally. I think we will bring the real 3D world into the digital space more and more effectively over the 5-10 years, so that our editing tools supported with AI will come with a revolution similar to what Photoshop did like 30 years ago.
Thank you for that. Misha, you want to go next?
Happy to
what
go
are you
next.
Dreaming of?
I wish I could contribute more to the AI part of the discussion, but I'll just tell you that the vision of our company of Edit Mentor is video literacy for everyone, specifically much younger children, because it will help them build a business, express their minds, and change the world. And I want to add to everyone really listening here that creativity is a messy process. It's not a straight line, and your failures are just important as your successes. So to everyone listening here, I wish you both many successes and many failures in the next year.
Thank you for that. Mark.
Yeah, kind of along the same theme. Sorry, artificial intelligence can be a means of enhancing and augmenting the human experience, what it means for us to be human. Creativity is obviously one of those things. As I said in my talk, AI doesn't make us creative. We're already creative, but to the extent that it can help us express that creativity effectively, right? There's a billion people with ideas stuck in their heads, right, that aren't going to come out. And if we can make the things that allow them to come out, that would be an extraordinarily powerful democratization was the term that was used for that. In the medium term, to get there, our tools have to be interactive. They have to work with us to, they have to provide us the right control knobs. And, from an AI perspective, I want to see an AI system that says, I like your idea is great. I'm going to work with you on this, but here's something else that I thought of. Maybe we can incorporate that for it to become a true kind of constructive dialogue.
Thank you for that. And finally, Pinar.
Yeah, I will, I think, give a out-of-the-box suggestion. It again has to do with frequency type of worlds. This whole, I lived in Netherlands for a very long time, even though I'm Turkish and Canadian. There, the mindset, especially in Europe, is I don't believe in things unless I see them. Like frequency is there. You cannot touch, you cannot see, but it's there. Like we cannot dispute the fact that it's there, but we cannot see nor measure it. So I would like to see with the, and I don't know if any of you have been in a mushroom or ayahuasca journey or had an out-of-body experience, had a lucid dream, or you know what I'm talking about, these parallel processing states, I call them, that reside outside of our perceived linear realm. I'm extremely interested in developing with any of you tools that help me bring to life these states that I experience. And I'm not talking about sticking neurons, like artificial neurons in my mind. I'm not interested in that. Like I have enough imagination to provide and explain. But I know that there is a realm that resides outside of our eyes. And filmmakers are having trouble visualizing these realms. And the more and more interested in consciousness, awareness, spirituality, all this the power of the spirit of humanity, the more we will have much more requests in VFX to cater to the visualization of these realms. Like show me emotions. Like, okay, I can yell, but how does it feel for me to be angry? Like show me my feelings. So I'm really, really interested in developing that part with you guys.
Thank you for that. I love this because we did have a question related to that I never put into the list, but this was an answer to it. So thank you for that. I want to thank everybody that came today. I want to thank our panelists for the amazing discussion. I really enjoyed this. I hope everybody else did. I hope the panelists had a good time as well, talking with everybody. Thank you so much for being here. I am going to pass it now to Alejo, I believe, to take it on to the next level. Thank you, everybody.
Amazing, guys. Great panel discussion. It's so exciting to be here, really. It gets better and better. So actually now it's time for the papers, like the human labor, actually, the PhD students that are actually doing these things on a daily basis. So we will have a set of a few talks, and I will be calling you guys. If you are here, please, I will try to unmute you. Just give me 1 second to find the order. So Dawit or Dawit, I don't know how to say your name. The anatomy of video editing. Let me see if you're here and I can unmute you. Yeah, you're here. Okay. So before you guys, I made you co-host. Just make sure that you can share your screen, and while you set up everything. So we have a set of prizes, and we will actually let the audience pick which is the best presentation. So we created this Google form. I already shared it on Twitter, so you can actually find it there. But you can also find it here on the chat. So for the ones who are sticking around to listen to the presentations, please feel free to go to these Google Forms and vote for your favorite speaker of the day in terms of papers. So I think Dawit, if I am pronouncing your name correctly, I hope so. Just you can take it over, and you will have 7 minutes, 5 minutes, and 2 minutes for questions.
Okay. Can you guys hear me?
Yes, we can.
Okay. What about the screen? Can you guys see the screen?
Yeah, it is there. Perfect.
Okay.
Actually, can you actually disable the annotating so we make sure that there is no Zoom boomers around?
Okay.
And view options and disable annotation or something like that.
Yeah, I
okay,
disabled
great.
it.
Thank you.
Okay. I'll start. Hi everyone. It's so great to be here. My name is Dawit Mureja, and I'm a PhD student at KAIST. I'll be presenting our work titled The Anatomy of Video Editing, Dataset and Benchmark Suite for AI-assisted video editing. And this work was done in collaboration with Adobe Research, with Fabian Kaba, Junyoung, and Marcus Whitson. So lots of films are released every year, as we have heard from our panelists and the amazing talk that they gave. Film editing is a very tedious task. Editing a single scene in a movie requires collecting a set of raw footages, and then the editor has to actually select the shots and then finally assemble them in order to make an edited scene. So in this work, we want to raise the research question: can we partially or fully automate the film editing process? So the ideal approach would be, let's say we have a script and a set of unedited footages or text. So we can build an AI model that actually takes the script and the unedited footages, and then it does the shot selection and assembling, and it will give us out the edited scene or a rough cut, and human can involve to make the final scene. However, we don't have a large-scale dataset that could be used to train such a model. So what we did in this work was more of like a reverse engineering. So we tried to learn general editing patterns from a large set of publicly available movie scenes. Here are the contributions in this work. We introduced the Anatomy of Video Editing dataset, which contains around 200,000 shots and more than 1.5 million cinematographic labels. We established a benchmark suite that includes 5 different tasks for AI-assisted video editing. And along with each task definition, we also implement competitive baselines and provide extensive experiment analysis. So here is the overview of our dataset. So given a scene, we use a shot detection method to actually detect the boundary of the shots, and we dissect each shot and we label 8 cinematographic attributes of the shot. We also label the camera setup each shot belongs to and the start and end time so that we could study the composition of the scene. So diving into the cinematographic properties we label, the first one is shot size, which is defined as how much of the setting or the subject is displayed within the shot. We have 5 categories in this attribute: extreme wide, wide, medium, close-up, and extreme close-up. And the other one is shot angle, which is the location where the camera is placed to take the shot. And in this attribute, we have also 5 categories: aerial shots, overhead shots, eye level, high angle, and low angle shots. And the third one is shot type. This one refers to the composition of the shot in terms of the number of features, featured subjects or their physical relationship within the shot. And in this category, we have over the shoulder shot, single shot, 2 shots, 3 shots, insert shot, and group shot. We also label the shot motion, which is the movement of the camera while taking the shot. It can be either pan or crack, tilt or pedestal. It can be a locked shot, or it can be zoom or dolly, and then it could also be handheld. And we also label the shot location, the environment where the shot was captured. It could be an exterior or an interior environment. And we also label the shot subject, whether the shot features an animal, a location, an object, a human, or a limb, or a face, or a text. And we also labeled the number of people that are actually featured in the shot. If there is no human, there will be 0. Then if there's only 1 human, if there are 2 people, 3, and if there are 4 or more, then we just labeled 5. And we also labeled the sound source of actually the shot, whether it's coming from the on screen, or if it's off screen, or if it's external narration, and if it's external music. So on top of the annotations, we define 5 downstream tasks that are closely associated with video editing. And the first 2 tasks are related to automatic footage categorization, and the last 3 tasks are related to sequence editing. So the first task is, given a shot clip, we want to predict the 8 cinematographic properties that I just described. So given a shot, we want to predict what's the shot size, angle, type, motion, location, subject, the number of people in the sound source. So for this one, basically, we use a visual and audio backbones to extract features, and we use a multi-classifier to predict the classes. The next task we define is camera setup clustering. So given a list of shots in any order, we want to group the shots that belong to the same camera setup. So we do a feature extraction. And then we do the feature clustering based on the extracted features, and then we try to actually categorize the shots that belong to the same camera setup. And the third task is shot sequence ordering. So this is more related to the actual editing, which is, given a sequence of contagious but randomly shuffled shots, the task actually aims to predict the order of the shots as they appear in the actual movie scene. So for this one, we try to use a high-level feature fusion as well as a low-level feature fusion, where we individually extract features from each shot and then later try to fuse the features, or we initially actually concatenate the randomly shuffled shot and try to predict the order. And the fourth task is actually next shot selection. So in this case, let's say we have a partially edited footage, and our task would be to predict what shot should come next out of a candidate of available shots. And for this one, we try to define it in a contrastive way. So basically what we did is we tried to extract feature from the given context, which is the partial sequence that's given, and we try to pass it through a sequence, an LSTM layer, and we extract the anchor feature from the LSTM layer. Then we attach the correct shot that's supposed to come right after the context, and then we define that as a positive feature. And then by attaching any other shot that's not supposed to come after the given context, and that would be a negative. And based on this anchor, positive and negative feature definition, we try to approach a contrastive loss and try to learn next shot selection task. And at last, the missing shot attribute task, which is given, let's say, the first shot and the last shot, and we want to predict the attributes of the intermediate shots that are between the 2 shots. And this is similar to the first task, which is based on the classification of the attributes. So for this one also, we just used audio-visual features and then try to apply a classifier on top of the extracted features. So these are some of the experimental results that we got for the shot attribute classification task. So the main takeaway for us was, instead of trying to do the multi-task setting, training individual classifiers for each shot attribute actually performed better. Also, we found out that using both audio and video features gives the best performance. These are some qualitative results for the shot attribute classification task. And these are some quantitative results for the camera setup clustering task. So in this case, we try to use pre-trained ResNet, CLIP, and other 3D convolutional architectures. And what we found is that on top of ImageNet pre-training, a model that's pre-trained on the previous task, which is shot attributes prediction, actually extracted better feature for camera setup clustering. And for shot sequence ordering task, we tried to actually compare the performance of our model like relative to humans. So we conducted a survey and asked around 160 people also to order randomly shuffled shots from movie scenes. And we found out that humans also struggle a lot when the shot is represented only as a single frame or in a video format without audio, but human performance actually increases greatly when audio and video modalities are given. So exploiting the content of the audio in the form of speech or other relevant representation would be important to imitate human comprehension in order to solve the short sequence ordering task. And one thing we also noticed is that our baselines actually have implicitly learned most common cinematographic patterns, such as the insert pattern or the intensify pattern. And for next shot selection task, we compared our baseline with a random chance cosine similarity, and we were able to actually get a much better accuracy compared to a random chance or cosine similarity. And at last, for missing shot attribute prediction task, we found out that incorporating the attributes along with the video and the audio modality actually also consistently improves the accuracy of the model. These are some qualitative results for missing shot attributes prediction. So in conclusion, in this work, we introduced the anatomy of video editing, which is a dataset in the benchmark, and we gathered more than 1.5 million manually labeled tags. We also annotated the shot transitions and the camera setup in the movie scenes, which allowed us to recover the scene composition. We strongly believe that our dataset will foster the design of new relevant tasks for AI-assisted video editing. We could use it for editing pattern formulation and analysis. We could use it for editing style transfer tasks. We could predict pace or rhythm recommendation for cutting, also soundtrack selection for movies. We hope you'll be able to use our dataset. For more resources about the dataset, please refer to the project page. Thank you.
Great, amazing paper, really interesting. So I guess we have time for one question. And Sebastian asked, have you considered also using language model for sequence predictions? Yeah. So I guess he's, yeah, go ahead, sorry.
Yeah, so in this work, actually, we haven't used language modality, but actually using the script or automatic transcription from the video itself actually helps sequencing the task itself. We are trying to actually build upon this work as an extension, and we have found out that using language modality actually significantly helps the short sequencing task.
Yeah, I guess also, I mean, something about language models is the autoregressive part of it, right? Maybe doing it in a sequential way, not like all in one shot, but
yeah,
like just using the past. Yeah. Okay, very interesting, Dawit. So now our next speaker is Sebastian. Sebastian, I made you co-host. I guess you should be able to share now your screen.
Okay, thank you.
So you can just whenever you're ready. Like, I mean, for the speakers, there are some questions being posted in the channel. Just feel free in the chat. Sorry, feel free to just answer to them. We don't have that much time for you guys to reply to them just in front of everyone, but maybe you can still interact in the chat and like I mean, share your contact with people, and yeah, feel free.
Can you see my PowerPoint slides?
Yes, we can.
Okay, super. Okay. So hi everyone, I'm Sebastian Løske from Aarhus University, and I'll present our paper, Text-Driven Stylization of Video Objects in collaboration with Serge and Sagi from University of Copenhagen. So editing and stylizing videos using human instructions often requires both domain expertise as well as unintuitive and complicated software. We seek to eliminate these requirements by instead specifying a edit or a stylization through an intuitive and semantic user instruction in the form of a target text prompt. So our method takes as input a video, an object in the video, and then a target text prompt. The result is then a video where the object is stylized according to this text. For example, given a video of a black swan swimming in a lake, we produce matching stylizations according to a given text. These stylizations are then applied to the video object in a temporally consistent manner. And with text, we're then able to express both these complex and also abstract stylizations without requiring any manual editing skills. Our method is able to generate both natural and consistent stylizations for objects for a diverse set of videos and target texts. And importantly, our method is zero-shot, so we do not require any pre-trained generator, and instead we take as input only a video and a target text. To apply these edits in a temporally consistent manner, our method uses this atlas decomposition method presented in the paper Neural Layered Atlases. NLA, they decompose this video into a set of 2D atlases, where each atlas provides this unified image representation of an object or the background over the video. And the video can then be reconstructed from these predicted 2D atlases. Also, edits applied to these atlases are then automatically mapped back to the video in a temporally consistent manner. However, editing these atlases still requires requires manual editing skills from the user. NLA, they train their method for reconstruction using these intermediate atlas representations, but we instead want to specify these edits via text and use this NLA method for reconstruction, or to apply these edits in a temporally consistent manner. And with this purpose, we first train the NLA model to do this reconstruction, and then we use a set of objectives that we want to minimize with the aim of matching the style of the foreground object with that of a target text. To train our model to stylize these foreground objects, we first uniformly at random sample a set of frames from the input video and pass them to this stylization model. This gives us a set of stylized frames. From the stylized frames, we do a view sampling procedure that generates both local and global views of the object we're stylizing. We then compute a loss function that takes as input this set of sample views, as well as a global and a local target text, which is given by the user's input. This loss function then includes a local loss, and the local loss computes a semantic loss, which is a cosine similarity between the local views and a local target text, where both the views and the target text are embedded with this contrastive language image pre-training model, also referenced as CLIP. The local target text then includes local specific semantics, such as rough cactus skin. And the sample views of this local loss contain a more zoomed in and detailed view of the object we're stylizing. Hereby, the local loss can focus on texture and fine-grained details of the stylization we apply to the input video. Our loss objective also includes this global loss, which also computes a semantic loss, but instead between these global views and a global target text. The global target text then includes the context of the object we're stylizing. For instance, here we have a swan with cactus skin. And the intended goal of this global loss is then to preserve the overall context as well as global semantics of the stylization. So here we see an example of the effects of each of these loss terms. So in the first example here, we have the results of having combined all losses, which gives us this natural stylization that shows both characteristics of a swan as well as this crocodile skin. And without the local loss, we see that the results lack fine-grained detail. And without the global loss, we see that these global semantics are less clear. We also demonstrate that varying the specificity of the target text prompt affects the level of detail in the stylization. For instance, if we have this boat made of wood, and we then add dark walnut wood, or even add a fishing boat made of wood planks, we see that these different text creates very different stylizations, and even that being more specific in the text gives us more detailed results. We also add neutral prefixes to both the local and the global target text. A neutral prefix could be a photo of a and then a target text, which in this example is a dog with Bengal tiger fur. Here we demonstrate that adding prefixes increases the robustness as well as the quality of the results. And also that having more prefixes to sample from in each iteration gives us these more detailed results. So to conclude, we can say that we developed this intuitive and semantic control for stylizing objects in videos using text, and that our method is able to generate consistent style changes over time. We stylize these objects in videos using both a local target text to control the fine-grained details and a global target text to control the global semantics of the stylization. We also demonstrate that the specificity and the prefixes of the target text can have a significant impact on the details produced in these stylizations. And for future work, it would be very interesting to look at extending this model to also be able to generate shape changes or even new objects from scratch. So visit our project website for more results and details, and thank you for listening.
Great, Sebastian. Thank you so much. Unfortunately, you can actually interact with the people in the chat. I don't think we have time for the questions because we're a little bit late for the next session. So I will have to hand it over to Mark. So Mark should be now able to present on behalf of Armin, which unfortunately couldn't join today. Thanks, Sebastian, for presenting and for joining us. So just feel free to just reply to the questions in the chat.
Okay. So now it's my presentation.
Yes, now it's you, Mark. Go ahead.
Okay. Can I share my screen?
Yes, I think you should be able to do it now.
Okay, let's try it. Can you see it now?
Yes, now we can.
Okay, great. So my name is Mark Last. Together with my colleagues, Chang Liu and Darmin Shmilovich, we are presenting today MND, a new dataset and benchmark of movie scenes classified by their narrative function. The setting of our research is that the success of Hollywood movies is partially attributed to the notion that filmmaking constitutes both an art and an industry. It's an artistic tradition based on a standardized approach to cinematic narration. The field of video understanding is focusing mainly on recognition of low-level information, such as a person is driving a car. On the contrary, the field of narrative understanding deals with more high-level information, like a person is going back home from work, which of course is a more difficult task to recognize than just identifying that a person is driving a car. More specifically, our research is focused on identification of narrative structure of a Hollywood movie. What is the goal? The goal is to recognize the narrative structure of a movie by recognizing the key events in that movie via scene classification. We have several contributions, novel contributions in our research. First of all, we introduce a new task for movie analytics, identifying the latent narrative function of each scene in a movie. We also introduced the first benchmark dataset of movie scenes labeled by their narrative function, and that dataset is released to the research community. Finally, we demonstrate that the movie's latent story structure can be automatically detected using conventional machine learning algorithms and a limited set of some relatively simple scene features, which can outperform strong temporal distribution baseline. According to a book by Blake Snyder, which is called Save the Cat Goes to the Movies, each scene can be associated with one of 15 story beats. These beats represent the progression of a movie storyline. The numbers that you can see on the left represent the number of minutes since the start of a typical 110 minutes movie. Just briefly, a few examples. The setup beat, the setup scene class introduces the hero and other movie characters, the stakes, and the goal of the story. A catalyst beat knocks the hero out of his or her before world that was shown in the setup. And the third example, a beat is called, which is called the story, which represents a different story, such as a love story, where the hero deals with her or his emotional side. Our movie narrative dataset, called M&D, includes 45 cinema movies from the movie graph dataset. The scene splitting is also based on the information in the same dataset. We rely on 119 human annotators who labeled about 6,500 different scenes. The available labels included the 15 story beats mentioned in the previous, presented on the previous slide, and also a label for another beat. Eventually, the set of labels was reduced to 12 only. We also had 9 movies with gold standard labeling performed by expert scriptwriters. On average, we had 3 movies labeled by the same annotator, and each movie had at least 5 distinct annotators. In our machine learning experiment, we have split the dataset of 45 cinema movies into 5 balanced folds. We applied feature engineering to calculate 7 different features for each scene. And we compared the accuracy of the majority rule and the level position benchmark to XGBoost classifier. So XGBoost classifier produced F1 measure of 0.31, which was statistically significant above a static baseline classifier. This indicates that machine learning algorithms can learn the sequential character of key elements in a movie storyline. The value of scene classification by the narrative function is in extracting the high-level abstract concepts associated with each story type. And this classification model may be probably enhanced with more elaborate features such as character emotions and audiovisual scene characteristics, including, for example, background music. And this dataset can be used to detect even higher level narrative concepts. Thank you very much for listening. We'll be happy to answer your questions.
Okay, great, Mark. Thank you for your presentation. So feel free to reply to the questions in the chat.
Okay, great. So good morning, afternoon, evening, everyone. My name is Bartolomeo Vacchetti, and I'm sorry, I wanted to activate also the camera. Okay, and I'm Hello everyone, my name is Bartolomeo Vacchetti. I'm a PhD student at the Polytechnic of Turin in computer science, and I have a master's degree in movie and media engineering. Today I'm here to present MovieLens, discovering and characterizing editing patterns in the analysis of short movie sequences. So why editing patterns? Well, as many movie critics such as Walter Murch and as many of you highlighted, editing has a key role in the structure and the quality of a movie. So, for instance, you can have good actors, a good story, a good soundtrack, but if you have a bad editing, the resulting movie will be mediocre at best. So, previous researchers already addressed many similar tasks, such as initial prediction, various assisted video editing tools, and also a lot of data sets that enable movie analysis have been released in the past years, such as also anatomy of dataset and the others that were presented earlier. So for our dataset, we have decided to rely on CineScale, which is a dataset that contains 120 movies from 6 different directors. And from every movie, a frame has been sampled every second and labeled with the following classification system. So from extreme long shot to extreme close-up, plus the foreground shot, which is a class that contains elements of different classes. So we take all of these movie sequences and we split them, movie sequences which with all the labels of every frame with its class, and we divided them into 30-second long sequences. And the resulting dataset now has more than 23,000 movie sequences. So our main objective here is to understand what type of correlation there is between the editing style adopted, the editing sequence of shots, and what is actually shown in the corresponding video. And in order to do that, our main contribution are the following: a data-driven methodology to cluster short video sequences, a machine learning algorithm able to classify short sequences, and preliminary data characterization results. So we have devised the following two-step methodology in order to conduct our analysis. Each step is intended to solve a task of practical nature. And for instance, at the beginning, we have unlabeled data. And so the first part is called the level estimation phase, in which through a combination of the levels and distance and k-means clustering, we're able to label our data. How do we do that? We have created 8 artificial sequences. Every artificial sequence is a sequence of all, for instance, we have a sequence of all foreground shots, a sequence of all extreme close-ups, and so on. And then, sentence by sentence, we have measured the levels and distance from the selected sentence and the 8 artificial ones. These distances were then used as 8-dimensional points coordinates. And then we apply the k-means clustering to find the best partition of our data. So since each point corresponds to a sequence, the group in which the points lies will define the label of the corresponding sequence. So at this point, we have labeled data, but still we have no idea what the identified labels actually mean or represent. So in order to analyze that, we trained a classifier. In our case, it was a simple multi-layer perceptron adapted to perform sequence classification. And after training, we analyzed the results. So we have tested our approach with different number of classes, so with different configurations. And of course, we see that as the number of classes increases, the overall accuracy decreases. However, even in the 32 classes scenario, we're able to achieve a 77 overall accuracy, which is pretty good. Here we present some preliminary results on the 16 classes scenario because it has the better trade-off between the granularity of the results and the robustness. So while analyzing in this context, our model was able to reach an accuracy of 81%, and we then analyzed our sequences and compared to what was actually shown in the video. And we identified 4 macro categories: environment description, character-environment relationship, character-to-character interaction, and the undefined classes. Each macro class has then subclasses that define more specific patterns. For instance, in character-environment relationship, we have class 1, which usually is a sequence represented by a unique shot, either a camera movement or a fixed shot, that introduces the character within the environment, while class 4 is more the focus is more on character reaction to environmental changes. So maybe a character opens the door and we see a close up on the character in the room that watches through the door. So these were our preliminary results, which are actually good and are encouraging, especially because there is a lot of room for improvement. We intend to address different implementation. First of all, we want to be able to have a better characterization of our sequences. We want to be able to distinguish between single clip versus multiple clips. In other words, for instance, if we have a sequence of all close-ups, as of now, we're not able to understand if it is a monologue or if it is a dialogue back and forth with the same, with two different characters. And we want to introduce, we want to enrich our data by integrating new movies and adding new features such as the temporal dimension, for instance. And so, consequently, we also intend to experiment with other machine learning techniques. Also, we want to implement more fine-grained type classification, not only on the classes, but also on the camera movements, interior, exterior, and so on. So thank you all for your attention. If you have any question, I'll be glad to answer them.
Thank you. I think it's a really great presentation.
Thanks.
Yeah,
I have a question. So this is quite interesting work, Bertolman. So I was talking, I mean, I made this question to Misha before, like, basically, like, you're talking about editing patterns, right? And trying to learn those from movies that has been already edited. But do you think there is a component actually that happens only when you're writing video? Like, is there like any pattern that will emerge only when you are kind of like editing, like when you have the raw footage, the raw takes, and then when you're doing the editing process? Is there something that you cannot capture from?
No, I know that, of course. Well, let's say that my aim here is to try to, let's say, find the most common, most used patterns. This is because, really speaking, creativity is also something that grows with not limits, but like, so let's say, okay, I want to start editing something. I don't know what to do. If I'm able to create artificial sequences, then I know what is the most common thing that everyone would do. And so I can start experimenting from that point into a different direction, for instance.
Okay. Okay, pretty cool work.
Yeah, okay. Okay, then thank you again very much. And
I will have to go with the next speaker, Tobias. Let me make you co-host, Tobias. I guess you're here. I found you. Yes, now you should be able to present. So yeah, welcome, Tobias. Just go ahead, take over. Let me know if you have like any technical details.
Can you hear me?
Yes, we can.
Okay.
We can also see your screen now. Yes.
Okay, I will just put on the slides. Okay, I hope you can also see this, like the slides now.
Yes, we can.
Okay, perfect. Yeah, hi, I'm Tobias Hepper, a master student from KTH in Stockholm. And I will present today our work, video prediction and infilling with diffusion models from Arash Meryu, Stefan Bauer, Dietrich Nielsen, and Andrea Di Tali. I just realized I can maybe turn on my camera. Okay, my camera's, yeah. Sorry for that. Okay, so first of all, about the problem. Assume we have a video sequence with some known frames XC and some unknown frames XU. And we would like now to predict the frames in U such that the combination of both is a temporal coherent video. A solution to this problem has many possible applications in video editing, such as increasing the frame rate or filling in disrupted frames or generating maybe even a completely new sequence over an already recorded video. But it can also be extended for a lot of problems in autonomous driving, reinforcement learning, and so on. So it's a very general problem. Training such a model, however, can be very difficult since it needs excellent performance in prediction, but also in generation. So simple regression usually does not work very well, and we need to model this differently. there was one before. Yeah, so most recent methods model this usually as a generative problem and try to train a conditional generative model. And for this, they usually rely on GANs or VAEs. But both methods have very common shortcomings, such as blurry predictions in VAEs or unstable training in GANs. And that is why we will use diffusion models, which have not yet been extensively studied for videos. However, as all of you know, probably diffusion models, there are more and more papers coming out, so probably there are even more video diffusion papers by these days. Very short recap on diffusion models themselves. So diffusion models consist of two stochastic processes, one which transforms the data distribution gradually into noise, and one which reverses this process. If we now learn the gradient of the data distribution at each time step t, we can sample from the reverse process and therefore obtain finally again the data distribution. Below I've illustrated this process, but of course in our case we won't work with single frames. We actually will diffuse the entire video at once. Now our motivation for Roundtable. So if we now train a simple or straightforward diffusion model on videos, we can generate videos with very high quality. But we found that when conditioning then on other frames, the predicted and conditioned frames are not very well harmonized. So you see this in this simple MNIST example. One solution for this is resampling. However, that is very expensive and especially for videos, therefore unfeasible. And so we propose randomized video diffusion, in short RAMVID, which is a model trained with randomized masking to learn the conditional, but also the unconditional distribution at the same time. So how does RAMVID work? For RAMVID, we condition on the frames by simply feeding the diffused frames XU and non-diffused frames XC combined to the network. So we do not rely here on concatenation as it's usually done for conditional diffusion models. By choosing the position and the number of conditional frames randomly at each training step, we can train the model for all kinds of completion tasks. And also we add a probability PU with which we do not condition on any frame. This allows us now to train the model conditionally and unconditionally at the same time and approximate both distributions. Finally, then we compute the loss only with respect to the noisy frames, which is also different from a lot of other conditional diffusion models. For the architecture, we use a simple 3D unit with self-attention, and the network is conditioned on the time step t by injecting it into each hidden layer. Now, the first experiment we did was on a very simple bear data set. So here, the common evaluation procedure is to predict 15 frames given one frame, and we can see that RAMVID outperforms all recent methods, even though it had actually less parameters. And using an unconditional rate does actually increase the performance also for the conditional generation. Now, since bear is rather simple, we also trained on Kinetic 600, which is a data set consisting of 500,000 videos from 600 different classes. And the evaluation procedure here is to predict 11 frames given 5 frames. And again, RAMVID outperforms all recent methods with less parameters. And also an unconditional rate greater than 0 helps. However, when we have a very high unconditional rate, this time the performance drops significantly. And we found that this is due to the very different unconditional and conditional distribution of kinetics. Since for bear, every setting is very similar, the conditional and unconditional distribution is quite similar. Here on kinetics, this is different. Yeah, and as I have mentioned earlier, so we cannot do only prediction. We can, with the same model, so we don't need to retrain anything. With the same model, do all kinds of video completion tasks. So here are some examples. We have on the left-hand side, we have the first 2 and the last 2 frames given, and then predict a video in between. Or we, on the right-hand side, we distribute the conditional frames uniformly over the entire sequence. And actually, RAMVID performs on this even better than on prediction, also in terms of FVD, but we didn't have any references or baselines to compare to. So I didn't put the numbers on the slide. Lastly, so if we have high unconditional rates, we can actually also generate videos completely unconditional. So we don't need to condition any frame. We just generate them from scratch. But for this, we found that the performance of RAMVID is competitive, but it's quite far from state-of-the-art yet. However, we would like to notice that UCF 101 is a very special data set since it's quite complex. It has 101 classes, but very few samples, and it has only 10,000 samples. And we assume with even more engineering, you could improve the performance by quite far. But we did not do that since our focus just didn't lie on conditional generation. And lastly, I would like to talk about two limitations we found. So sampling long sequences via autoregressive sampling is possible, but very difficult, because at each prediction step, the quality of the video deteriorates, and we get usually poor quality after around 30 frames. And also, as most video models, Runwit has problems modeling fast movement, which we see on the examples on the right-hand side. Thank you for listening. Any questions? I don't see them.
Yes, if there are questions, so maybe you can like reply to them in the chat. And in the meantime, I will just hand it over to the last speaker. Thank you, Tobias, for your talk. It was really interesting. I hope you can catch up with the literature. And now I hand it over to Anyi.
Yeah, can you see the screen and slides, right? So you can see the slides, right?
Yes, we can.
Oh, great. Okay, so this is Anyi Rao, and we present an extended abstract paper here. It's temporal and contextual transformer for multi-camera editing of TV shows, where we collaborate with some filming major schools. And today's talk will start from a different perspectives to videos and then goes to our work. So the first question before we start, I'd like to ask is why we wanted to study videos. So since video is a very good way to vividly express what's in our mind, let's take our research as an example. 32 years ago, the first ECCV conference published its first paper on scale and resolution in the analysis of local image structure. And then we have the slides today, like what we have to do here to present our work as a better way to communicate our ideas. And then we also noticed that in recent years, there are a growing number of instruction videos by third party to explain a paper to a broad community in a more vivid way. For example, on one of our Bungie paper. So interestingly, we noticed that some people prefer YouTube than archive to keep up to date with the advanced technology in the community. So how to analyze such kind of videos from a machine's eyes? So let's take an example in a recent movie, Everything Everywhere All at Once, is about a policeman. This scene is about a policeman come for Evelyn and Waymond. And we see a basic method to process it is frame by frame. But when we compare it to language, it's like this. It's a stuttering language. So we further invent a shoot-based method to make it to be more efficient. And based on such a temporal unit, we can have a structural understanding of a video. So take a Titanic as an example, like we are able to know who and who are doing what and where, and contribute to our understanding to a scene or a plot. So this structural understanding further leads us to think about, well then, how to create videos. Let's start from the easiest way. Since a video is actually a series of image frames, and an image is a matrix of pixels. So if we can generate each pixel, then a video comes out, like the opening things here. And we can further edit it based on such ideas as what Paul did on Twitter, and I refer it here. From another perspective, a video can also be viewed as a result of a camera robot navigating in the 3D environments, where the action space is about its position, angle, and focal length. Furthermore, when we specify the scenario to a professional video, for example, movies, it's very comprehensive. That is made from pre-production, on-stage production, and post-production. And we know a good movie usually takes several years across thousands of people's work that combines people's efforts, language understanding, graphics, visions, and a lot. So from another perspective scenario in TV shows, the video that present to audience actually comes from the editing of multi-view camera tracks. And this is our work's focus. But it still faces significant challenges on like how to select a suitable cutting point and how to pick up an appropriate view from the candidates. So to facilitate the research along this direction, we construct a new dataset, TV shows multi-camera editing dataset. And it contains 6 tracks synchronized raw footage with 1 ground truth videos created by professional TV show creators. And it contains 4 different various indoors and outdoor scenarios and 88 hours of videos in total. And here is a glimpse of it. From the statistic, we also find out that the dataset is quite diverse and large. So based on these datasets, we provide a simple baseline called temporal and contextual transformer, inspired by the observation that professional editors usually select a view based on the historical decisions they made and all the visible views at the current time step. And here is a comparison with other methods, from which we could tell that the proposed method is quite effective, but still leaves a lot of space to improve. So that's all. Thank you.
Okay, Anyi, thank you so much for your presentation. Again, as the other speakers, you can just go ahead and reply to the questions in the chat. So we will have around 20 minutes break before the next part of the workshop, which will be the second roundtable. The second roundtable will be very exciting as well. We will be talking mostly about the new generation of methods for generation image and video. We will have a great set of panelists, so please hold on with us, guys. Go and have some snack, a cup of water, a coffee, and we'll see you all in around 20 minutes, okay? At 12:30 PST, we will restart the workshop.
Also, don't forget to vote for the best presentation. So there's a form in the chat. You can go and follow.
Hello, everybody. Hello. Maybe before we start this session, we can check if all of the panelists is online here now. I think some of them, I think Negar, you are here. Also, Oren, I see you. I think Pinar should be here too, I guess, right? Yeah, I think let's wait a bit. We still have 2 panelists who haven't joined. So let's wait a bit. Hello, Pinar.
Sorry, I'm a minute late.
No, we're on time. It's not yet 12:30. I think Paul is joining. Hello, Paul. Can I ask you to turn on your camera so that everybody can see you?
Hey,
okay.
Sorry
Hello.
about that. Hi.
I think we're still missing one panelist. We can wait 1 minute. Right? Okay, Patrick's here too. Okay, hello, Patrick. Can you turn on the camera so that everybody can see you? Hello? Oh, okay. Okay, I think everybody's here. Everybody in the panel is here. So, okay, everybody turn on the camera. So, hello, everyone. Thanks for joining us today. My name is Dong. I will be moderating this session. I'm a research scientist at Netflix, where I'm currently working on human-in-the-loop AI solution for content generation, indexing, and management. So I know today we are spreading around the world. Some people are celebrating holiday, I know. Also today is Sunday. So I really want to say thank you to everybody for being with us today. So basically this panel, so we will have some conversation. So the conversation will be around generative AI models for content creation. So one of our goals in this panel is to understand how we can bring different communities together to work on this challenging problem. So, you know, we have tried to invite speakers from different communities. I'm very proud to announce today we have people, professional creative artists. We have inventors of the famous content generation models. Also, we have an expert on ethical AI who looks into the social impacts of the model we built. So this is very wonderful. So basically, in this panel, you can think of like we will have a dialogue between the creative artist and AI scientist. So we want to, we hope, we tried very hard to cover different perspectives of this, from the technology all the way to the social impact. So really, we are looking forward to your input here, everybody's input here. So what I would to do first in this panel is to first ask the panelists to introduce yourself. Please tell us a bit about what you do and why you got interested in generative models for content creation. So if you can give us a quick introduction, maybe Negar, do you want to start?
Sure. Thanks for having me, and hi everyone. So I'm Negar. I'm a research scientist at Google Responsible AI team. And my background is on video understanding and computer vision. Like my PhD was around video classification, video captioning, video generation. But back then, like in 2017, when I got my PhD in 2017, like the kind of models that we were using for video generation or image generation was very different with now. And then I got interested in creative applications as soon as the Deep Dream models came out. And so it was kind of like following the news. In 2018, we started organizing a series of workshops called Computer Vision for Fashion, Art, and Design. At the same time that we released a data set called Fashion Gen for releasing basic generating fashion images conditioned on text designs, and see how we can actually work with this kind of systems, and had a competition at ECCV in 2018 around this, and try to bring in artists also in a format of art gallery in the workshop. From 2020, I started working on this ethical aspects and have a retrospect view over my own research and my community's research around generative models and machine learning in general, with a series of workshops, again in computer vision conferences, CVPR, called Ethical Considerations and Creative Applications of Computer Vision. And I'm very glad to be here.
Yeah, thank you. Thank you for the introduction. Pinar, do you want to go next?
Yeah, only if it's not going to be a bore for all of the other attendees that heard me the first part of the conference. But I will be revealing things I didn't reveal during the first panel. So for those that are new here, my name is Pinar Demirda. I'm the co-founder and the AI director of Seyhan. I dare to say we're the only production company that specializes in integration of generative art into professional filmmaking. So we do really cool stuff. We do short films, we do VFX for feature films, we do immersive experiences and whatnot. Why am I here is that AI and consciousness found me. That part I left, the consciousness part, during the first presentation. In 2017, 2018, Alexander Morvintsev, the creator of Deep Dream, discovered the way for artificial neural networks to visualize futures. And his discovery looked like my body of work as an artist. So I got summoned at Google Brain Lab and at Google Arts and Culture in 2018. And I think I'm the first artist to have Google collab for her to make art. So I started making art, and I actually would love to show you guys. I haven't showed you the first part. This is made with that tool. This is an oil painting. And parts of this, I can make a picture and send you guys, but I had a lot of fun while working on that project. And the other part why I'm in AI is because I intuitively understand where everything will develop. And I would like to encourage everyone that has a lot of fear about AI taking over or humanity losing its meaning and relevance. That's why I started writing articles. I have a blog about how will humanity remain relevant and how technology and AI can be in the service of humanity. So this panel is of very much interest to me. Thank you.
Yeah, this is a really interesting journey. Thanks for the introduction. So next, Paul, can you introduce yourself?
Sure. Hi, my name is Paul Trillo. I'm a filmmaker by trade and have sort of been absorbed into the AI community more recently, but have been keeping tabs on it for a while, just because I sort of, I use a lot of in-camera techniques, post-production techniques, and I think it took this year for it to cross a threshold where AI image generation could actually maybe be integrated with live action footage in a less abstract way and maybe a more photoreal way. And I think that's incredibly exciting. And I don't know if people quite realize maybe how revolutionary that will be for visual effects. My work, spans like genres and formats. I went to an art school for experimental filmmaking, but then kind of did music videos, which led to commercials. I've also done, 10 or more short films at this point that have played in, major film festivals around the world. Also did a stint at Google Creative Labs. But like my work has always been in exploration of like form and function and technique, being paired with something thematic or something that relates to the story. So yeah, I've done, a whole variety of techniques, and it's always trying to like see if conceptually you can justify why you're using an effect and not make it kind of arbitrary. And so that's leading me down a path now where I'm now writing a few things that are about AI, but also use AI filmmaking techniques to tell that story. And yeah, I guess we can get into it more later, but yeah, when I first saw, how in painting works and works very convincingly, it basically opened up a door for me, and I've started to still somewhat manually, but like use in painting for like crude kind of stop motion techniques that I try to polish and make look like visual effects that you would see in a movie. And so my kind of like, I don't know, purpose lately has been trying to like educate people and also develop tools that will use AI in place of like CG and other maybe more expensive and time-consuming effects. So yeah.
Yeah, excellent. We're excited to have you today.
Yeah,
so yeah, Oren, do you want to go next?
Sure, thank you. So hi everyone, I'm Oren Gafni. I'm a researcher at FAIR, Meta AI. So FAIR today is fundamental AI research. Once it was Facebook AI research, same acronym. And I've been the lead researcher in the Make a Scene research project, which is basically text-to-image generation, where you optionally can also introduce a sketch additional to the text. And more recently, I've been part of the Make a Video project, which is basically text-to-video. Yeah, so my research background kind of always was generative models, always generating images, videos, usually more human-centric. Now with the current text-to-video or text-to-images, it's everything, not always humans. But yeah, when we started working on Make a Scene about a year ago, maybe a bit more. So it was kind of, we have text-to-image was already kind of working with the first Tali. And we wanted to focus more on how can we basically empower people to be more creative with it. So when you have text-to-image generation, you have the text input and you generate a wonderful image, at least today. But there's always a question, is who's being creative? Is the AI, is that the person? And we wanted to introduce kind of an element that will help people being more creative, or even use text-to-image generation for more applicative use. So for example, when you have this sketch, when you can basically sketch what you have in your mind, it helps whether you're an author that wants to illustrate their book, or an artist that wants to create art. It kind of helps you basically direct the image you want to generate in the way you want to do it. So yeah, that's about it.
Yeah, that's super cool. Looking forward to more input from you today. And finally, Patrick, do you want to give a quick recap of your research yourself?
Hey, yeah, sure. Can you hear me?
Yes.
Great. I'm Patrick. I'm a researcher at Runway, and how I came to work in creative AI, I guess it really started a long time ago. I think I was just fascinated the first time I saw some variational autoencoders producing MNIST numbers. And yeah, ever since then, was excited working on that topic myself. And yeah, so I had a great opportunity to work in the Compass group in Heidelberg, where I really did research on generative modeling, and especially what I worked on was like learning representations that are better suited for image synthesis. that's what I've been doing quite a bit. We published Taming Transformers, for example, which was also the VQ gun part of it. A lot of people used that, and that was actually exciting for me to see. Like, I mean, the more popular thing I would say was even like the VQ gun and clip stuff. So it wasn't like completely our doing. It was like really how other people took some parts that we developed and really used it in novel, creative ways. And that was something I really enjoyed seeing. And also, yeah, really led me then to pursue this direction more of really building creative tools that can be used by creative people and everyone. And that's how I came to join Runway. And yeah, we specifically also look at applying these techniques to video, to move into the video domain. And yeah, but also definitely, I think part of the route there is still like combining existing post-production techniques with like image techniques. So that's why we also worked quite a bit on text-to-image models still. We had the latent diffusion models and recently also scaled that up a bit, leading to the stable diffusion model. And yeah, now I'm really excited to be here since, like I said, creative tools, especially for video, is very exciting for me.
Yeah, cool. This is very exciting. Thank you, everybody, for your introduction. So I want to start the conversation with a question. First, I will direct to our creative artist. And then this kind of like QA. Then I want to hear some response from our scientists. So basically, we want to hear everybody in the panel. So if you want to chime in at any point or once a person finishes speaking, please just go ahead and do so. So perhaps I would start with Pinar and Paul. So I know both of you have used those amazing image generation tools, right? To create art pieces and post them on social media, which got a lot of attention and impressed a lot of people, including us. So the question here is, what is your experience using this state-of-the-art image generation models? What are their pros and cons? Right? For example, how do they inspire you in your daily workflow? What are their limitations? So I know this is a big question, but please summarize a few key points. And our scientists, I hope you can give some responses. Yeah, let's start. Who wants to start?
Paul, do you want to go first?
I was going to ask, do you want to go first? I feel like you have been talking all day, but I feel like you've also kind of had your hands dirty in this world for a lot longer than I have. I've only had, about 9 months of experience with this stuff. You've kind of seen the progression of it, I get, right?
Yeah, I can go first.
Tools becoming more friendly over time.
Yeah, my involvement about is like I stated earlier. My involvement is like I wake up, I do this, I go to bed, I do this, I dream about generative AI. Like I don't do nothing else. I'm like completely obsessed and possessed since 4.5 years. And my general, what I do at my day job is that I identify whatever happens in the world of generative AI, the latest tools, which tools our team can combine the best for which type of script. I analyze and identify that. I identify the best talents. Like, for example, a talent that uses impersonator, hypercore, whatnot, this type of models is not the same as a super artistic visionary creator that uses like style transfer in the most artistic ways. So I really do identify like artistic contributors. And others is, and my other day-to-day task is to be on the phone with LA-based producers and directors and advertising agencies who are extremely curious, especially since I would say 3 months. Like there's some form of a rush. They feel like they're in the mist, and unless they understand right now, they will be irrelevant. So we've been proposed to merge with them investing in us, so then they have an understanding in generative art. Like before they want to understand, they want to like pay and buy, I think. But so what are the limitations? Like, why am I in it? Is again like so far, what I'm like, this is the first time humanity is presented with a tool that generates content. Before, it was always a tool that helps the creator do certain tasks that they cannot do without that tool. So, but so far, the way we're seeing is that like there's a tool that generates for us, and then we're watching the tool generate, and we're slowly like shaping the tool, just like a bit of a sculptor that shapes the outcomes of its sculptor. What are the limitations? I spoke really thoroughly this morning, but again, if I were to iterate understanding of space-time and coherency, being able to identify an object and make that object consistent, have like, for example, it's so wonderful to generate like a beautiful mountain with a whatever descriptive thing in the middle, but when we try to have like, let's say, a girl solving a Rubik's Cube sitting on a mosaic carpet with a robot of pink elephants overlooking the shoulders, and where the mom is scolding the kid about how much she's not going out enough, you know, like I would like to see much more complex objects being coherently placed by the machine inside a scene that I can totally control. I was very impressed by that. I don't know if it was a paper, like the one before the last, that was about, it was made for the editing, but actually it's segmented really nicely, like what is intuitive for filmmakers in the language of the machine. Like that is, I think, a very good insight for generative tools. Like that can, like that paper can really benefit, like, okay, what are we generating? What is the scene? Is it outside? Is it inside? How many people? So I think that really speaks to the biggest lack, like segmentation, coherency, cohesion, space-time, real-world physics. Yeah, what do you think?
Yeah.
By the way, I'm such a fan of your work. Sorry.
Oh, thank you. Likewise. I just recently started to dig into it, and I was like kind of upset at myself for not finding it sooner. It's incredible. But thank you. Yeah, I mean, I guess just piggybacking off of that, I guess we can start with the limitations, and I'll reverse back to like what makes me so excited about it. But I mean, there's definitely limitations in like the sort of temporal consistency of images that I know Make a Video is kind of solving day by day. So I think that will change within a year, or if not sooner. But I think that's going to be like, because the human eye has like a ability to just recognize the uncanny very quickly, and especially in motion. You know, a still frame can look like passable. As soon as something starts to move, we detect something wrong with it, which is like why I think early CG animation was a little bit off-putting. Like some of those early Pixar films are a bit creepy, and I feel like we'll go through a stage of that uncanny valley for a minute, but I do think we will overcome it. But that's been one thing that I think will prevent it from being adopted into like, you know, studio movies for a while. But I think if you embrace the kind of aesthetic of it, and the randomness of it, and the I guess naive imagination of the computer, and you embrace the experimental quality of it, it can lead to really interesting effects that simply like didn't exist before. And that's what really got me excited about it, is not like, I mean, so I do think AI will replace some visual making techniques, but really what it opens up is more exciting, of like the things we just like weren't able to do before. So like, you know, for instance, I made this video with the outfit swapping really rapidly, which is an effect I've done both practically and digitally before AI. And it's an incredibly like time consuming thing. You have to do like, you know, very consistent camera work where the camera either doesn't move or it's motion control. The actor has to get in and out of wardrobe, and then you have to composite it all together. Or if you do it all digitally, you have to like create the 3D models and motion track, light it, create the materials, match the perspective and everything. And as soon as like I kind of like the light bulb went off with in-painting and doing that over like an image sequence, I was like, oh my God, this opens up so many. I've had sort of a creative like rejuvenation lately, where I think, you know, I easily get sucked into doing paid work, and I finally like have reoriented myself lately to go back to making more personal work, and it's just purely because of AI and the new techniques it's opened up. So with each video I've been releasing every week, it's an attempt to show people, to shed light on like, hey, here's another use of this technique, another way to be creative, that, you know, that is open for everyone now. Now it's like, it's free in a lot of cases. And so that's also what's exciting, is like the democratization of the tool, and that like you could, in theory, you can create insane landscapes or outfits or objects that, you know, someone without the budget before couldn't make. And so I'm trying to like show people like that this can be applied to video. The other kind of limitation at the moment is just the I'm a director, but I also have a little bit of a post-production background, so I can like manually comp stuff like the AI into live action video. Not everyone has that many years of experience. So I think hopefully, and I think what Runway is working on is tools that will just allow people to not be limited by like having years of experience, and you're more limited by your ideas than anything else. And so, yeah, I think that's to me, that's still the setback right now, is like the AI image generation still takes a little bit of brute force to marry it with live action footage. So yeah, anyways, hopefully that starts to change in the coming months.
Yeah, it seems like we have some commonality, right? Especially on the video generation, right? How to compose video sequence. So now I think our scientists, we are here. So I think maybe you can like provide some like insight or solution. What are some secret projects you are working that can address this problem? Maybe I can start with Oren, because I know you work on Make a Video. Maybe you can share your insight. Then I want to hear from Negar and Patrick as well.
Well, sure. Yeah, so there were a few points here. Temporal consistency came back quite right. And yeah, basically, there are kind of two ways to look at it. When you look at video generation or text to video, you have one which feels more like image animation, right? You take an image or you take a text and you created an image that is actually animated. The other part is more complex videos, right? So, and both of them, they already exceed what you need for kind of image consistency, right? So image consistency kind of feels like it's solved, you know, at least research-wise. I'm sure that we're going to have, you know, better models, faster, lighter, higher quality, better consistency, less uncanny valley stuff, as Paul mentioned. So yeah, that's kind of feels solved. There was also talk about complex scenes, right? Pinar said that she wants to describe a really complex scene. I saw some of the papers that already do that. You know, you never know what's cherry picked and what not. But at least with what's out today, for example, Dali 2 that you can play with their demo, it seems to capture pretty good complexity, not perfect. But also, there's also the question of why would we want to generate such an image that has, you know, very, very complex description that's very out of the distribution of what you would see in the world. Usually it's just to kind of, just to see if we can do it. But is there a real day-to-day usage for that? Yeah, there was another part I'll talk about, which was editing. So that until maybe a year ago, it was mostly editing tools or editing research. And today it feels like it's more generation. And I think Paul talked about, he mentioned in painting, right? So you can use generation for editing, like when you do in painting, also out painting. And I'm sure we'll see it in video working very well very soon.
Yeah, do we have, from scientists, do we have something else to add here?
I can talk a little bit about the history of this. Like, I mean, I'm not working on the modeling right now, but I'm sure like with this direction that our field is going, so we hopefully will have like much more consistent models. So in like historically, like, I mean, I was working on, for example, with KTH dataset, which is a very simple data set in computer vision, and we're trying to regenerate like very, very simple moves in videos, like just doing boxing or like doing jumping jacks. And even with those like very, very simple moves, we had very inconsistent video generation or like frames, or like if we were successful, we're creating like 10 images on the row. So I can see like lots of growth during the last few years, given all these amazing models that came out. So yeah, I don't have much answer for like the future.
Yeah, cool. Patrick, do you have something to add here?
Yeah, sure. I guess like how I think about it, like moving towards more consistency and moving to videos is always like a bit, I always see kind of like two rough directions, which I guess other people mentioned as well. Like on the one side, there is like the really more the editing or post-production based work, right? Where you usually start from existing moving footage, and then you really try to insert something new or modify the video to some degree. I actually think that's a super interesting direction, because it gives a lot of control to the user, right? And you also I think there's something cool about combining a real scene with something completely generated or something imaginated. So I'm really a big fan of that. Overall, I think, yeah, this one is also from a technical viewpoint, I guess, still quite challenging to make it work in all situations. So, I mean, there was the great talk by Tali Dekel on layered video representations, right? And that's definitely something I think has huge potential. Definitely something we're always experimenting with as well, to see, if we can provide better, really better representations of video that you can use for editing, which makes it easier to apply consistent edits. But I think overall you have to, in that route, you have to kind of like try to understand the geometry of the video, right? So I would say it's even like more of an analysis task, where you have to understand what's in an existing video, and then you can insert new stuff. And the other direction, of course, is layer. Like we just generate videos from scratch, right? Like generate the whole thing. And that's also super exciting. And yeah, it would be interesting which of those two directions move how fast.
Yeah, so we have a lot of PhD students and researchers here. Hope you guys can take a lot of insight from this conversation and start doing your cutting edge research. Okay, so I think next we move to the next question. So it's kind of like, you know, those content generation models are really cool, right? We heard Tali make a scene, stable diffusion, right? So they were built with huge data sets, right? And hundreds of millions of images and very sophisticated machine learning models. That's what we heard about it, right? Then from the artist perspective, I know different artists, professional and like regular users, they start playing with the tool, right? The scientists build. But seems to me there is a gap here, right? So when we build those tools, we don't seem to directly involve those creative people, like artists, as the part of the process, right? It seems, at least to me, right, there must be a gap. There must be something we can do better, right? It maybe like to shift more centric, right, towards the artists, right? For example, their creativity, like we discussed today, their intention, right? So even the establishing patterns, right, they learn from art school, right? Those have not been incorporated, right, into those models. So the question here to you, to all of you, I think to everybody, is how can we do better to keep the artist in the loop when we develop those content generation tools? So maybe I can start with Negar, because I know you work with different communities, right? So maybe you can share your insight. Then I want to hear from everybody.
I believe like some workshops, like the workshop that you're organizing and bringing in artists and AI researchers together would be like one of the ways that we can approach this. Or workshops like basically there is a creativity workshop at Generative. We have also workshops around creativity, and this kind of workshops that we will get together and start talking and discussing. But I think it's also very important to have artists in the loop from very early stages of the project, even on the data collection part, like assuming like which kinds of problems are important. The last question that you were discussing with artists on, so what are the limitations that you see? Like that might be very different from the limitation that I, as a machine learning researcher, computer vision researcher, see. So it's very important to have them into the conversations from very early stages of the process. And I also encourage like user experience researchers, UX researchers to be part of the process and understand and be able to embed artists' view. And I think like it's even like beyond just like art communities, because we have also like, we can consider also like a traditional art community. I mean, traditional, I mean, artists who are not necessarily interested in using these tools. How can they be part of these conversations when we are developing these models from very early stages of the process? Then it's not like retrospective anymore. It's not like that. I'm looking at my work that I did and see what are the limitations. I would kind of like try to embed this point of views from the beginning in my work. So that's the kind of like way that I think we are doing some of this, but it could improve also.
Yeah, so yeah, that's great. We should start collaboration as early as possible. Then what should we do?
I have some suggestions for this. I have this really I would like to start with a crazy example where businesses failed in recognizing the power of creativity and upsetting their community. Giphy was sold for $400 million, and none of the creators received a dime. This created a huge backlash in the gift-making community because that money could have never been raised and exchanged without the amazing contribution of its creators. I would like to give Paul, an example from your work. It's a true story. You made something that has to do with this Mediterranean Art Deco Rising Chinese store. My brother, who has no idea about generative art, got forwarded that piece and gave me a call. He lives in Istanbul and he's the marketing manager of an industry. And he's like, yo, have you seen this amazing thing? Can you do these things too at Seyhan, at your own company? So what I'm getting at is that people only can welcome a new tool if their consciousness level for creativity is expanded. And sometimes a sample can do this piercing impact. So artists should not be involved in the creative process. They should be the center of the creative process. So I would like to go a little bit far. I know that we're all like either academics or amateurs or professionals or artists for this generative art. My suggestion will go further to marketing and business decision-making. Like a company like, for example, Meta, like because of like politics and whatnot, like the brand image of Meta has been a bit shaken, Facebook, let's say. But then with the latest amazing generative tool developments, like in my opinion, their brand image really shifted in collective consciousness. It's amazing. The research that they put out there is amazing. And artists, when using these tools that these big companies are putting out there, they are actually unconsciously contributing for the collective, the brand image of these big brands, big technology companies. So what I suggest is that, let's say when NVIDIA or Meta or say Netflix or whatever, like Google, like big names, would like to come up with new like generative tools, they make a consortium of 20 different people, artists, filmmakers, generative enthusiasts, and they put them and their vision in the center of their development. Like Negar was saying, from conception to the data set making, and then they release the tool, but they release the tool already with the experiments of the high pitch level extreme innovators. So people understand what they can make. And then I would go one step further, is that, so people like my auntie starts making, like everybody starts making things, and then maybe they can identify 1,000 new people that have been using this tool different than the 20 financially backed, by the way, I forgot to say that, these 20 people that contribute to the making of these tools absolutely need to be rewarded for their contribution, but maybe later on as an encouragement and a support of their community, maybe they can continue rewarding people that expand the creative possibilities of these tools.
Yeah, I think this is a really important question and discussion. And Pinar, thank you also. It's a very flattering story. It's cool that it made it to your brother. But no, yeah, Dong, thank you for the question, because it isn't really something that people are talking about, and it seems so obvious. And it's frankly shocking. And it's happened, this siloing of creativity and really amazing papers that are published has like been happening for whatever, 15 years now, of like how these advancements in machine learning have been going on, and they've been very isolated. And I've followed people at Berkeley, University of Berkeley, and I've like emailed them and get very like, I don't know, like confused responses. I'm like, hey, I'm a filmmaker and what you're developing is really interesting. And they're just like, oh, okay, thank you. And they just put these papers out, and then nothing comes of it. And it's so like shocking, because there's so many, like, when I see like an effect and a technique, my mind kind of like spirals of like, what can you do with that hasn't been seen before? I'm always trying to seek out like things that people haven't seen before. And that's where technology comes in, because it opens up things that just weren't possible. So it is a little bit frustrating, but I do think Meta is a good example. But I do think there is a shift towards that, but like it's shocking still with like all these experiments I've been doing with Tali and the people at OpenAI, who are very nice, and that they've been very like flattering, but they also were like, we never knew this was possible with our technology. Like, you're showing us things that we didn't know were possible. It's like, really? Like, why didn't you reach out to people sooner? Like, it feels, it just feels a little bit cold in its research process. And because of that, you just get a very limited example, and then you just show people, you're like, hey, this is what the tool does. And then everyone kind of just uses it in this homogenous way, where I think if you can get people, creatives, artists from different disciplines to use the same tool, and then you publish what can be done with the tool, then it's like totally mind expanding. And it is very shocking how OpenAI like totally disregarded the whole video potential of their product. I do have to shout out Runway. I think is also making strides. I've been having conversations with them, and they are making strides to speak to filmmakers and say, like, how would you use this? What do you want to see? Because that's really, I think, where innovation comes from. And that's like how Apple was able to drive so much innovation, is that they had the creative side mixed with the technology side. And it was like the back and forth discussion that really propelled things. Having these isolated conversations, it slows progress down. I mean, that goes like in kind of both ways, where like the visual effects world seems a little bit like cautious to like adopt. I think it's changing, but they've been cautious to adopt AI techniques. Even like, you know, it took a while for Disney to use deepfakes to do de-aging, which I think look far better than doing CG de-aging. And it's like, well, deepfakes have been around for a while. Like, why were so many visual effects artists were like really resistant to adopting AI just because they weren't the natural tools for them, whether they were better tools or not. And so I think there needs to be some sort of bridging of the gap there. But yeah, maybe it's events like this, workshops like this, you know, these companies going to film festivals and meeting people, and, you know, yeah, bridging the gap between the communities that way.
Yeah, that's cool. So yeah, Nigar, go ahead.
I have a question, and it was a very wonderful conversation. And so we like, how can we attribute artists who are in the process? Like, if we bring them on from the beginning of the process, if we value their views, but just like using their idea on developing a tool, so where is like, is it okay, like if we just like put that kind of part of the process that artists will be using these tools at the end, or we should attribute them in a different way? Of course, like they will be attributed by the artwork that they're creating, but how about their involvement in the creative process and creation of the tools?
Yeah, I think, yeah, who has some insight on this? I think our scientists, AI engineers, do you have some answers to this?
So maybe just to comment on the previous one, I wanted just to mention also that, like, because like how artists can be more involved in the process. I just wanted to mention that even if we like, there's no direct outreach or direct involvement during development of such models, I would say, at least for us at Runway, or for me personally, I'm definitely what I work on and the directions I pursue are always informed by seeing how artists use those tools, right? Like, especially with Paul's work, that's like, we see something like this and we immediately start wondering, okay, like, how can we help with this? Like, how can we make this easier? This is a great thing. Like, that's what we should work on. So yeah, just wanted to mention that I think just by showing your work, what you're working on, that definitely has an effect.
Okay, just like actively collecting feedback, and that's one way. I think, Oren, do you have any common practice besides just using training data? Do you have other possible solutions to address this?
Yeah, so I would give also an example and make a scene after we published the paper. So working on the blog, we had 4 artists that came in and worked with Make a Scene, and suddenly we saw that when artists or people that are probably actually skilled were doing very accurate sketches and had, you know, these ideas in their mind that they're better at bringing out to, well, not to paper, but the computer. So you could see that you could create some more amazing things and things that you didn't know that you could create. Going back to the question, as it's, you know, I'm not answering for other universities, companies, of why don't you do it before you publish the research. But I'll just say that for Make a Scene, for example, when we published the paper in March, we were, you know, state of the art, and that was considered as the, you know, best text to image generation. 10 days later, DALL-E 2 came out, and then they were the state of the art. And you could see it, you know, repeating again and again. About 2 weeks after that, Imagine came out. And in these very competitive fields like text to image generation, now text to video, you can see that when you have something good, you want to go out with it and publish it. And there's, an infinite amount of work that you could do with it and that you want to do with it. And many times you do it, but many times it's after you publish the paper initially, and then there's like a big hype and everyone hears about it, but they don't always hear about what you continue working on it. I think it's very important to include artists, designers. We started doing it. We did it. I mean, there's always room to do it more. I saw also that I think it was Imagine Video, they also they thanked artists for helping them. So I'm hoping it's, a trend that it happens more and more in the research world.
Yeah, maybe we can start with this workshop, right? We collaborate more in the future, right? Okay, so we don't have a lot of time, but I do have some questions. So one question I want to ask you is, because like when we train these models, right? So we use a lot of data, right? The size of those training data can easily go beyond what a professional artist would be aware of, right? In terms of which specific piece of art, right, were used to train the model. So that being said, if I'm a user, I use the model to generate some art pieces, right? Then it could be accidentally, I copy the work of other people without even know about it, right? So how do we solve this potential like accidental appropriation, right? So I want to hear everybody's thought on this. How did you avoid that? Okay, maybe we can start with I think with Pinar. You have a lot of experience. You can
Yeah,
start.
thank you. This is such a valuable question. I think we can never ask ourselves enough. I would like to approach from several different angles. One, we still don't know how ideas emerge in our heads, right? Like technically. But after 4 years of working with AI and taking many lessons about how our subconscious mind is related to our unconscious and conscious minds, I started drawing parallels between the subconscious mind, which is the data set of human personality, imagination, and ideas. So the way images emerge out of a complex data set is actually nothing too different than ideas emerge in a human filled with books, YouTube videos, nature walks, talking to people. So there's a lot of parallels between images emerging in almost like the collective unconsciousness representation of humanity called big data sets and human mind. And how to avoid that, I don't worry about these things because I realize that I end up manifesting what I worry. Instead, I started teaching myself and our team more about art history. So then accidentally, when we end up making something that looks like the work of somebody else, we don't end up stepping on other people's toes. So from an artistic point of view, I can't speak for a technical point of view, but from an artistic point of view, I think the answer is in broadening your capacity of recognizing the works of others. So then you make sure that what you generate does not end up looking like the work of others.
Yeah, but so like one question I have, like, how is that guaranteed, right? So I assume technically we need some support, right? We need to do something with our tools, right? In order to avoid this copyright issue to happen, right? So Patrick, do you have any idea what can we do on the tools?
Yeah, it's definitely like a super important question. To be honest, like I definitely don't have the solution. I think it will be like a huge topic. I think it's like probably bigger than research. It's like something that affects society as a whole. So it will also involve like people who are experts in the law and everything. So I think it's really a wide-ranging topic. But at least some of my thoughts are, I mean, one point or one question I think was like, how do you really avoid like duplicating work, right? And that's definitely something I think I think the whole how you use that and avoid that it happens should be much improved. But I guess like at least with something, if you have models that are trained on a publicly available data set, then I mean we do have like tools right now where you can actually perform search in the data set and look what you get back, like in terms of the closest image that's in the data set. So that at least I would say is definitely a starting point to make sure that, hey, this wasn't like an accidental copy of anything in there. Although I think it should definitely go much further than that. And also like the question of attributing artists that whose work is in the training data set. I think that's a pretty important question to figure out.
Yeah. So do we have other insight from the panelists? Please feel free to share. Nagar, yeah, go ahead.
Oh no, sorry. Were you going to say something, Nagar?
If you want to go first, yeah, go for it.
I was slightly going to shift the question, but yeah, I mean, I think this is something that I worry about more from like, I think like people stealing from each other has happened, for thousands of years. I don't think this is like a new concept where everything's a remix, everything's like inspired by something else. I think what the conversation around like AI and copyright, like why it felt maybe more triggering for people was that like specific images, like specific artists were used to train the models, and rather than this sort of zeitgeisty collective unconsciousness that has existed in art movements in the past. This is like individual artists that were targeted and used and not compensated. And I understand the arguments around it, but also like the flip of that is like, I don't think the people fully understand how complex AI image making is, that it's not a direct ripoff of a single artist or image. But what I worry about is in the limited, it's big, but limited data that trained these models is the homogeny of the output and the homogeny of culture that's going to come out of this, where I'm pretty tired of seeing like the same AI images generated all the time. But I'm starting to unsubscribe to certain hashtags because it's getting like, it's not really pushing anything forward, because multiple people can make the same style looking image. And I don't really know what the, what the solution is. I think it's like, it's definitely fun for people that were purely like maybe imaginative, but not, but couldn't physically, paint or draw themselves. I think that's like, it's a very fun tool and liberating for people to like envision their imaginations. But people trying to pass it off, sell NFTs as like original artwork, and they look just like 300 other people putting out the same thing. It's a little bit sad from a cultural perspective, I think. And so I hope, but I think a pendulum will swing and people will recognize the homogeny, and hopefully this is just a cultural thing that emerges, is that people will be valued for their ideas and not just for an image that they put out in the world. And so if anything, it's like to try to find the optimistic side of that coin is like, if anything, yeah, maybe people's ideas will be valued a lot more, that like, yes, it'll enable people to make more images, but those images are going to have diminishing returns, and they'll become less interesting over time, so that people will be forced to find originality in that. If the tools are democratized, everyone has access to them, then it'll hopefully there'll be a sort of competitive nature to original concepts. At least that's my hope. The other side of this that worries me, especially with Make a Video, is from a personal standpoint. Like, it was one thing when you could upload a single image and generate variations of an image. That's like one thing, but like to be able to like take someone else's video and then generate variations of a video and have no way of like ever finding who the original source video was, and people being able to like easily copy work and also like legally pass any sort of threshold of like copyright law where like you can't find the source video. It's different enough from the original source that it's can't be considered a copy, but it is. And so there's people that could be laboring over creating something. Someone can just steal it and then re-upload it, create a variation, pass it off as themselves, and get more credit from it. Because it already happens with people stealing videos off of TikTok and then they go viral on Twitter and they don't credit the source, and vice versa across all the social media platforms. And so that being exacerbated by variation generation to me is scary, and I don't see a solution for it unless it's an ethical, cultural conversation that evolves.
Yeah, that's an interesting insight. Nigar, want to add
very,
something?
very small point that, yeah, like, so I agree with like everything that was said. I think like we have also a policy gap, and there is an incentive like that we are looking for, and we want to change or want to make sure that there is no copy of like or like memorized images or like uncredited images from artists. But there should be also policies around enforcing something like this, because otherwise like that might be very difficult to trace back all this kind of contributions and seek for an answer for all the time that this kind of mistakes happens.
Yeah, cool. So we are getting a little short on time, but there's one last crucial question I have to ask. So what is the billboard advice for artists, for example, machine learning practitioners, for entrepreneurs, right? If they want to start using generative AI for content creation? Can each of you give 1 or 2 sentence suggestion to people? I think we may start with Oren. What do you think? What is your advice?
Well, that's quite a wide audience. I would say, well, it's easier said than done, but I would say, think of what's the application that hasn't been done before. Like, what can you use it for? Something different than what everyone is doing again and again and again.
Cool. Then who wants to share next? Maybe Patrick, do you want to share?
Yeah, I mean, yeah, it is. I agree. It's a wide audience, so maybe a wide answer. But I really think, like, yeah, just if you're interested in this, make the first step. That's usually the most important one, and then from there, you just keep taking steps, and you will actually figure out your own direction, what you're interested in, and yeah, make it work for yourself.
Cool. Paul, do you want to go?
Yeah, I guess I sort of agree with Oren, and just question why you're getting into it. Are you doing it because you want to replicate what other people are doing, or are you doing it because you have like an original idea that hasn't been done before? Are you doing it? What are you, I guess, contributing to the conversation by doing it? So that, yeah, again, we can like make this a conversation about technology, because there's a lot of noise out there, and I guess we don't need more of it. So yeah, I think people need to find justification for using it.
Cool. Pinar, you want to go next?
Yeah, sure. Oh, sorry, Negar or Pinar?
No, I heard Negar, but I think it was your name.
Oh, you go.
Yeah, whoever.
Negar, you go, please.
Maybe Negar, you go first. No problem.
Sorry about that. So I wanted to say that, like, yeah, machine learning pipelines have many stages, from ideation to data collection to modeling and also assessment. And it's very important to engage, like, I mean, we discussed about engaging artists, but also engaging socio-technical researchers on the pipeline, and then also see how we can take responsibilities in each steps of the way, from the ideation part and also like to the end, to data collection, which kinds of data we are using, modeling side, and how we are assessing this kind of systems.
Great. Finally, Pinar, to do it.
Thank you. I think I would like to give an unexpected answer.
Okay.
I am dealing with people who are novel to these technologies every single day, and only 1% has unconditional enthusiasm. 99% have generally fear. I don't understand. It's too complex for me. Am I going to be relevant, or am I going to lose my job, or will you be doing my job? So my first and only advice is to understand what makes you different than the machine. Your consciousness, your agency to dream, to vision, to transcend, and also invest in anything and any agency, these agencies that make you different than the machine. So that you do not end up working with the machine or coding the machine or supporting researchers that work with the machine from a point of view of an inferiority complex. I'm saying something really important, because it doesn't matter if we're dabbling with creative technology. Oh, they're making movies, not like they're working at DeepMind or DARPA or whatnot. It actually does matter, because people that are working at the cutting edge technologies, especially involving generative tools like AI, we end up positioning the human where we want to position. We can get rid of the human, or we can put the human in the very center of our creations. So first and only advice, recognize your superiority and your difference and your power from the machine. And second, invest in amplifying these qualities so that you will always remain relevant. And third, have an inferiority complex check. Where do you see yourself compared to the machine?
Yeah, that's a great insight. Yeah, unfortunately, I have to wrap this up today. But I want to say thank you for everybody who attend this workshop. Also, big thanks to the panelists. We really enjoyed. Thanks for the time for being with us. And hopefully next year, I want to see each of you again here in this workshop. Okay, also like your input and feedback, please feel free to give to us. That's extremely important as well. I think at this point, we are ready to move to the next keynote talk session. Anyi, please take over. Thank you, everybody.
Thank you.
Thank you.
Thank you.
Bye.
Yeah, I think everyone should enjoy the roundtable. And let's welcome back to our great keynote. Our next speaker is Yagiz, who is an assistant professor at Simon Fraser University. He used to study and work at ETH, MIT, and Disney Research. And now he leads the computational photography lab that focuses on the production-ready sim representation. His research targets the application of modern computer vision and AI methodologies to solve everyday problems in photography and post-production film. His research on a lot of fundamental problems in mapping, depth estimation, editing, and lighting also inspires me a lot in my work. So let's welcome Yagiz and hand it over to him. And you will have 25 minutes for the presentation and 5 minutes for the Q&A. Yeah, please share your screen. And yeah, one helpful note is that you may disable the annotations from others to avoid the bumps. Yeah, can you share the screen?
Sure.
And disable the annotation.
All right.
Oh, great.
I hope you can see my full screen as a presentation now.
Yeah.
All right. Thank you very much for that very nice introduction, Anyi. I am an assistant professor at Simon Fraser University, reporting from British Columbia. I lead the computational photography lab. We are a small and young lab, and we've been working on mid-level vision problems lately. Mid-level vision is defined as getting the physical attributes of a scene from a photograph or from imagery. These physical attributes may be surface colors or illumination or shading, which is called the intrinsic decomposition. Or it could be reasoning about the geometry, for example, depth estimation, or generating surface normals from a single photograph. It can also be segmentation, that partitioning the image into coherent parts. These are all individual problems that we look at in the computer vision community, but once we put them all together, we effectively create the inverse rendering pipeline, one unknown at a time. And the mid-level vision tasks create a lot of opportunities in the image editing and computational photography space. Essentially, these tools allow image editing beyond the RGB values that we are used to in common image editing software. So instead of changing the brightness of a region, now we can change the illumination direction or the illumination color. We can change the materials. We can recolor them or give them additional attributes. We can change the geometry, and we can do seamless compositing once we have these physical attributes of the scene ready. And as our computer vision algorithms get better and better at these tasks, then these will enable these much higher capabilities that we are typically used to in rendering programs like Blender. So not in Photoshop, but as these tools come online and get widespread, we will start seeing 3D interfaces or interfaces for lighting or material editing, similar to Blender, in tools like Photoshop. It will get more complex. It will also be much more informative and controllable. However, there are certain challenges that we have to deal with first in the computer vision industry, so that the human-computer interaction side can take this problem out of our hands. Among these problems are the biggest problem we have right now is high-resolution estimation. These tasks we can do since deep learning became a thing. Now we are able to do them quite reliably, impressively, if you ask academics. But we can do them at low resolution. That comes from our ground truth, that comes from our GPU memory, our network architecture, that comes with a limited capacity and a receptive field. Another challenge that we currently have is generalization to any scene. If we want to have a tool that we claim to do material editing or illumination editing, it should not be confused once we give it a complex regular photograph. It should work in anything. However, currently we don't have it. One thing we do have is amazing rendered data sets that we have figured out in the last 2-3 years. But at this point, we haven't been yet able to generalize only from them to the real world images. And especially for these type of physics-related problems, it is very hard to get real-world ground truth. Depth is easy. We have figured geometry out 30 years ago. But for example, in illumination, in intrinsic decomposition, in segmentation, it is still very hard to generate reliable ground truth at high resolution that we are up to. And of course, this comes with a cost in quality. But once we are trying to do image editing and we are trying to give full control to the user, these results needs to be perfect, high resolution, highly aligned with the image and so forth, so that we will be convinced by the editing result, that we are not there yet. Today, I will talk about one challenge and another opportunity, a step towards more complex image editing interfaces. First, I will talk about how to get high resolution monocular depth estimation so that we can start using monocular depth for everyday image editing tasks, which comes with a need to edit the 3D world that now we have associated with every image. So then we will look at our simple interface that utilizes regular image editing ideas, but allows for intuitive 3D editing. This is a web-based interface that you are all welcome to try. First, let's talk about boosting monocular depth. How do we get to high resolution using our current technology? This was a work by Sebastian and Mahdi from our lab in collaboration with Adobe, with Silvan and Long. What we are doing here is getting this current state of low resolution estimation to this highly scaled, highly detailed, high resolution estimation. To get there, we will first need to understand how we do monocular depth estimation. But since we are in mixed company in this workshop, I will not go into nitty-gritty details of it and give you a higher overview. Then we'll look at some applications of it. Monocular depth estimation is a little bit different than geometry estimation that we are used to from multiple views. When we have multiple views, we have geometry. We can match things, we can figure out by triangulation what is the geometry. But from a single image, we do not have this information. We only have higher level cues that we humans use as well, such as occlusions shown in green here, vanishing lines shown in red, or relative size of objects. These are all very high level things for a network to figure out. It needs to figure out that there are vanishing lines and they represent something in the geometry so that it can start generating the depth of it, for example, which makes it a complex task for the network. And as a result, when we give a complex scene like this to state-of-the-art networks, this is the result that we are able to get. In the last year or two, this result has gotten a little bit better, but it is nowhere near the high resolution or detail-rich state that we want for realistic everyday image editing tasks. Why does this happen? That happens because, first of all, the network has a limited capacity to generate information. If it has to generate the entire complex scene structure, it cannot also generate the details that are associated with it. We go over our information theory limit to be proven. But let's look at how we do actually these tasks in using convolutional neural networks. Convolutional neural networks has something called the receptive field. This comes from the size of the architecture that we are using, and this is typically the resolution that we train our network with. So this is the resolution, for example, that we have available data sets for. In this receptive field, the network is able to see the entire image at once so that it can reason about the furthest away object, the closest object, whatever, at the same time all together. But it is only in the end able to generate a small resolution image. In the current architecture, this resolution is around 300 to 800 square. By the way, we are not yet at a megapixel level. Convolutional neural networks can process images at any resolution, though. But when we increase the resolution of the estimation, now we are not able to show the network everything at once. Since it looks at a simpler scene, a zoomed in scene inside its receptive field, as you can see from the bird, we are able to get more details. But as you see at the top right corner of the result, we are now the network starts to get confused by the lack of information that we are giving it inside this receptive field. Once we make it even larger, the amount of details we get is even much better, but that comes at the cost of the network being confused at many times over in different places due to the lack of information. In this work, this is what we exploit. This is what we use in our favor to get to high resolution estimation by using the same network, a pre-trained existing network, in this case Midas, over and over again many times, and putting the results back together. So the first thing we do, the main thing we do, is double estimation. So we first create two different estimations. Low resolution estimation is at the receptive field size. The network knows where everything is. The network can reason about the entire image globally. So this provides a reliable base or a reliable structure that we want to add the details to. Then we generate another high resolution estimation. This creates a lot of the high resolution details that we are after, but it also creates weird inconsistencies in the geometry, as we are seeing here. The bottom of the tire is at a very far away place, while the top of the tire is close to us. This is incorrect. So we formulate a gradient-based merging algorithm. This is a low-level task that we teach a network to do, so that the details that are generated in the high-resolution estimation is integrated into the structure in this low-resolution estimation. In the end, we are able to add a lot of details without loss in global coherency using a simple low-level image operation. If you are familiar, this is very similar to Poisson blending, but think of it as a smart Poisson blending trained specifically for merging depth images. Once we have this, we usually get a good result, but in detailed scenes, there are still many areas that we can further increase the resolution and hence the details. So this is followed by a local boosting algorithm, where we first select patches in the image and determine at which size the best result will be possible from this patch. And then we do a double estimation for every single patch that we create. So we use the pre-trained network on image patches over and over again, and merge all of them back together one by one to our initial estimation. In the end, we are slowly building up the details inside the scene that we are able to generate. And this allows us to really go to that computational photography enabled space where we can start thinking of editing the geometry of these images. Let's look at some results. You will first see the before our work part, what we are doing at the receptive field size of the network, and then we will look at our results. So these type of very crowded, very complex scenes take a lot of patches to be merged. However, given the complexity of the scene, this type of rich depth information will not only be useful for depth-based image editing applications, but they're also now much more informative for down the stream tasks. For example, this makes depth-based segmentation of an image much more possible, which can actually the depth discontinuities that we are able to get are sharper than most segmentation algorithms. So this is definitely useful for further the down tasks. And there has been recent work from Thorsten Sattler's lab, for example, which makes use of monocular depth estimation to help with multi-view geometric depth estimation as well, because monocular depth estimation is already able to give us a lot of very useful high-level geometric information that we are able to get from the scene through data-driven methods. This also works in artwork, especially if it is a Renaissance artwork where the artists developed their understanding of the 3D scene and the perspective and illumination. We are able to very comfortably generalize to these type of scenes. This image was featured as a best science image of the month last year. And of course, once you have the depth map, there are the geometric applications are already existing in our research field. This is the 3D photography method. This is a video Jiabin Huang shared that uses our algorithm to render this 3D scene from this famous two-dimensional photograph. But I'd like to show you something a little bit more interesting. This is a set of work by Akira Saito, a Japan-based artist that used our single image depth estimations on his artwork. And he takes us to tours inside the imagined worlds, imagined in 2D, discovered in 3D. He used Houdini to generate these results, and I recommend you pay him a visit on Twitter, because he does have very interesting work, not only in depth but in general. But as you can see, very much highly detailed textures and environments, either close by or far away, are now very much possible to render from a single view, even on artwork. This is not even real scene. Which tells us about the power of convolutional neural networks in general. Right now, most things are being done in transformers. It does have a better high-resolution performance. However, transformers do not have the detailed generation capabilities of the CNNs at the highest level. So at the level that we start seeing the low-level problems, their convolutional neural networks generate better details than transformers. What is left for us to do is to merge them or use them together in our formulation. The merging formulation is independent of the architecture. So we also have a repository where you can merge high resolution details from a convolutional neural network to low resolution or base estimation coming from a transformer based architecture, which gets the best of both worlds of CNNs and transformers all together in a single high resolution estimation system. Once we have the high resolution depth, now we are able to do some real 3D photography from 2D images. However, we do not, our estimations are not perfect. They will never be perfect. Even if they were perfect, we want to give the user or the artist new tools to be able to play with the geometry of the scene before creating the 3D representation of it. Currently, we do not have any tools for this. What we use is depth is a grayscale image in the end, So we use standard image editing tools to paint it. But although this is a grayscale image, it has a geometric meaning, and we do not yet have tools that allow us to work with two-dimensional depth images in the 3D world. So this is what we developed in a simple web-based, lightweight web-based interface. This work was led by Obum with Mahesh Mahdi and them. We presented this. We released this very this week, very not long ago, and we presented this as a poster at SIGGRAPH in Vancouver a few months back. Now, this is how our interface looks like. We have a depth-based layer representation where the users can select objects spatially, but also in the 3D depth space by using a simple depth histogram that shows us inside our current view what are the distribution of depth values. So this can already generate very sharp segmentation results, as we are seeing in the selected layer at the top. And it creates a layer-based representation of the scene that is intuitive to work with, because we are working with different depth layers. On top of that, we have an adjustment. We have some adjustment possibilities that may flatten the result or change the 3D location of it. But we are only editing the depth map in this interface. That's the entire goal of it. Once you edit the depth map and you see on our live real-time updated 3D model, once you are happy with it, then you can export your depth map and use it in any 3D down the line test that you would like. So let's see Obum's small demo on how this editing process works. This is an image from our campus. This is our entire group. So as you can see, if there is a region where Obum would like to do an edit, he can select quite accurately sub-regions that correspond to each person, as we are seeing, so that we can flatten the little mistakes done by the algorithm. Then now he is putting the trees in the background to where they are supposed to be. Then we are able to export the image. This was at 6 times speed, but this is essentially the idea. It is a very lightweight and easy to use interface, but the 3D real-time 3D visualization feature and the depth-based selection feature is, I think, will be coming to many common image editors very soon, because this is the type of new interfaces that we are waiting. I don't know how it will look like for the illumination editing, for example, or for segmentation. But this is our first attempt at this type of next generation interface for geometric image editing. So that will be it from me. Our all research is open source. All our tools are shared with everyone for research purposes, and you can find it on my webpage. I guess we still have some time for questions, right?
Yeah, thank you, Yagiz. And yeah, you present very solid methods and very interesting interactive tools. Yeah, we may have time to accept one questions from the audience. And one audience is asking, like, they basically wanted to know the details of the double depth estimation. He wants to know, does the double estimation always go great? Any failing cases for that? Since you mentioned there would be some difficulties for the high resolution estimation, right? So any comment?
Yeah. Well, to make sure that the double estimation process goes well, we are limiting the resolution of the high resolution estimation. We have been overly careful, so that this high resolution estimation is never so bad that we are not able to merge. Merging is an easy operation. It is only gradient based. As long as the high resolution estimation is somewhat stable, it works. So we determine that high resolution by looking at the content. That's the type of details that I didn't go into today. So we analyze the image in terms of edge content and make sure that in any receptive field that falls onto the image, we have close by clues about the depth, so that the network does not fail. We haven't seen it fail. It will fail to generate some of the details. It is just like what the base network is capable of doing. But in terms of stability, we haven't seen it fail in that way. The type of problems that we have with double estimation, and especially the patch-based further merging, is that we start generating some noise, especially in flat regions. This comes as in the form of a very low frequency noise, but when we are trying to do real geometric analysis of the scene, double estimation generates more reliable geometry than patch-based editing, which will be remedied in the future by our follow-up papers, but this is where we are right now.
Yeah, so thank you, yeah, and thanks for attending the panel and also give us such a great talk. Thanks again. Yeah.
Thanks for having me. Thanks for the invitation, though.
Yeah. So let's move to our next speaker, Raffay. Hi, nice to meet you.
Hi.
Yeah. So let me first introduce Raffay. Raffay is a senior principal scientist at Amazon Prime Video and Amazon Studios, where he is the co-founder and the chief scientist of multiple game-changing AI-driven experience across them, such as virtual product placement, global compliance and moderation, immersive sports customer experience, personalized marketing asset generation, and video quality evaluation, which are featured by BBC, Time, MIT Technology Review. And he also contributes a bunch of great top-tier research papers that inspire the community very much. So let's warm welcome Raffay and hand it over to him. And you will have 25 minutes for the presentation and 5 minutes for the Q&A. And friendly notice is like, please disable the annotations for others to avoid unexpected bump.
Sounds good. Just wanted to confirm, can you hear me well?
Sure.
And can you see my screen correctly?
Yeah.
Okay, cool. Thank you. Thanks so much for the invitation and for the kind introduction. So my name is Raffay Hamid. I'm a scientist in Prime Video and Amazon Studio, and I'd like to go over some of the work that we are doing in the space of computer vision and machine learning for long form video understanding and synthesis. So Prime Video obviously serves a lot of different types of video content for our customers, including Amazon Originals. We have a whole bunch of different channels that we offer to our customers as well. Customers can watch ad-supported video on our freebie service, as well as that creators can actually upload content to Prime Video Direct in a self-service manner. And last but not least, we have a growing footprint in the space of live events, especially with the investment in NFL, etc. That's a growing area for us as well. And so given our very wide selection of content as well as global customer base, it is really important for us to invest in AI technologies in order to be able to continually delight our customers in a scalable and efficient manner. Right? So in today's chat, I'll be giving you guys a very high-level overview of some of the stuff that we're doing in long-form video content, particularly in the space of content understanding, as well as content synthesis. And to give you folks a little bit of examples of some of the stuff in content understanding specifically, we're using AI technologies for automatic marketing asset generation at scale, like promos and cover art generation. We're also doing actor tagging at scale in order to provide a lot of information about what are the actors that are appearing in the titles that our customers are watching. We are using AI to ensure that the highest quality video is actually delivered to our customers. Similarly, it's not just the visual information in long form videos, but also audio is extremely important to us. So we're performing a lot of different types of audio analyses as they are powering a whole bunch of different downstream use cases for us. To ensure the customer safety and trust, we are performing large-scale content moderation and compliance in long-form video. And just to present one last example here, we are starting to use AI technologies for optimal video encoding as well. So this is just to give you folks a little bit of flavor of some of the stuff that we're doing in content understanding. Similarly, in the space of content synthesis, we have a big new initiative of virtual product placement. And so how do we insert products into long form videos in a photorealistic way? And that requires us to really rethink how traditional VFX processes are performed in the industry. And I'll speak a little bit about that in a second. Similarly, in the space of live sports, we are trying to use AI to understand what is going on and then synthesize and generate different types of sports visualizations to make our customers more engaged with the content that they're watching. And last but not least, we are using AI to synthesize human speech, human voice in order to create audio descriptions at scale to improve the accessibility of our video content. So this is just a very high level, broad brushstroke of some of the stuff that we are doing in this space. Let me start by double clicking a little bit on the content understanding bits for the next few minutes. So while there are a whole bunch of different technological challenges in the space of content understanding, like modeling and evaluation and large scale deployment, I believe that one key problem that cuts across a lot of different use cases in this space is label acquisition. And there are three key reasons for this. And the first one is that majority of the AI models that we are still using in the industry are still, they require strong supervision through labels. And then, collecting and managing and cleaning these labels is a significant portion of what our scientists do and they spend their time on. And it's a little bit of a decelerant for us. And then I would argue that the long form nature of our content makes the problem of label acquisition and label management even harder than some of the other spaces like text or images. And so as we try to address this problem at scale, we have to keep Prime Video's unique setting in mind. And there are two important parts of that. And the first one is that our video catalog size is very large, right? So we have a lot of long form videos available to us. And then the second key factor is that we have petaflops of compute available to us to use that, right? And so while keeping both these unique aspects in mind, the big question that then becomes for us is, how do we learn effective content representations while requiring minimal number of label data and at the same time making maximal use of the raw videos that are available to us? And so there are the whole bunch of different ways to approach this question. And one of the most promising directions that is coming up in this space is contrastive learning. And so in today's talk, I'm going to spend a little bit of time talking about some of the example applications that we have explored in the space of content, contrastive learning applied for content understanding. And so these three examples are scene boundary detection, which is a very task-specific problem. And then the second area is learning more general purpose representations that can be then applied to achieve state-of-the-art results for a whole variety of downstream tasks. And then the last example that I want to talk a little bit about is cross-modal pre-training for applications like auto-tagging or search and retrievals, etc. So let's chat a bit about scene boundary detection. So before going into any further details, let me concretize a little bit about what I mean by shots and scenes. And so here I'm showing you a few key frames for one movie, Stuart Little. And when I say shot, using this illustrative example, what I mean is a series of frames captured over an uninterrupted span of time. And so here I'm showing you 9 illustrative examples of shots from this movie. And on the other hand, scenes imply a series of shots from a single location capturing a cohesive part of the story. So here I'm showing you 2 example scenes for illustrative purposes. And so just at a very high level, providing you an approach overview. So we start with a current shot in a series of shots that is given to us. And then we look at the temporal neighborhood of our current shot. And based on the other shots in this temporal neighborhood, we select the most similar shot to our current shot. And then we use the current shot as the query shot and the most similar shot in the neighborhood as a positive key. And at the same time, we randomly select multiple shots to be used as negative keys. And then this query shot, positive and negative key shots are then used in a contrastive learning setting in order to learn our shot encoder, which is then fine-tuned as needed to perform a 2-class classification for whenever a scene boundary is happening in a pair of adjacent shots or not. Just want to say a few words about the intuition for positive key selection and why do we think it works. So in contrastive learning, I believe one of the most important things is how are we augmenting our data and then providing it to the contrastive learning algorithm, right? Unless we perform that augmentation correctly, the contrastive learning will not be able to learn the representation that will be effective. And so to illustrate this point, let's take a look at this query shot. If we were to augment this shot using some of the more traditional augmentation schemes that have been used in contrastive learning, like flipping or change of color space, this type of augmentation does not incorporate any contextual information that these shots can have in a scene, right? We could start using the temporal aspect and just pick the previous shot from a current shot or the next shot from a current shot. But as you can see that the appearance of these previous or next shots can be completely unrelated to the current shot, right? And so they really do not provide us any useful information. On the other hand, by making use of the most similar shot within a temporal neighborhood of a current shot, we are able to make use of the underlying structure of the storyline that is already there and is carefully curated by the director or the editorial process. And that allows us to capture the context and appearance of the scene in a meaningful way, which then results into this approach performing effectively in practice. So just a high-level overview of the underlying insight here. I also wanted to share a few results about the types of scene boundaries that this algorithm can detect. So here, for example, is a typical type of a scene change example where the type of scene actually changes, the type of place actually changes, right? So before the scene boundary was detected, you saw the soldiers were throwing some grenades in a swimming pool, whereas after the scene boundary was detected, now you're in a completely different setting. Similarly, another common example of scene boundary is like the same actor can be in different contexts. So here, before the scene boundary, one actor is talking to a particular actor, whereas in the second scene, the same actor is talking to a completely different actor and is in a completely different setting. So here again is a pretty common example of the types of scene changes that happen in long form videos. And lastly, there are different types of genres where the narrative is quite continuous. So for example, in documentary settings especially, the narrative can be quite continuous. And as you can see in this example, before the scene boundary, even though the entire content is within a hospital setting, before the scene boundary, the couple is talking to each other and is looking a little bit worried, whereas after the scene boundary, we see a nurse walking down the hallway, which is clearly a quite different scene. So just very high level overview of some of the context where this type of algorithm works successfully. And so, you're welcome to find more details for this work in our CVPR 2021 paper, where you'll find a lot more qualitative and quantitative results for this approach. Moving on to the general purpose representation learning for a wide variety of downstream tasks. The main motivation of this type of work is, again, we've seen works like clip and align perform actually quite well for a whole variety of downstream tasks in a zero-shot setting. And so our goal is, how do we actually be able to do that for long-form videos? And the key challenge, just like I mentioned in scene boundary detection, again, what is the right type of data augmentation scheme that we can apply that works for the long-form videos, right? And the intuition that this work comes in with is that we want to use available movie-level information like genre or synopsis or co-watch as means for data augmentation to learn a generalizable scene-level representation. And what I mean by that a little bit, to provide you an approach overview for this method, we start with like a sort of movie-level similarity. And like, for example, you can use co-watch information or you can use genre information to select pairs of movies that are thematically similar to each other, that are overall sort of similar to each other. And then with this type of information, we automatically select pairs of similar scenes in order to then learn a scene encoder through contrastive learning. And then this representation, this scene level representation, is then fine-tuned to then perform different types of downstream tasks, for example, place tagging, year prediction, et cetera, et cetera. And the key point I want to mention here is that the movie level information is at a very coarse level, which is like around 120 minutes, whereas the scene level representation that we are learning is at a much more temporally fine-grained level, which is around 2 minutes, which is quite interesting. So we have actually I wanted to share some example similar scene pairs that this method is able to find. And as you will see, so I'm showing you two different movies. On the left is Need for Speed, and on the right is Fast and Furious, and these are considered similar based on the title level or the movie level similarity metric that we're using. And as you can see that like these two scenes that the algorithm finds very similar based on its learning, they are, from an appearance-based perspective, they're actually very different from each other. But from a thematic perspective, they are actually very, very relevant to each other. They're both showing scenes of a car chase, right? And so just to show you another example of the similar phenomenon, here I'm showing you again, left Need for Speed, right Fast and Furious, two pairs, a pair of scenes which is considered very similar to each other, and both of them have two actors speaking to each other within a car, right? And then lastly, from again same pair of movies, on the left we are showing a scene where a bunch of people are talking, just like on the right, in sort of a calm setting, right? And so this shows that by using this title level information, you're able to effectively learn scene representation that actually does give you meaningful and relevant results. We've actually tried this approach on 14 downstream tasks, and it does provide us with state-of-the-art results on all of those 14 downstream tasks. So it seems to be quite effective. And then lastly, wanted to say a few more words about sort of cross-modal pre-training for things like auto tagging and search and retrieval. So, previous approaches in sort of cross-modal representation learning, like CLIP, they basically, try to minimize the distance between images and their corresponding text pairs while maximizing the distance of all other pairwise relationships that you may have. And while they have been extremely successful, they still suffer from two important challenges. And one of them is data inefficiency, and the other is the compute inefficiency, right? And so there are two key reasons for these challenges. And the first one is that as you build your data by sort of crawling the web, there can be a lot of noisy and inaccurate captions that you may capture. So here, for example, I'm showing you one caption, which is actually a file name, right? Which is clearly incorrect. And then the second main reason for this challenge is like there are many correspondences that are not being modeled as efficiently and as effectively as they could be, which basically results in not modeling the semantic similarity between negatives correctly, right? And so we address these two key challenges by instead predicting soft alignments to capture the similarity between the negatives in a more effective way. And so basically our work uses self-distillation, knowledge distillation. And as you may recall that in traditional knowledge distillation methods, we have teacher model that makes some predictions that are then used by the student models. And one of the costs that we pay in traditional knowledge distillation methods is that we have two different models, one for teacher and one for student, right? And that can result in both memory as well as computational cost. And in order to avoid that, we propose a self-distillation method in a cross-modal setting where the same model is used as a teacher as well as the student. And so basically the self-distillation part of our loss progressively increases as we go through the process of training. And effectively that means that our student effectively becomes its own teacher. And just to give one sort of canonical example of what type of an actual difference does it result in, here I'm showing you one query of a cat lying on top of a chair in the living room. And so if you look at the top results retrieved by the clip method, you would see that while these results capture the chair and the living room part of the query very accurately, the cat part of the query is completely missed, right? Whereas if you look at the results from our method, you would be able to see that all the three key parts of the query are actually represented very effectively, which is just to give you sort of a high level understanding of like what types of result differences would you see from a qualitative perspective. And again, you can see, you can find a lot of quantitative and more qualitative results in our CVPR 2022 paper on this topic. So that sort of concludes my very high level overview of some of the stuff that we are doing in the space of content understanding. Moving on to content synthesis, I would say that a lot of the work that we are doing requires using some type of visual special effects. But the problem with visual special effects is that a lot of the workflows are extremely manual, and so they really cannot be scaled to the level that we want them to be scaled, right? And so there is a whole bunch of different types of processes that go on in traditional VFX pipeline, like match move, geo, rotoscoping, etc. I want to focus specifically on match move, which essentially is about tracking the camera that was used to sort of capture a scene. And so in order to automate this process, folks, one way to do that is to use traditional structure for motion approaches that can perform, that can track the camera and at the same time extract the 3D structure of the scene. The challenge is, however, that unlike previous sort of domains where SFM has been used, where you have a lot of parallax present, in studio produced content, you actually you have very small amount of parallax. And that's intentional actually, because we want to not shake up the camera too much, and we don't, so that we can have a negative experience to our viewer, right? And so in order to overcome that problem, because traditional SFM methods don't end up working for studio produced content as well. So in this work, we have proposed to use sort of monocular dense depth estimators as a prior, in order to then be able to use more traditional SFM methods in a more effective way. And here you're seeing some sort of example shots that I'm showing, where on top we have the input, and bottom left we have the estimated depth of the depth of the point cloud, and on the right we're showing the sort of the camera motion and point cloud sort of in a joint way. And then you can start using these types of technologies to then perform completely automated hands-free match move for different types of cinematic content. And here you can see that you have shots where you have very limited kind of motion, all the way to shots where you have very sort of purely zoom in motion. And for all these different types of shots, and this approach is working quite effectively. And then with this information, you can start inserting more complex models in the scene. So here I'm showing you one kind of bottle. Here I'm showing you two, and then you can start having multiple sort of objects inserted in the scene that kind of start looking more photorealistic and without any jitter, etc. In the results. And so again, in the interest of time, I won't be able to go into any details here, but you're very welcome to find more details about this work in our CVBR 2022 paper on this work. And just like for sort of studio produced content, we're finding the correspondence between the scene and the camera is really important. So is the case for the space of sports, right? And here I would argue that the problem is a little bit more limited, because generally the broadcast camera is actually standing on some sort of a tripod, and it generally demonstrates pan, tilt, and zoom degrees of freedom. And so again, registering how the sports field is appearing as the camera pans, tilts, or zooms as the game process progresses is extremely important. And so we've done some work where we are using both sparse features prediction as well as dense feature prediction in order to then combine them to be able to register sports field quite accurately. And then here I'm showing you an example result of this type of an approach where once the field registration is done, we're actually back projecting the model of the field of the American football field back to the appearance of the field as it appears in the broadcast camera. And as you can see that the lines of the model are aligning almost perfectly with the corresponding lines on the field itself, which shows that the method is working quite accurately. And on the right side, I'm showing you the field of view, which was captured by the broadcast camera at a particular instant in time. And this type of a method does not only work for sort of American football, but we've actually tried it for US Tier 1, top 5 US Tier 1 sports like soccer, ice hockey, basketball, tennis, and it works quite effectively in real time. And once you have this type of information available to you, like, once you're able to register the field to the camera, then you can start thinking about a lot of kind of useful sports visualization experiences for our customers, right? So here, for example, I'm showing you a video where the notion of yards to go, which is an important quantity in American football, in a particular play is displayed in real time. And as you can see that, at 30, the yards to go is around 70. And as the player moves towards the left, at 40, it's about 60, at 50, it's about 50, and so on and so forth. It's actually performing quite accurately. And along similar lines, you can start imagining other types of use cases, like, for any play in soccer, what was the total distance traveled by the player who was actually leading an attack, for example, on the opposing team? And at the same time, sort of what was the instantaneous speed? So here you can see that, like, the instantaneous speed of this particular player went all the way to 11 meters per second, which is quite astounding. And offering our customers these type of insights makes them better aware of exactly what's going on. And then you don't have to limit yourself to sort of use cases that revolve around a single player, right? You can actually start extending them to use cases that have multiple players. Like, for example, in soccer, a very important foul is offside foul. And here we are showing a virtual offside line where at the time that the player actually passes the ball to the second to last defense player, they are actually beyond the virtual offside line, which essentially helps the viewer understand exactly what's going on. And this type of a particular use case is even more informative for audiences of countries that are not as sort of experienced in understanding the nuances of soccer, etc. And so again, you can find a lot more details about this work in our WACV 2021 paper. So this was a very high level, broad brushstroke overview of some of the works that we are doing, both in the space of kind of content understanding as well as content synthesis. And I hope this gives you some understanding of the exciting directions that we are pursuing, and lots more to come. So yeah, happy to take questions at this point.
Yeah, thanks, Raffay, for giving such a comprehensive and great keynote. And I see the attendees, the participants, are quite excited about the speech, and they raised up a lot of questions. The first question I think is about like they really admire the resources that Amazon Prime could have, and they wanted to know like whether they could also access such kind of data at such a large scale.
Yeah, that's a great question. So, obviously, as active member of the research community, we want to sort of contribute to that space. And we have started to do that, Anyi, as some of you may already know, that for our depth-guided structure for motion work, we have actually publicly released the data on GitHub. And if you guys haven't checked it out, please check it out. So yeah, there is a lot of internal conversations that are going on in order to do that. How do we do that in the best way? Because obviously there are copyright related challenges that we have to face, right? And so we want to do it in the right way. We want to do it kind of in a way that is helpful and acceptable to all parties that are concerned. I just want to assure everyone that we are working hard on that, and hopefully we'll be able to kind of cover more ground in the next few months.
Yeah, that's very nice. And then another question comes out from the application side. He is interested about the potential application of thin segments and short segments.
Yep. That's a very, very important question. Yeah. So there are a whole plethora of applications for scene segments and short segments. Let me focus a little bit more on the scene segments. So the work that we did was primarily for ad cue point detection, right? So when you're trying to insert traditional video ads in long form videos, we want to minimize how disruptive they may be to our customers. So we want to maximize the experience quality for our customers. In other words, we don't want to insert ads at places that are within a scene, or at places where two people are talking and are in the middle of a conversation, and now you're showing us a video ad, right? That's not the experience that we are aiming for, right? So in order to figure out what are the optimal places where we want to insert these types of traditional video ads for freebie, for our freebie service, right? So that's actually where the whole work started. But you can imagine there are many other downstream applications, especially like video summarization and sort of marketing asset generation, etc. So there's at least half a dozen more applications that can make use of the scene boundary detection information.
Yeah, and I also personally subscribed to the Amazon Prime Video, and I love those functions like the tagging, yeah. And then another question comes from like is interested about like in the recent times we started to talking about long form videos. So what in your opinion, so what are the tasks and applications that truly need long form video reasoning?
That's a very, very good question, actually. So I'll yeah, even so the long form video space is unique in my opinion in two ways, right? The first is that a lot of the long form video content that we have are studio produced almost by definition. And so that means that there is an underlying story narrative, right? There's a story arc there, right? And so previous, as you guys know very well, a lot of the previous work in video understanding has focused on sort of, non-studio produced content. So that's one part of novelty. And that means that a lot, even if we are doing learning at a shorter temporal scale, like frame-based or short-based or scene-based or clip-based, etc., there are certain challenges that are still novel and very exciting. But going back to the specific question, I think if you start thinking about problems like video summarization, right? The long form aspect brings a whole new flavor to on the table, right? We have to be very, very aware of very long duration dependencies. We have to be very aware of what does it mean to be a spoiler and how do we avoid those types of things, right? And I would argue even beyond that, right? I would say that for TV series, right? It's actually far more than 2 hours or 3 hours or whatever, right? You could have like, I don't know, 24 episodes, each around 30 minutes long, right? So in some sense, the long form nature of it can exceed to like maybe 12 hours or so, right? So that completely changes the conversation when it comes to how do we capture and model long form dependencies. And these days, like transformers are all the rage. And, as you know, there's a lot of ongoing works going on, and that's a completely unsolved that's a lot more progress needs to be made in that direction. So that are some of the ways in which the long form aspect brings its unique flavor to the table.
And in this sense, and it also means like the multimodality understanding is also very critical, right?
Thanks for reminding me, Anyi. Absolutely. Could not agree more. Yeah. So, and just to be clear, like multimodality here, it's the heterogeneity of multimodality is actually higher than how we have seen it in the past. So audio and visual modalities are obviously very important. And then, a small leap forward is text, so to speak, from a conceptual perspective. But I would argue that there is a lot of sort of discrete information that is provided by the providers like genre, subgenre, overall mood, etc. Those should be considered within the space of multimodality. And lastly, on IMDb TV, right? Like you have reviews, you have synopsis. So there's a whole set of multimodality that we have to incorporate in a kind of a more of a consolidated way. I don't think that has been looked at in the past, just because long form cinematic content was not as much explored in the past. Yeah.
Maybe one comment here. Like I was thinking, like, so I guess like for language, for instance, we have a clear definitions of the atoms, right? Of the like at least the written language, right? So we know each word has a meaning. But in video, and especially in long form video, I don't think we have get to the point where we know what is the atom, what is the minimal unit we should use for like analyzing and understanding long form video, right? We may use the shot, but even within a single shot, there may be a lot of things. There may be sub tokens within that shot, right? So is there something you think like we should look at, or like we should do research in that space, trying to come out with those tokens, or simply uniform sampling across these long form videos and try to come out with the tokens from the model would work?
Yeah, it's a great point. A very, very keen observation. I think, yes, as you know, very well know, like right now, the sort of the default atom that we are using, atom of information, or just a unit of content that we are using in a lot of these types of works, both at Prime Video and in general, is short, right? But as you correctly pointed out, there can be a lot of nuances within a short, right? And I think that here, there is a huge opportunity for us to learn in a data-driven way. Right? We don't want to overcommit to shorts, but we also definitely don't want to commit to frames, because without learning how does the importance of one frame vary from another. I think it's an open question. I'm not aware of. Please help me get better educated if you guys are aware of some of these works. But I think I'm starting to see some initial work in that direction. But the long form aspect of that is still sort of not as at the scale that we want it to be for actual cinematic content, right? Yeah.
Yeah.
Thanks.
Yeah. I think one interesting perspective is like you mentioned, like we have shot, we have scene, right? But like in history, people talk about like story understanding, right? So in terms of like long form content, do you have any perspective on, for example, what kind of story, right, we should be focusing on, right, to understand, really understand the movie content, right? For example, some people, they say, if I can generate the movie, right, for example, generate the plot, generate the story of the movie, so that means I really understand the long content, right, in the multimodality way, right? The kind of like you said, this is an open question, but I want to see if you have some perspective on.
Yeah, that's a great question, Dong. I think that there are 1.5 points I'd like to make. So I guess one point is that the first problem that comes to my mind, which could be very relevant to the direction that you're alluding towards, is summarization. And so I would argue that a great summary of a long form title or a long form movie, or a movie, let's say, would be able to capture this underlying narrative or storyline that you're alluding towards, right? And so a promising direction could be, can we make use of some, there's a whole bunch of different efforts that are going on in the summarization space. Can we kind of make use of a lot of that body of work to be able to get to what it means to extract storyline from long form video? I would also say that I think that NLP and NLU is really kind of ahead of the curve, in my opinion, in this space. The vision language models and the lot of action that we are seeing there gives me hope that we would be able to make use of all the great work that has been done in the NLP space for summarization to then bring it over specifically for the long form content understanding space. But I think that, yeah, it's a critical problem. Without getting there, I don't think we would have really achieved long form video understanding, because that's a defining unique aspect of this space. And I think a lot more work needs to be done. Yeah, definitely.
Yeah, I think it's time to redefine some critical research problems in this domain. Cool.
Yeah, so I think thanks again for Raffay giving such a great talk and answer our questions. So thank you.
Thanks for inviting me. Thank you.
Yeah, so then I will hand it over to Fabian and give a final remark.
All right. Okay, so I think we're good to go. So, all right, so I think we get to the end of the workshop. So really thank you all for staying with us today on a Sunday. And also like people who will be watching the workshop afterwards, like thank you for watching the entire workshop. Yeah, so I just wanna do some departing words here for the workshop. I will be also announcing some prize winners from the papers we have received in the workshop. Yeah, so let me start by just thanking the organizers, like all of us, like who actually meet months in advance to prepare this workshop. It has been a lot of work, so thank you all for your hard work and making this happen. Thank you to all the participants as well, the speakers, and the participants from the panel discussion. Thank you. This has been great because of you. And also, we need to thank our program committee who helped us review the papers and come up with decisions and give feedback to the authors, which is the most important thing. Is actually they wrote reviews that were insightful and did help the authors to get better papers at the end. So thank you for contributing your time to the reviewing process. And this is probably the nice expected part of the workshop is like we will be announcing 2 different prizes. So the first one is gonna be the best paper award. And this is basically based on the reviews we received. So we analyze all the reviews, we analyze the relevance of the papers and the scores, the papers reviewed during the review process, and then we select the one with highest scores. And the winner is the paper called Text-Driven Stylization of Video Objects by Sebastian. I don't know if Sebastian, if you're here, but congratulations. Amazing work. I think reviewers like it, like the program committee also like it a lot. So congratulations on you winning the best paper award for the workshop. And the second is also a prize that were given based on the audience votes. So basically we gave the opportunity to the audience to choose which one of the presentations we had today in terms of papers was the best one, like student presentations, like which one was the best. And then we received in total, I think 14 votes. And the winner is the diffusion models for video prediction and infilling. So this was presented by Tobias. Congratulations, Tobias. Yeah, so I think the audience speak by themselves. So you did a great job presenting this work. So with that, I guess like we get to the end of the workshop. Thanks again for attending the workshop today on a Sunday. Like please keep engaging with us in our Twitter account. It's there, like Twitter at CVEU-workshop. And then also visit our website. We probably will be posting there more updates about the workshop, but our speakers. Our goal is basically keep engaging this community further. Hopefully we can see each other again next year. So stay tuned. So we will announce news soon about it. But yeah, so thank you all for coming. And the recording of this entire workshop will be available on YouTube at some point later in the future, because we're gonna wait until ECCV happens to release the full recording. So thank you all for attending, and yeah, have a nice rest of Sunday. Take care. Bye-bye.
Okay. Thank you, everybody.
Thank you.
Thank you, everybody, for coming.
Thanks.
So I will stop the recording.